Hello guys, Spark Poly here, and welcome to the Learn How to Create a Third-Person Pirate Shooter Game inside of Unreal Engine 5 beginner tutorial. In this full course, I will show you from start to finish how to create this third-person pirate tower defense game inside of Unreal Engine 5. I will walk you step by step through this course, and we will create this exact game that you see here from complete scratch. And the game that we create in this course is a third-person tower defense game where you're playing as this pirate character, and you must defend your tower against the different waves of pirate skeletons that will spawn in. As a player, at the start of every round, you will have to purchase different items to help defend your tower against the different waves. Things like explosive barrels, cannon turrets that will fire cannonballs on the skeletons. These items the player will be able to purchase and place down to help set up their defenses, and each skeleton that you kill has a chance of spawning in these coin crates that the player can collect to add more coins and buy and upgrade their defenses. And once the player survives all the remaining waves, they win the game. In this full course, I will show you how to create this third-person tower defense game from complete scratch. We will create everything that you see in this video, and this video has timestamps and is organized into 15 to 20 minute lectures. I will start by showing you how to import a custom pirate character model, how to set up the custom character using some animations that we import into the engine. I will explain everything along the way so you don't have to worry if you're a complete beginner, and we will set up the character with some basic weapon logic. So we'll give the character a basic weapon. We'll set up the enemy skeleton AI and all the blueprint that will feature this high quality enemy character. We'll set up all the behavior for the enemy AI so that it will chase the player if it sees the player. We'll also give it the ability to attack and damage the player. We will also add things like health and health bars to our player and skeleton, and set up the death events so that the skeleton will explode or ragdoll when killed. Once we have our basic enemy AI set up, we will also set up the tower defense blueprint that our player will have to defend. The tower will have a basic health widget so that we can see how much health our tower has, and the player will have to kill all the skeletons to progress to the next wave. We will create all of the waves based logic and handle spawning skeletons for each wave, and spawn in more skeletons every single wave to increase the difficulty level. And once we set up the basic game mode logic, we will add two different items that the player can buy and place down. So the first item that we'll add will be an explosive barrel that the player can shoot and do an AoE damage and kill multiple skeletons at the same time. The second item that we'll add is a cannon turret that the player can buy and place down, and basically the cannon turret will auto lock on any enemy skeleton and blast them away with a cannonball. Once we create these two items, we'll create a buy menu widget that the player can open up at the start of every round and purchase and place these items down into the level. Once we finish creating all this gameplay logic, I will show you how to create this custom island level for our game. We will start by creating a simple landscape and adding an ocean water body. We'll create different islands, and we'll download some free pirate assets and high quality 3D models to start building and designing our level. I will show you how to design our level, how to add various different assets, how to modify their collision, their pivot points, how to do things like paint trees, rocks, foliage, and much more. I will also show you how to download free 3D materials from Quixel Bridge, and how to create a very simple landscape material so that we can create this high quality sand and wet sand effect. Once we finish creating our shipwreck level, we will go ahead and create another level called our main menu level. The main menu level will feature a custom main menu widget. The main menu widget features things like a simple graphics options menu where you can change the graphics quality of your game, and it also features a very nice level selection widget where the player can select what level they want to play, and this widget will allow you to add multiple levels to your game if you wanted to create additional levels in the future. I will show you how to create all of these menu widgets and how you can implement level selection so you can open up any levels you'd like. And then finally, at the very end of this video, I'll show you how to implement things like controller input support so you can play the game using a controller. All the widgets and the inputs will be set up for controller. And finally, we'll package the game for Windows and PC devices. So I'll show you how to set all the default maps, all the settings, and how to finally package your game into an exe file that you can play, send to your friends, they can play the game as well, or test it on another computer. If you guys enjoy this full course, make sure you hit the like button and consider subscribing, as I will be uploading more full courses like this on my channel. It takes a lot of time and effort to create these big videos, to put in the time to developing, editing, recording, everything that goes into making this video. So again, make sure that you hit the like button, consider subscribing, and also leave a comment down below on what type of game I should make a video on next. Let me know in the comments down below. Now, if you guys do not want to watch this full course and say you just want to download the completed project or the source file files. I will be selling the complete project on my Gumroad, so I'll leave a link to it in the description below if you just want to save yourself the time and you just want to purchase the complete project source code. Check the description where I'll leave a link to my Gumroad page. Also, before we get into the video, if you guys genuinely want to know what it takes to create an open world game inside of Unreal Engine 5, I have a complete multiplayer survival game course. This course has over 70 hours of course content, and it teaches you skills and things that you cannot fit into a simple YouTube video. There is no other course like this on the internet that will show you from scratch, step by step, how to create a multiplayer Steam survival game inside of Unreal Engine 5. You will learn how to create a drag and drop inventory system, a crafting system where you can craft all sorts of different items, a harvesting system where you can chop down trees, you can mine rocks and pick bushes. We create an open world map that features a swimmable ocean, lakes, rivers, mountains, and much more. We create a procedural spawning AI system, a base building system and raiding system, and we add Steam voice chat, player tribes, and so much more. This course has over 250 lectures which spans over 20 chapters and over 70 plus hours of course content. So check out the multiplayer survival game course bundle on my website smartpoly.teachable.com and make sure you pick up the course before I raise the price of the bundle later on. I also have another course you guys can check out. It shows you how to make a cross-platform mobile game inside of Unreal Engine 5. It features a simple prop hunt game that is multiplayer. You guys can check it out on my website, and if you purchase my survival game course, you can actually get it bundled with the purchase when you add it to your cart and check out. So check out my course on my website smartpoly.teachable.com. I'll leave a link to it in the description below. And without further ado, let's get right into the video. Hello and welcome to the Unreal Engine 5 third-person pirate tower defense game course. I want to set some expectations for this course. First and foremost, this is a beginner's course. However, I will not be showing how to download and install Unreal Engine 5 in this course, nor will I be showing or explaining the basic controls or user interface of the engine. I expect you to, by the least, have Unreal Engine 5 downloaded and installed, and at least know some of the basic controls and user interface. If you do not have Unreal Engine downloaded, and if you are not familiar with the basic user interface, I recommend you watch my complete beginner's tutorial, as this shows you how to download and install Unreal Engine 5 and it explains in great depth the user interface for a complete beginner. The second thing is I will be showing how to create everything in Blueprint, which is Unreal Engine's visual scripting system. It allows anyone to make games inside of Unreal Engine without having to type a single line of code or without having to know how to write code. In this course, I will not be explaining the basics of Blueprint. I will show you step by step how to do everything, as well as explain the basic logic behind the blueprint that we create. However, if you are just a complete beginner to blueprints and if you have no idea what blueprints are, I suggest that you pause this video and go watch my Blueprint for Beginners tutorial, as this video will explain what are blueprints and everything that you need to know as a complete beginner. Now, with all of that out of the way, I can safely assume that you have at least Unreal Engine 5 installed, you have some basic knowledge of the user interface and the basic controls, and you also have some basic knowledge of Blueprint. And so we can go ahead and begin with this course. So the first thing that we're going to do is we're going to go ahead and launch Unreal Engine 5.4.3. So go ahead and click on launch from the Epic Games Launcher to launch Unreal Engine. And once the Unreal Engine project browser is loaded up, we can go ahead and create a new project. So we're going to choose the games template over here. And for the game template that we're going to pick, we're going to pick on the third-person games template. And these are my settings. I have it set to Blueprint, Target Platform Desktop, Quality Preset Maximum. And we can go ahead and just rename our project. I'm going to go ahead and give this name of the Pirate Game Tutorial for my project. You can name it according to whatever name you want. Then we can go ahead and just click the Create button. So that will go ahead and create the project and launch Unreal Engine. And now you can see our project is open up. So if we hit the play button on here, you can see that we have a very simple third-person character template. So this is the character that we're going to modify. So as we hit play, we have a character. We can run around, jump around, and move around using the basic controls, WASD, spacebar to jump. We're going to take that character and modify it to add our own custom character, essentially our pirate character. And we're also going to take some custom animations and create our own animation blueprint so we can see our pirate character animated and walking in our level. So let's go ahead and get started. So first thing that we'll need to do is we'll need to download the pirate character model. So for that, you'll need to open up the Epic Games launcher and head over to the Marketplace tab. And under the products, you want to search for pirate and filter this by free. So click on max price and filter by free products. And you should see this free pirate character. Go ahead and click on this. And this is the character that comes included. As you can see, it has different types of outfits, as well as a couple of different weapons. All you have to do is click on add to project. And you want to make sure that you click this show all projects button and search for your pirate game tutorial. And now that you see it in here, if you are following this tutorial in a future version of the engine, if you do not see a project here, you want to click on show all projects. And if there's a red message that says the asset is not compatible, you have to click on the little drop down right there and select the most recent compatible version. Once you do that, it should allow you to select your project, and you can just click add to project. That will go ahead and download the model and add it to your project like so. So in our content folder, in our content browser, we should have a new folder for pirate. So if you double click on this, you can see that we have a couple of different folders in here for the character mesh. So we can go to the mesh UV4 and we have full, and as you can see, there's a full pirate mesh character. So there's 3 different variations. We can open up the SK Pirate Full 01. And so this is the character mesh that we're going to be using for the course. As you can see, this character model has quite a bit of detail as well as some cloth simulation on the waist cape right here. But as you can see, we're going to use this model for the duration of our game. So we're going to actually close out of there. And we'll need to go ahead and set this character model in our character blueprint. So first things first, let's go ahead and organize our project files. So we'll need to go to our content folder, and in here we can right click and create a new folder and name this core. This will be our core assets. So we can right click this folder and set a color. Give this folder a color of maybe a red, dark red color, something like that. Just so that stands out to us, because this will be where we store all of our game assets. So in here, we can go into our core folder, and we're going to right click and create a new folder and name this to our blueprints. And this is where we'll store all of our blueprints for our game. Double click and open that up. And we need to go ahead and drag in our character blueprint. So if you go to the third person folder down here, you should have a folder for blueprints, and we should have this third person character blueprint. So this third person character blueprint is the character that we saw in this level when we hit play. This is the character blueprint that controls everything that we see in the level, the character that can run around and jump around and all that. We'll need to take this character and drag it and drop it into the blueprints folder, and we should see the option to move here or copy here. And we actually want to just move here, so we'll click move here. That will move it into our core blueprints folder, and that's exactly where we want it. So we're going to keep all of our blueprints and everything organized in this folder. So now that we have that moved into that folder, you can actually double click and open this up. And whenever we open up a new window, we actually want to dock it here at the top. So you can take the window and dock it here at the top, so you can switch between the character blueprint and the third person map. Now also, I'm going to change the setting in my project. So if you go to edit, and we should have under the editor preferences, I want to change the setting so it'll automatically dock our windows here at the top. So if you go to your editor preferences under the asset editor open location, you can set this from default to main window. And now that you have that set, whenever you open up a new asset like this blueprint, we'll automatically dock it here at the top. So you can switch back between the level and the blueprint. So this is the character blueprint, the BP third person character. So as you can see, we actually have a couple of different tabs in here, but we have the event graph, which has all the logic for the character. Things like the camera input, the movement input, the jump input. So you can navigate in this graph by holding the right mouse button to pan around and scroll in and out to zoom in and out. We have these different tabs here at the top, which we have the viewport, which if you click on the viewport, you can see this is what the character is made of. We have things like the character mesh, the camera, and the capsule collision. So in our case, what we want to do is we want to switch out this character mesh with the pirate character mesh that we downloaded from the Unreal Engine Marketplace. So the way that we can do that is we can select this character mesh, and in the details panel, you're going to see different details about the different components that you have selected. So currently we have the mesh component selected. And since we have that selected, we can see various different details about that mesh, things like the location, the rotation, the scale. But more importantly, we can see the actual mesh asset. So over here, this is the actual asset that is set for our character mesh. As you can see, it's set to this SKM Twin Simple. But if we hit this drop down, we can select what character mesh we want to use other than the current one that we have. So in our case, we want to set the SKM pirate underscore full underscore 01, which is that character mesh that we saw earlier. So if we select that, you can see that we now have our character mesh swapped out. It's actually automatically playing the animations that we previously had set up. So to save this and actually test this out, whenever you make any changes inside of a blueprint, you want to come over to this compile button. You want to hit on the compile button. So we'll change from that yellow to a green icon and just click the save. Then we can go back to our third person level and hit play. And now you see that we swapped out our character mesh. And we have our basic pirate character who can actually just run around. We have the jump, everything set up. And you can see that it automatically works because these are using the same skeletons. So the animations will work flawless, as you can see here. Sometimes not all character meshes will automatically work with the default animations. So note that this will not always be the case. So we created our project. We've downloaded a pirate character. We've organized our project assets, and we set the default character mesh to this pirate character. Next up, what we need to do is we need to set up our own custom animations. So currently, if we hit the play, you can see that we set up our simple pirate character, and we're just using the default animations, which is great and all, but what we need is some locomotion as well as a pistol idle animation so that we can hold our little pistol weapon that the pirate character has. And when we strafe left and right, the character will strafe left and right, as well as an aim offset. So depending on where the character is looking, the character will rotate his body, sort of like aiming where the camera is pointed at. So we'll need to go ahead and import some custom animations and set everything up. So if you're watching this tutorial on YouTube, you want to head over to the description of this video to download the project files. But essentially, you should see this pirategame.zip file. Once you have it downloaded, you just right click and extract all, and that will give you the extracted file, which is this pirate game folder, which includes animations, meshes, a couple of other different things. So what we're interested in right now is the animations folder. So double click on the animations, and in our core folder, you want to go back to the core. And in the core folder, you want to right click and create a new folder and name this to animations. And just double click and open this up. And in our animations folder, you can see that we have a couple of different animations. We have the fire and locomotion. So we'll set up the locomotion first. So we need to right click and create a new folder in our animations. Name this locomotion. And just double click and open this up. And in here, we can open up the locomotion. And we have all the following animations. So just drag and select all of these and drag and drop them into your content browser in our locomotion folder. And what you should automatically see is this FBX import options window pop up automatically, which will basically ask us to choose a skeleton or essentially a character to import these animations to. So it's going to ask us to choose a skeleton. So if you click on this none, it'll have the drop down. And we want to look for our pirate skeleton. So down here at the very bottom, it says UE4 mannequin skeleton. But if you look at the details, you can see that the path is our pirate folder, comes from our pirate folder. So this is the skeleton for our pirate character. So we're going to select this skeleton. Now I'm not going to click on any of the other settings. These are all the settings. I'll leave them as the defaults. But I'll click the import all. Now we'll go ahead and import all of the animations. So now that we're back in our project, you can do a file save all to save all of our animations that we just imported. But now you should see all of the following animations, things like our jog forward, idle, and everything. So we can just open up a idle animation, and you can see we have this character holding sort of like a pistol weapon in their hand. And this is what we'll use for our animations. We also have a couple of different locomotion animations. So you see we have jog forward, jog left, jog right. So we'll use this to set up our directional locomotion. So first up, what we'll need to set up is a blend space, which allows us to blend between one or more animations. So it allows us to take things like our idle animation and blend it with our running forward animation. So in our animations folder, you want to go back out to the animations and right click. We're going to create an animation asset. So you want to head over to the animation asset and we want to select on this blend space right here. That will create a blend space. Now it's going to ask us to first pick a skeleton. And because we imported all the animations onto that pirate skeleton, we're going to be using this UE4 mannequin skeleton. Again, this is the one associated with our pirate character. So it's important to choose the same skeleton as the one we're using the animations with. So select that, and we'll go ahead and add the asset. So we just need to go ahead and rename this to our blend space underscore locomotion, and just file save all. And we can go ahead and double click and open this up. And so in here, we'll need to set up our basic locomotion. But if this is your first time opening up a blend space asset, essentially all you need to know is that in the center of your screen is the viewport, where you can move your mouse cursor around by holding the right mouse button or navigate using the WASD to move. Now on the bottom of the screen, we have this graph, which has two different axes. We have the horizontal axis and the vertical axis. And then on the right, bottom right, we have this asset browser, which shows us all of the animations associated with this character. So you can see we have things like our idle animation, jog forward, and much more. Now over here on the left, we have the asset details, which allows us to set things like our axis settings and much more other different settings. So what we'll need to set up is our graph down here. So to modify our graph, we'll need to go to the axis settings over here and first expand this horizontal axis. So under the horizontal axis, we'll need to give this a name. So under the name, we can select this and name this to direction, because this will be the direction of where the character is moving. And once we've named that horizontal axis, you'll see down here on the bottom, we'll rename it. We want to give the horizontal axis a minimum and maximum value. So for this minimum value, we'll change this to -180. And for the maximum value, we'll change this to +180. So if we save that, you can see now in the bottom on the horizontal axis, we have our center, which is a value of 0. And we have our minimum value, which is -180. And over here on the right, the maximum value, which is +180. Now, lastly, we'll need to change the grid divisions. So we want to change this from 4 to 8. And then we'll add more grid divisions to drag and drop our animations onto. Now we'll also need to set this to wrap input, and that will be all the settings that we'll need to set for our horizontal axis. Next up, we need to set the vertical axis, so expand the vertical axis. Let's scroll down, and for the name, we'll rename this to speed. So this will be the speed or how fast the character is moving. The minimum value will be 0, and the maximum value we'll set to 600. As for the grid divisions, we'll leave that as 4. And then lastly, we'll just click wrap input. So now that we set up our vertical axis, you can see our vertical axis down here on the graph is renamed. Speed has a default value, a minimum value of 0, and a maximum value of 600. So essentially the blend space will blend between the speed and direction. It will pick, based on the character's speed and direction, what animation to play. So now in our asset browser, we can start taking different animations and dragging and dropping it onto our grid to start blending between different animations. So that's exactly what the blend space allows you to do. It allows you to blend between one or more animations that you drag and drop onto your graph. The first thing that we're going to do is we're going to take our idle animation. So we have this idle animation. We can drag and drop it on the graph. What you see happens is it adds this little animation asset, which is this dot. If I select on it I actually want to click on this show sample names so you can see that this is our idle animation. Now, if you drag it anywhere on the graph, you can see that it doesn't snap anywhere on the grid. You can drag it anywhere you want. But I want to actually hold down the Shift key. And if you hold down Shift and drag this, you can see that it actually snaps to the grid. So we want to snap it here at the bottom at the value 0 and 0. You want to actually drag this multiple times. So drag, hold down Shift and click, and that will snap it. And you can drag it on the bottom here as well. So we want to drag and drop this idle animation for each grid division down here at 0, 0. So we want to drag it all the way down here, and just for each grid division, you want to add an idle animation down here. So we should have all 8 idle animations down here at the bottom. Then what we want to do is we want to search or look for our jog forward. So we should have this jog forward, and we can shift and drag that and drop it on the graph. And we're going to drop it here in the center. So if you select it, it should be direction value 0 and speed value 300. And now what we should be able to do is if you hold down Control, you can see that we can move this little green cursor. If we hold Control and let it go. If I put the control right up here on the jog forward, you can see that the character is playing the jog forward animation. If I move it all the way down to idle, you can see it's playing the idle animation. So all that the blend space is doing is it's blending between the two different animations, the idle and the jog forward animation. So depending on the character's speed, if the speed is 0 and the direction is 0, we'll be playing the idle. If the speed increases to 300, you can see that we're playing this jog forward animation. So essentially, the blend spaces will just blend between those two different animations. Now we're going to add multiple different animations so that if the character direction is in the negative values or in the positive values, we'll play our jog left or jog right animation. So we're sort of adding this locomotion to our character. So what we'll need to add next is we need to add our jog forward circle left. So we have this jog forward circle left. So if you shift and drag that, we can drop it on the grid. And we want to snap it right here to the left of our jog forward. We should have this jog forward circle left. If you hold down Control, you can preview that animation and see exactly what it looks like and how it will blend between the jog forward and the jog circle left. Now, on the other side, we want to take the jog forward circle right, shift and drag and drop it on the grid directly to the right of our jog forward animation. So it should be an exact mirror of the jog circle left. Now we want to take our jog left and drag and drop it on the left grid division. So we should have our jog forward circle left and then our jog left. And then on the right, we want to take our jog right and drag and drop it on the adjacent side. So now we can take our green cursor, hit Control, and you can preview how the blending of the locomotion will look like. Then lastly, we have these jog backward. So we have jog backward circle left and jog backward circle right. So again, you want to take the jog backward circle left, shift and drag it on the grid right here to the left. Then take the jog backward circle right and drag and drop it to the right on the right side. Now you can see what it looks like. And lastly, we want to take this jog backward. So this is the last animation that we need. We can drag and drop it, put it on each adjacent side. So we should have jog backward, jog backward. Now you should see we have the full locomotion set up. So you want to make sure that you have all the matching animations. So you can pause the video and make sure that you have all the exact animations that you see here on the screen. They match up exactly to what I have set up here. So one last thing that we want to do in here is we need to add some smoothing so that the transition between our jog forward and our idle and the left right has some smoothing between playing the following animations. The way that we'll do that is in our asset details, we can scroll all the way down till you see this sample smoothing section. And under the waste speed, we're going to increase this value to 10. And you want to make sure that you check smoothing and check allow mesh space blending. So just hit those checkbox there and click save. And that will just ensure that the animations will blend smoothly, or there won't be a snapping transition between blending between two different animations. So now we can go ahead and close out of there. We set up our blend space locomotion. Now what we need to do is we need to create an animation blueprint, which will bind the blend space with our character blueprint. So you can think of an animation blueprint as sort of the bridge between the animation blend space and the character blueprint. That's why it's called a animation blueprint. So to create this animation blueprint, we'll need to right click and create a new animation asset. So go to the animation asset tab, and we want to select the animation blueprint asset. So select that. And just like we did with the blend space, it's going to ask us to select a default skeleton for this animation blueprint. So in our case, again, we want to select the same skeleton that we're using for this course, which is this pirate skeleton, or the UE4 mannequin skeleton. So select that and click create. And we can go ahead and rename this asset to our animation blueprint, or ABP _ pirate. And do a file, save all. We can go ahead and double click and open this ABP, or the animation blueprint. And again, if this is your first time using an animation blueprint, very quickly I'll explain the user interface. So over here on the top left, you can see that we have this little viewport. Again, you can scroll in and out and look around, preview your character's animations. Over here in the center, we have this anim graph that you can zoom out in and out and use your right mouse button to pan around. And we have down here on the bottom right an asset browser where we can drag and drop different animations. And we have these two different tabs, the anim graph and an event graph. So those are all the basics that you really need to know about. So in our anim graph, what we need to do is we need to add a new state. So off of this result, we want to drag and drop it on the graph. And under the search, we want to type in state machine. So under the animation state machine, we want to just add a new state machine. So click on the state machine. Now we'll go ahead and add a new state machine like so. And you can see that it's plugged into the result. So now we can double click and open up that state machine. And you can see that it takes us into this graph. So you can go back to the anim graph by clicking the back right there. You can go back into the state machine by double clicking on it like so. So you can see you can go back and navigate back and forth. But in this state machine, we'll need to add a new state. So off of this entry, you can drag it on the graph. You can see it creates this arrow and drop it on the graph. We have a couple different options. In our case, we want to create the new state. So we'll click on this add state. Now for the state, we'll go ahead and rename this to our idle walk run state and click enter. And now we can hit compile and save, and that will save our settings. So currently we have our idle walk run state. So you can actually double click and open this up. As you can see, it opens up the idle walk run state. And again, you can navigate back by clicking on the back and double click to open it back up. But in our case, you can see that we have this output animation pose and this result pin. So what we want to do is we want to drag in, go to our asset browser and search for our blend space locomotion. That blend space that we just created, we want to take it and drag and drop it on the graph. Now we'll add this blend space node, which is essentially our blend space that we created. So what you'll notice is we have two pins. We have a direction and a speed. So these are the two values that control our blend space, determine what animation should be playing. And then we have this out result, which is the animation pose, which we can plug into the result like so. So now if we hit compile and save, what you'll notice is we're now playing the idle animation. So now all that is left to do is we need to bind these two variables, the direction and the speed, to our character blueprint's direction and speed. So essentially, when the character is running, we want to bind the speed, how fast they're running, to the speed variable in the animation blueprint. That way it will tell the blend space, hey, what animation should we be playing? Would we be playing the idle animation if the character is not moving? Or should we be playing the running animation if the character's speed is greater than 0? So the way that we'll bind these variables to our character speed and direction in our character blueprint is we're going to take the direction, and you can drag off here and drop it on the graph. We have the option to promote this to a variable. So that's exactly what we'll do. So we'll select that. What that does is it adds a new variable under the variables of the type float named direction. So we can click anywhere else on the graph, and now we'll go ahead and add that. We want to do the same exact thing for the speed. So take the speed and drag and drop it on the graph. and click promote to variable. And again, double click anywhere on the graph to add that. So now hit compile and save, and now we've successfully added these two variables for direction and speed that are plugged into our blend space locomotion. So now all that is left to do is to bind these two variables to our character's direction and speed. The way that you'll do that in an animation blueprint is on the event graph. So you want to head over to the event graph tab by selecting it up here. That will bring us over to the event graph. So this event graph is very similar to a blueprint graph that we saw in our character. And so in here, we have these two different nodes. You can see that they're currently grayed out, but we want to go ahead and use these nodes to get our character's movement speed and set these direction and speed variables that we have down here. So first things first is we have this try get pawn owner node. So off of this return value, we're going to do a is valid check. We want to use this is valid, the white question mark down here at the bottom. Now we'll add a is valid node. So what the is valid node is doing is it's checking to see if our pawn owner, in our case, if this is our character blueprint, is it valid? Is it currently spawned in the level? Now we want to hook up the execution. So you want to take this execution from our event update animation and plug it into the execution and hit compile. And once you hit compile, you can see that the flow is moving from left to right. So we're currently checking to see if our owner, our character blueprint, is valid. Now, if they are valid, this is valid will get called. If they're not valid, then nothing will happen. So in our case, for the is valid, we want to set our speed and direction. So first, let's set our speed. So take our speed variable down here and drag and drop it on the graph, and we can choose the option to set it. So for our is valid, we'll set up our set speed. And we also want to do it for our direction. So get our direction variable and do the set and hook up the execution. So now we just need to set these two variables based on some information that we get from the pawn owner, in our case, the character blueprint. So off of this try get pawn owner, we can drag and drop it on the graph and search for a get velocity. We can get the velocity of our character. And if we select that, it will return a vector. And so we need to convert that vector to a float. So drag off here and drop it on the graph. And we'll use the node vector length. So type in vector length, and we'll use this vector length node, and that will return a float, this green value right here, which we can plug into our speed. So essentially all we're doing is we're getting the velocity of our character, we're converting that vector to a float, and we're setting our speed variable to that. Hit compile and save. Now we just need to set up the direction. So for our direction, we need to do a little bit more work to set this up. So all we have to do is off the try get pawn owner, drag and drop this on the graph and search for get actor rotation node. We have the get actor rotation. And then off of the return value, we want to do a calculate direction. We have this utilities calculate direction. Select that. And you can see we have two inputs. We have a velocity and a base rotation. Our rotation is already plugged up. We just need to take our velocity and plug this in for the velocity like so. And that will output the character's direction. So it's calculating the direction and will output the return value, which is a green float value, which we can plug into our set direction variable. So now all we have to do is hit compile and save. We have our simple animation blueprint, getting our character velocity and rotation, and we're setting our speed and direction, which is used in our state machine in our idle walk run state to power our blend space, which will output the animation pose depending on our speed and direction variables. We'll pick the proper animation to play. So now all that is left to do is to set our animation blueprint in our third person character blueprint. You want to go ahead and go to your core blueprints and open up the BP third person character and head over to the viewport. You want to select the character mesh, and in the details, under the animation tab, we should see a animation mode, use a animation blueprint. Currently, we have this anim class ABP Quinn C. We want to change this to our ABP underscore pirate, our animation blueprint pirate. So select that, and it looks like we're getting a weird bug with the character mesh, but you can see the animation is playing. So to fix that little bug, all you have to do is go to your animation blueprint pirate, and in the preview scene settings, we're going to set this to our SK Pirate Full 01 mesh. You should see it apply it like so. Save that, go back into your third person character, and you want to reset the skeletal mesh. Also set the animation class back to none, and we can set our skeletal mesh to our Pirate Full SK Pirate Full 01, and set our animation class to that ABP Pirate, and compile save. And what we should see now is the character mesh is not stretched like what we had before. So just ensure that this is the proper character mesh, the SK Pirate Full 01, and the animation blueprint is our ABP Pirate C. And in our animation blueprint, I set the preview mesh to our SK Pirate 01. And we should see now that our character mesh isn't stretched and we don't have that weird bug. But as you can see, we have our character playing our animation blueprint, which is holding the pistol. And if we hit play in our level, we can see that we now have our animations playing. So when our character runs, we have our running animation. If I stop running, you can see we're playing our idle animation. Basically, we set up our character with the animations using our animation blend space to blend between our idle and our walk and run. And we also set up our animation blueprint, which takes our character's movement speed and tells us essentially what animation should be playing based on the speed and direction that we're getting from our character blueprint. Now, the next thing that we'll need to work on is we actually need to fix our camera and character settings. So currently, if I go ahead and close my content browser and hit the play button, you can see that our character doesn't strafe left and right. If I move my WASD keys around, I can rotate my character and sort of spin the character. But essentially what we want to do is we want to modify not only the character's movement settings, but also things like our character's camera positioning. Let's go ahead and do that. Open up your content drawer and click Dock and Layout. Now we'll get it back in our layout right here. But we want to go to our core blueprints and open up our third person character blueprint, because we'll need to modify some of the different settings in here. So for the first settings, we want to head over to the class defaults. So click on this class defaults button here at the top. And in the details, we can search for our rotation. And so search for rotation. And if we scroll down, we should have this orient rotation and movement. We want to uncheck that option. And then we want to check or use control rotation yaw. So we uncheck the orient rotation and movement, and we check use controller rotation yaw. Compile and save that, and hit play. Now you can see that we're strafing left and right or backwards depending on where the character is moving. And if I rotate my camera left and right, you can see that it rotates the character's body. So now we're using our actual locomotion animations. So depending on where the character is moving, you can see that we're playing those different directional animations. We're strafing left or right, and it looks a lot better than what we had before. Now all that we have to do is we want to modify our camera's positioning so that we can have the camera right above the character's shoulder and not directly behind the character. So if we head back over to our third person character and head over to the viewport, we can go ahead and modify our camera positioning. So currently our camera is attached to our character by this camera boom, which is the spring arm component. So the spring arm component essentially allows us to move or rotate the camera around the character via this arm. So we're going to modify our camera boom or the spring arm settings. So select the camera boom, and in the details, we can modify the settings, things like the arm length, so how far away the camera is from the character, as well as different positioning and offset. So in our case, in the details, under the camera, we want to go to the target arm length and change this from 400 down to 300. And that will pull the camera closer to the character. Then we also want to give this an offset, so we can offset the camera location to be more over to the right of the character. So under the offset, we can give this a default value. So I'm going to plug in some values here, and basically I just got these values by testing it out, but you can play around with these values or just copy the ones that I will input. So I'm going to type in 96.8, and then over here I'll type in 62.6, and those are the different values. Then also I'm going to take this camera boom and move it up, like so, to about the character's chest height right there, and just compile and save that. So those are all the settings. We changed the arm length, the offset, and I moved this camera boom up. And now if we go ahead and hit play and close my content browser, you can see that we moved our camera to be more over the right and not directly on the center of the character. So now you can see that this is what our game will look like. We can strafe our character left and right, and we have our camera set up to be overlooking the character's right shoulder. So next up, what we want to set up is we need to set up an aim offset. So essentially, what you'll notice is when we hit play, currently if I look down or up, the character's body is just standing at this idle pose. It's not rotating the character's body to look directly up, we're looking, or to point the gun directly down where we're looking down. So essentially, we'll need to add a aim offset so that if I move the player's camera up, the character's body will rotate and orientate to the direction I'm looking. That way we're pointing the gun up in the sky or pointing it down on the ground, depending on where I'm rotating my camera. So that is the purpose of an aim offset. It allows you to rotate the character's body to orientate it depending on where the camera is looking. So to go ahead and add this aim offset, we'll need to add and import some animations. So you should automatically have the project files downloaded from the description, but you want to go to the Pirate Game animations, and we should have a folder for fire. And in that fire folder, we have this folder for aim offset. Just double click and open that up. So we have 4 different animations in here. So in our project, I'm going to take this side by side, and you want to go to your core animations and right click and create a new folder and name this to fire. And then double click, open that up, and right click and create a new folder and name this to aim offset, or just AO for short. Then double click, open that up, and we'll take our following aim offset animations, all 4 of these, and drag and drop them into that folder. Again, we'll pop open with the FBX import options. So all we need to do is select our skeleton that we're using. In our case, we're using the UE4 mannequin skeleton, pirate skeleton. So select that and leave all the settings as default and just click import all. And now that we have all the following animations imported, we can do a file save all. And you can see that we have our aim offset animations imported. Now to make an aim offset, all you need are the 4 following animations. You need a looking down animation, a looking up animation, a center animation, and then a static animation. So if you want to make any sort of aim offset, you'll need the 4 following animations. So you can create this in any 3D application in Blender. You can even create them in the engine using things like Control Rig. But I've already created the following animations. So now that we have these created, we just need to change a couple of different settings. And we need to modify the down, up, and center animations. So essentially what we need to do in these animations is we need to set the static reference pose, which is this pistol static. So first, let's open up the pistol underscore down and double click open that animation up. And in here, you can see that it's currently playing this animation. So we can pause the animation by clicking here on graph, and that will just pause the animation from playing. But in the asset details, we want to scroll down until you see this additive settings. And so under the additive settings, you want to change this additive anim type from no additive. You want to change that to a mesh space. And that will give us another option to choose our base pose type. We want to change this from skeleton reference pose down to our selected animation scale. So choose selected animation scaled. So we have mesh space and selected animation scaled, and then it will allow us to pick a base pose animation. So in our case, we want to hit this drop down and search for our pistol underscore static, pistol static animation, and select that and just save that. So we need to do this in the other 2 animations, the pistol center and pistol up. So go ahead and close out of this one and open up the pistol center. And again, same exact thing. We want to scroll in the asset details down to the additive settings. Change this from no additive to mesh space. And change this to selected animation scaled. And hit the drop down and search for our pistol underscore static animation. Save that, close out of there. And again, lastly, we open up the pistol underscore up. In the asset details, we can scroll down under the additive animation type and select mesh space, changes to selected animation scaled, and hit the drop down and search for our pistol underscore static animation, like so. Save that and close out of there. So now we've done the following changes to our center, down, and up. So now we should be able to create the aim offset animation asset. So to create an aim offset, you want to right click, and under the animation assets, you want to select the aim offset. So select that. Again, with any animation asset that you create, it will ask you to pick a skeleton. So again, we need to pick the UE4 mannequin skeleton, or the same skeleton that we've been using. So go ahead and select that, and we'll need to rename this asset. So we'll go ahead and name this to aim offset underscore pistol, just like so. Let's just do a quick file save all, and then let's double click and open up this aim offset. So in here, the aim offset is very similar to our blend space, in which case you have a viewport, you have a grid down here, you have things like the asset details, the horizontal and vertical axis. And of course, you have some animations in this asset browser. So in our case, all that we're going to set up is the vertical axis. You don't need to set up a horizontal axis, just the vertical, since we have our pistol up, center, and down. Now, if you had pistol left or right animations, you could add those in here, but in our case, we're just going to set up the vertical axis. So in the axis settings, we just need to expand the vertical axis. And in here, we're going to give this a name. We'll name this to pitch. For the minimum axis value, we can change this from -90, from 0 to -90. And for the maximum axis value, we'll change this to +90. Now, that is all the settings that we need to do in the vertical axis. Now we can begin dragging and dropping the assets or the animations from our asset browser. So in the asset browser, we can search for our pistol underscore. And we should have our pistol center, down, and up. So first, let's take our pistol down and drag and drop it. And if you shift drag, we'll be able to snap it to the grid, which is what we want. So snap it to the very bottom. We want to click on the show sample names. You can see that this is the pistol underscore down. And then we want to take our pistol underscore center and shift and drag that in the center right here. And lastly, we'll take our pistol underscore up and drag and drop it on the top right up here. So if you hold down Control, you can preview what the aim offset looks like. So if we hold it on the down position, it will play the down animation, center animation, or the looking up. So you can see it's basically just rotating the character depending on where the player is looking. So if they're looking down, it will play just looking down. If they're looking in the center, play the looking center, and looking up, like so. We'll save that and close out of there. Now we just need to add that into our animation blueprint. So we created the aim offset asset. We just need to add it in our animation blueprint. Let's go to our animations, and we should find our animation blueprint underscore pirate. Just double click and open that up. And in here, we can go to our new state machine by navigating back like so. We have our anim graph, our new state machine, and then our idle walk run state. So in our idle walk run state, currently we have our locomotion, but we want to add in our aim offset for our pistol. So in the asset browser, we have our aim offset underscore pistol. You can drag and drop it anywhere on the graph. You can see that it has this aim offset node. Now what we want to do is we want to blend the locomotion with our aim offset so that we can see both of the following nodes playing together. And the way that we'll do that is we're going to blend this locomotion to the bottom half of our character so that our legs will be moving left or right, or strafing left and right. But on the upper half of the body, from the waist up, we want to be playing the aim offset for our pistol. So the way that we'll blend that together is using the layered blend per bone node. So drag off of this animation pin and drop it on the graph and search for the layered blend per bone and select that. What the layered blend per bone does is it takes a base pose and it will blend it with another pose and output the result. So we can take our base pose, will be our locomotion, our blend pose, that will be our aim offset pistol, and now we can hit compile. And currently we need to do a couple of things. First off, we actually need to finish setting up our aim offset for our pistol. So just like we did for our blend space, we need to promote our pitch to a variable so that we can bind that variable to our character's blueprint. So take the pitch and drag and drop it and promote it to a variable, and just click anywhere on the graph, and now we'll name it pitch. Compile and save. And lastly, we need to add a base pose. We need to add a base pose. We want to search for our idle animation and drag and drop that on the graph. You actually want to select this animation, and in the details, scroll down and click on the loop animation. You just want to make sure that this idle is looping. Then you want to take the animation pose and plug that into the base pose and hit compile and save. So now you can see that everything is hooked up. Then the last thing that we want to do is we want to select this layered blend per bone, and we need to specify the settings at which position in the character, which bone should the following two animation nodes blend at. So essentially, where in the character's body should the lower half be played and the upper half be played. So select this layered blend per bone, and in the details, we can set the specific bone. We want to blend the animations together. So under the config layer setup, we can expand this index and add a branch filter. Click on the plus icon to add an element. And in there, we can expand that. And that will allow us to specify a bone name and how much blending should occur. So in our case, we want to rename this bone name to spine_01. And so this corresponds to the bones in our character. So we're going to blend this at spine01, meaning that the lower half will be played with the locomotion and the upper half will be played with this aim offset at the spine01 bone. Now we want to add at least a blend depth of 1 or higher. And then lastly, we want to click on this mesh rotation blend. This will be important later on when we have things like our firing animation. But these are all the basic settings that we need set up for our layered blend per bone. We'll compile and save. Now the last thing that we want to do is we're going to set up this pitch variable. We need to bind this variable to our character's camera position. Basically, where the character is looking at, we'll need to use that value to drive our aim offset. So to do that, we'll need to head back over to the event graph. And this is again where we're binding things like our speed and direction. So we'll just need to set up our pitch. Now for that, we'll need to do a little bit of calculation. So we're going to, off of our try get pawn owner, off the return value, we can drag and drop this on the graph and search for the get base aim rotation node. And that will get us essentially the rotation of our camera, or where the player is looking at. We can right click this return value and split the structure, split struct pin. That will give us the X, Y, and Z. Now what we're interested in is just the pitch, which is the Y value. So we're going to take this pitch and drag and drop it on the graph. Check and see if this is greater than or equal to. Check and see if the value is greater than or equal to. And for the value type, we want to type in 180. And that will give us this Boolean. So off this red pin, we can drag and drop it on the graph and add a branch. And that will provide us with a true or false. We just hook up the execution. So for our true, we want to set our pitch. So take our pitch value and drag and drop it on the graph and click set pitch. So hook that up for the true. So for this value, we want to take our pitch and subtract that by a value of 360 and set that for our pitch for the true. Now for the false, we also want to set our pitch. So hook that up like so. And for this value, we just want to plug in the return value to the pitch like so. So compile and save. So all we're doing is we're doing a little check to see if our pitch is greater than or equal to 180. If so, we'll set our pitch value to the pitch minus 360. If not, we're just setting the value like so. So now that we're setting this value, our aim offset will use the pitch and it will rotate our character's body depending on where we're looking. Now we can go ahead and go back to our third-person map. And if we hit play, if I look down, you can see that the character's body rotates down. And it orientates based on where we're looking or where we're aiming. So if I look up, the character's body will rotate up. If I look down, it will rotate down. So that is our basic aim offset. And you see that it also blends between the bottom half of our body, which has the strafing left, right, forward, and backward, as well as our aim offset, which allows us to look up or down depending on where the character's camera is rotated. The next thing that we'll need to work on is we need to attach a weapon to our character's hand. In our case, the simple pistol. So let's go ahead and get started. So head over to your content drawer and let's dock this in layout. But we need to find our pirate character. So go to your pirate folder and go to the mesh UE4 and head over to the full. We should have our SK pirate underscore full underscore 01. So double click and open that up. And we'll need to add a socket on which to attach the pistol weapon to. To add sockets, you actually want to head over to the skeleton of your character. So to find the skeleton, you can click on the skeleton icon over here. You can see that it's a little skeleton. We can click on it. Now we'll open up the skeleton associated with our character's mesh. In our case, the UE4 mannequin skeleton, which is the same skeleton we've been using for the duration of this course. And in the left here, you can see the different bones in that skeleton. So in our case, we need to add a socket on which to attach the weapon to. So we want to attach the weapon to our character's left hand, since all of the animations are left-handed. So select and find the hand underscore L bone, which is this bone here on the left of the character. And we can right-click and we can add a socket. If you right-click that bone, we can add a socket. Now we'll add a hand L socket. We can actually double-click on this to rename it. We can rename this to our weapon socket. Then with that weapon socket selected, you can right-click and add a preview asset. So right-click that and add a preview asset. And we can search for our pirate underscore pistol. So we should have this static mesh underscore pirate underscore pistol. So select that. And if we navigate in the viewport and move around, you can change your camera speed down if it's too fast. Basically, you can see that we have this camera pistol added on top of that socket. So with that socket selected, we can press W, and that will give us the movement gizmo. We can move it. Press E, we can rotate it. And we can actually click on Control Z to undo that. But if we change this from local space to global space, that will allow for a little bit better rotation and movement. Basically, we want to rotate this weapon to be in the character's hand. And a better way of doing this, or positioning this, is we want to preview our idle animation. So under this preview animation, we can hit the drop down and search for our idle and click it like so. And now that we have our idle animation set, we can actually pause this by scrubbing on the timeline and bringing it back to 0. And now if we press E, we can rotate the pistol. Press W, we can move it around and really position this where we need to. So you can straighten it out and position this like so and get the exact position that you want. Now for me, I'm actually going to input some values. Now this is where I have it currently positioned. So if you want to pause the video and copy the location and rotation values for the socket, you can. Get the exact placement that I have it currently. That is exactly where I'm going to leave it. Now I can hit save, close out of there, close out of the SK Pirate full asset. And in our third person character, you want to go to your core blueprints and open up the third person character blueprint and head over to the viewport. In our viewport, this is where we're going to add the actual weapon mesh. So now that we've created that socket, we can attach the weapon mesh to our character's hand. So in the viewport, we can select our character mesh, and under the components, we can click on this add plus icon and search for a static mesh component. We want to select the static mesh component. Now we'll add that static mesh onto our character mesh. So select that static mesh component, and in the details over here on the mesh, we can set actual mesh that we want. So we want to hit the drop down and search for our pistol, SM Pirate Pistol. So go ahead and select that. You can see that we now have that mesh added down here. We want to attach it to our character's weapon socket. So to do that, since this static mesh is a child of the character mesh, you can see it's directly below it. Under the sockets in the details, we can click on this browse icon and attach it to the weapon socket. And you want to make sure that the location and rotation is set to 0. And what it should automatically do is it should automatically attach it and position it in the exact position that we set up in our skeleton asset. So hit compile and save, and now you can see that it's attached to our character's hand. One last thing that I want to do is I want to remove the collision on this mesh. So with this mesh selected in the details, scroll down till you see the collision. Under the collision presets, we'll set this from block all dynamic to no collision. We'll just compile and save that. Now let's go ahead and hit play. And we should see our weapon mesh attached to our character's hand. Now obviously with the camera positioning, you can't really see it that well, but the pistol mesh is now attached to our character's hand and we have the weapon added to our character. So now that we set up our character with our weapon in our hand, we'll have to set up the fire logic. So essentially what happens when we click the left mouse button. We'll need to set up the fire logic and animation for our weapon. So let's go ahead and get started. So first things first, we'll need to implement an input for our fire logic so that when we click on the left mouse button, our input will be called. So in our core folder, we're going to add a new folder in here for input. But what we'll actually do is in the third, and then in the actions, we have things like our input for things like our jump, look, and move. So these are already the inputs that we have set up for our game for the third person character. So they come with the third person blueprint. So we're just going to go back to the third person folder and take this input folder and drag and drop it and move it into our core folder. Now we should have our animation, the blueprints, and input. So in our input, we're going to go to the actions folder. We're going to create a new input action. So right click and create a new input action. So under the advanced asset, we want to look for input. We want to select the input action. And we're going to rename this input to input action underscore shoot. Will be our input action shoot. And then we want to double click and open this up. And we want to add a trigger. So under the input action shoot in the triggers, we want to add a specific trigger. Basically, how will this input be called? So under the triggers, add this plus, click on the plus icon, and we can select under this drop down the different types of triggers. So we just want a simple pressed trigger. When the player presses on the left mouse button or on our input for our shoot, it will trigger this input action shoot. Okay, there's different other types of triggers, but we're not going to cover that in this course. But just note there's other different ways of triggering inputs. Now that we have our input action shoot, and close out of there and go back to our input folder, we want to open up the input mapping context. So open up the input mapping context. This file is for mapping our inputs that we created, our input actions, to the specific keys that we want to bind them to. So for example, if I expand the mappings here, you can see that we have things like our jump. Our input mapping jump is bound to our spacebar. Our input mapping move is bound to our WASD keys. As you can see, the input mapping context is just a file that specifies which input actions are bound to which keys on the keyboard, or in some cases, even controller inputs. So in our case, we're going to add a new mapping in here. So click on the plus icon. We want to choose the input action that we want to map, which is our input action shoot, the one that we just created. Expand that, and then we have a key that we can assign. So for this, we can just click on this none and search for the left mouse button and select that. And now we have set up a simple binding for our input action shoot to our left mouse button. So when I'm in game, I click on the left mouse button, this input action shoot will be fired off. So we can close out of the input mapping context, and now we can go into our character blueprint. So head over to your core blueprints and open up your third person character. And here on the event graph, you can actually see some of our inputs already set up. things like our camera input action look, our camera input action move for our movement input, and our input action jump for our jump. So right below that input action jump, we're going to right click on the graph and search for our input action underscore shoot. We have the enhanced action events, input action shoot. Let's go ahead and select that. So for our input action shoot, we are going to do a couple of different checks before we shoot our gun. So we'll need to add some variables, do some checks. Basically, we want to check and see, does the player have enough ammo to shoot their gun? Are they currently firing the weapon? And if they are reloading the weapon. So we're going to, off this trigger, do a branch. And so for the condition, we want to do a AND Boolean. And the conditions that we want to check to see are a couple of different variables. So we'll need to create some new variables. In the variables tab down here, we're going to click on the plus icon to add a new variable. And the first one that we want to add is named current ammo. Name that to current ammo. We want to change this variable type from a Boolean to a integer. And hit the compile and save button. So this current ammo, which is the integer, we want to set under the default value our current ammo, default value, and I'm going to set this to 6. Compile save. So we have 6 rounds in our weapon, and that's how much ammo that the player will have before they run out and they'll have to reload. So we're going to check and see if our current ammo, so we need to drag and drop this on the graph and get it to check it. We want to check and see if that value is not equal. So type in not equal. We want to make sure it's not equal to 0. Because if it is equal to 0, then that means that we're out of ammo. So in order to shoot our gun, we want to make sure that we have at least 1 bullet left in our gun. Now we're going to add a couple more pins there. So add another pin. The other condition that we want to check is we want to add another variable. So click on the plus icon down here. And this next variable is called isFiring ? We want to change this from an integer to a Boolean. So compile, save that. Then we want to get the isFiring on the graph and check and see if we are not Boolean. We're going to see if we are not firing our gun. Because if we already are firing our gun, we don't want to fire it again. Then the last condition that we want to check, so we want to add another variable. This will be called isReloading ? Compile and save. Get that isReloading on the graph. Again, we want to see if we are not Boolean, if we are not reloading our gun. And so if all of these conditions are true, if our current ammo is not equal to 0, if we are not currently firing, and if we are not currently reloading, then we can go ahead and actually fire our weapon. So we're just doing these checks. That way, we're not giving the player the ability to shoot the gun if they're out of ammo, if they're firing, or if they're reloading. So off of the true, what we want to do is now that we are shooting our weapon, we want to set our isFiring Boolean. So grab and drop that on the graph and do a set. Set up for the true. We want to set that to true because now we are firing our weapon. And then what we want to do is we want to play an animation. And so we'll need to import a firing animation. So you want to go ahead and download the project files or open the project files. You probably already have it downloaded from the description of this video. And in the pirate game animations fire, we have the fire fast and this reload fast. So you want to go to your core animations fire and drag and drop these animations in that folder. It's going to ask you to pick a skeleton. And so we'll need to assign the skeleton, which is our UE4 mannequin skeleton, the one down here at the bottom, and click import all. So now we've imported those firing animations. We can do a file, save all, and we want to play this animation on our character. And in order to do that, we actually need to do a couple of different things. The first of which is we need to actually convert this to an animation montage. So we need to right click this animation asset and convert it to a montage. So to convert this to a montage, and what an animation montage is an animation montage allows you to play an animation on top of your current character's animation or locomotion. So these are just regular animations. You can see them by this green color of the asset. we want to right click this fire fast, and on the create up here at the top, we want to create a animation montage. We'll select that. And then we can click anywhere else on the graph and do a file, save all. And now you can see it added this blue asset or this montage, which is essentially a copy of our animation. But in this case, this animation montage can be played on top of our current character's animations. So the reason why you're using montages for animations is because you'll need them for when you're doing things like firing, reloading, any sort of animation that is on the fly that you might want to play. You will want to create an animation montage for that. So now to play this animation montage, we need to go to our third-person character, and right off of our true or is firing, we want to do a play montage. Search for the montage, play montage. So it's going to ask us which skeletal component to play this onto. So we want to get our character mesh up here and drag and drop that on the graph and plug that in for the skeletal mesh component. So that will just be which character mesh should we play this animation montage onto. Then it's going to ask us which montage we want to play. So we want to hit the drop down and select our fire fast montage, the one that we created. And then off of the completed, when we are done playing the montage, we actually want to set our is firing back to false. So let's set our is firing back to false. We'll actually hook this up for the on blend out and on interrupted as well. We'll compile and save that. Now, if we were to actually test this out, we're not going to see anything happen. So let's go ahead and actually play test this out. When I click on the left mouse button, we're going to go ahead and do these checks, check and see if our current ammo is greater than 0. We're not currently firing and not currently reloading. And then if so, we'll play that animation fire montage. Let's hit play. And if I left click, you can see that nothing is actually happening. And that's because we need to set up our animation blueprint to allow playing animation montages. There's actually a setup that we have to do in our animation blueprint in order to play animation montages. So let's go to our animation blueprint. So we need to go to our animations and find our ABP pirate and double click and open this up. So in our animation blueprint pirate, we can head over to the anim graph. So you want to click on the anim graph tab and go all the way back out to the anim graph, all the way far out. So we have our new state machine and our output pose. So in order to play an animation montage, you need to add a default slot or a slot to essentially interrupt the current animation that's being played so you can play your animation montage. So off of this new state machine, we want to search for the default slot, the montage default slot. Let's go ahead and select that. And now that will add a node in between our state machine and our output. Essentially what this node does is it interrupts the current animation that's being played, which is our locomotion, and it adds any extra animation, or in our case, any montages to play on top of our animation locomotion. So compile and save, and let's go into the editor and hit play. And now what you'll notice is when I left click, we have our fire animation being played. Now, one thing you may notice that we need to fix is if I look down and I click, you can see that our character, the fire animation is playing in this position. If I look down, it's not playing when I'm looking down, it's only playing in the look center position. So what we'll need to fix is where the montage is playing so that it will properly play wherever we rotate our character's body. If I look up, we want the montage to be playing if I'm looking up or if I'm looking down. We don't want it to just play here in the center. To fix that issue, it's actually a little bit more of a advanced setup in our animation blueprint, but it's not too hard to actually solve. So we need to head back over to our animation blueprint. And the way that we'll fix that is we're going to do some layer blending with the upper half of the character's body and the lower half of the character's body. So just like we set up blending between our aim offset and our locomotion, we're going to do the same thing, but in the anim graph over here with our montage. So what I mean by that is let's unhook our new state machine by clicking the Alt to unhook the wire. And we want to actually save this state machine so that we can reference and get that on the graph. So drag off here and do a save. We want to save this to a cached pose. So if we click on that, that will save our state machine into this saved pose. So compile it and save that. And now that we are saving that, we can actually reference and get that. So we can right click and search for our use save pose, use cache pose, save pose 1329. Now we can get that, and we can actually copy and paste this twice. So we're basically saving it, and now we can get it as many times as we want. And so we're going to blend the upper half and the lower half of the body together. So what we're going to do is unhook the result, move this over. We're going to hook up the cache save pose down here to our default slot. And then off of this top one, we're going to do a layered blend per bone node. So we're going to blend the base pose, which is our base locomotion and aim offset, with our basic locomotion and aim offset with the animation montage. And then the bone that we want to pick, we'll need to specify. So select this layer blend per bone. And in the details, we need to go to our blend, our layer setup, index 1, and add a branch filter and expand that. We need to specify the bone name and the blend depth. So we'll rename this to spine_03, and the blend depth will be 2. And now that we have that set in the layer blend per bone node, we can hook up the result like so. We'll compile and save that. So essentially what we're doing is we're taking our state machine, which is our locomotion name offset. We're saving that so we can have 2 references. Then we're blending the base pose, which is the lower half of the body, with the upper half animation montage slot, so that our animation montage will play no matter where we're looking. If I'm looking down, the animation montage will play. If I'm looking up, the animation montage will be played. So now if we go ahead and hit play, if I look down, you can see that I'm playing my firing animation while I'm looking down. I'm looking up, it's playing wherever I'm looking. So we don't have that weird bug where if I fire my weapon, it's playing only at the center position. But now our montage will be played wherever we're looking, wherever the character's body is rotated. So that is our very simple shoot and fire logic. What we set up is a simple input action that does a couple of checks. Check to see that if we are currently firing, if we are reloading, and if we have enough ammo. And then if so, we play a simple animation montage for our firing montage. So currently what we have set up is we set up our firing logic. So we can click our left mouse button and we'll fire our pistol. Right now it's only playing a simple fire animation. So what we want to add is we want to actually do a line trace for wherever we're looking, center of our camera's position. And we want to fire a line trace to see if we hit anything for our fire logic. And later on what we'll do is with the fire logic, when we set up things like our skeleton enemy, if we hit our skeleton, we want to do things like apply damage. We need to go ahead and set up our firing logic in our character. Let's go ahead and get started with that. So you want to go to your third-person character blueprint and head over to the event graph. And currently we have our shoot, input action shoot, and the basic logic for our firing. Let's actually add a comment for this. So select all this and press C to add a comment. And we can rename this to shoot weapon. And I'm going to go ahead and click the show bubble when zoomed. That way we can see what our comment is named. But basically we want to go ahead and set up our firing function, our fire pistol function, that will get called when we shoot our weapon. So the way that we're going to call that event or our function is off of our animation montage using our notify begin event. So we're going to use a animation montage notify. So the way that a notify works is in the animation, you can specify at what point you want to fire off your notify pin. So what I mean by that is if we go to our core animations fire, we can open up our fire fast animation montage, double click, open that up. And if we scrub in the timeline, we can position our little cursor here to the point where we want to fire off our weapon. So you can see when the gun is pulled back like that, that is basically when we fire the weapon. So when it goes back like that. So right here, about 3 seconds, we want to put our cursor right here. And then under the notifies, you want to make sure that you're in this one track right here. So put your cursor down right here, and right click, and we should see this add notify. You want to make sure that you're doing it in the right spot. So do add notify. We want to add a montage notify. So what that will do is when the animation reaches this point right here, as soon as it reaches this point, in our character blueprint, this notify begin will get fired off because we set up this notify event. So notify events are useful for when you want to set up logic where it's firing a weapon, or say if you have something like a sword, if you're swinging your sword, and when you're swinging it, when the sword is reaching the farthest point, then you can call your notify event. So let's save this in our montage, close out of there, and now we have our notify event. So we'll just need to create a function to get called off of this notify begin. So in our functions, we want to click on the plus icon and add a new function called fire pistol function. It will be called fire pistol function. I'll save that, head back to the event graph, and we want to call that function. So drag and drop that function onto the event graph, and off of our notify begin, we can call that function like so. So now that we are calling this fire pistol function, let's actually double click and open this up. So in here, now that we're inside our fire pistol function, we want to set up the line trace logic that will be the basis of our fire pistol function. So the way that we'll do a line trace is we'll do it from the camera's position. So we'll need to get our follow camera right here and get it on the graph. And we want to do some math to determine our line trace, where it should start and where it should end. So off of our follow camera, we want to actually get the world location. We'll get the world location of our camera, and we're going to take that value and drop it on the graph. And we're going to promote this to a local variable. So the local variables will only be accessed inside of a function, which is what we'll need it for. So we can rename this local variable to local cam location, for our local camera location. So compile and save, and we can hook up our execution. Next up, we want to do our line trace. So off of this, we want to do a line trace by channel. We'll do a line trace by channel. And so we want to input our start and end location. So for our starting position, this will be our camera location. So let's get our local cam location and plug that in for the start. For the ending position, what we want to do is we'll need to do a little bit of calculation. So basically, we want to get our starting position and do a little bit of calculation to determine how far our trace should end. What is the end point? So to do that calculation, we want to first get our local camera location, or our start location. And we want to do a add, operators add, and hook this up for the end. So the value that we want to add is our camera's forward vector. So off of our follow camera, what we can do is we can get the world rotation. So get the rotation of our camera. And off of that return value, we can get the forward vector of that camera. And then with that value, we can do a multiply, operators multiply. And we want to multiply this by a float to determine how far our trace should end. And so in our local variables, you want to click on the plus icon. So make sure it's under the local variables. And we're going to rename this variable to bullet distance. And we'll need to change the variable type from a Boolean to a float. And compile, save that. And for the bullet distance, under the default value, we can give this a default value of 10,000. Compile, save. And now that we have our default value of bullet distance, we can drag and drop that on the graph and multiply that by our forward vector, and then take that value and add it with our camera location. So basically what we're doing is we're calculating the end location based on where the player is looking and based on how far the bullet distance should be. And that will determine our start and end location for our line trace. Now, a couple of other settings that we want to change in here is we want to change the trace channel to camera, since we'll be doing this from our camera. We want to click trace complex so that we can properly hit things like our enemy AI that we'll add later on. And then we want to, under the draw debug type, change this from none to for duration. That way we can actually see our line trace being fired off. Let's compile and save this. Now we should be able to actually see this in action. Let's go into our third person map and hit play. And if I left click, you can see that we're firing off this line trace. Every time that I click on my mouse, we'll fire a line from the center of my camera's position wherever I'm looking. So if I'm looking down, it will fire a line down. If I'm looking up, it will fire a line up. And if I actually hit something, you can see that it adds the red box wherever I hit. So if I hit the wall, you'll see that it has these red boxes. If I hit the floor, I'm hitting the floor. If I look up and shoot in the air, you can see that the trace ends at about 10,000 units. And so we're not hitting anything if we actually shoot into the air. So basically, you can see our basic line trace logic, which will be our very simple fire logic for our character. So next up, what we need to set up is for our fire logic, we want to go back to our third person character in our fire pistol function. Now that we're doing our line trace, we want to check and see if we actually hit something. So to do that, off of the return value, this will return whether or not we actually hit anything. So off of this, we can do a branch. So if we do hit something, then we can go ahead and we can spawn for now just a particle effect at that location. So the way that we'll spawn a little particle effect is we want to do a spawn emitter at location. We have this effects spawn emitter at location. And it's going to ask us to choose a emitter and actually need to add our own particle effect that we download from the marketplace. So let's actually go ahead and do that right now. Let's go ahead and add some particle effects. So go ahead and open up the Epic Games launcher and head over to the marketplace. And you want to search for military weapon, and you want to filter this by free. So if you search for military weapon and filter by free, we should see the military weapon dark and military weapon silver. I'm going to choose this military weapon dark, but essentially this pack comes with a bunch of different particle effects as well as sounds. So we can use some of the particle effects in our pirate game, things like muzzle flash and explosions. So we want to go ahead and add this to our project. And so since this is free, you'll be able to download it for free. And to add it to your project, you want to make sure that you click show all projects because this asset hasn't been updated. So you have to check show all projects and search for your pirate game tutorial. And once it pops up, if you select it, you're going to see that we have this red message, asset not compatible with version 5.4. Please select the closest alternative version. Basically, you just have to click this drop down and select the closest alternative version, which is 4.27. And now that you've done that, you can click the add to project button. Go ahead and click on that. Go ahead and download and add that to our project. Now that we have that added, if we go into our third person map here and into our content browser, we have this new folder for military weapon dark, which comes with FX. So you can see we have things like muzzle flash, explosions, and impacts. So if we hit something, we have different types of impacts. We're going to use the particle effect for our fire. Let's go back to our third person character where we have our spawn emitter at location. And in the emitter template, we can search for P_impact. And we have this P impact metal large. I'm going to use that P impact metal large. And for the location, we want to basically get the hit location from our line trace. So if we hit something, we want to get that location wherever we hit it. So off of this out hit, we can break the hit result. And if we expand this all the way, you can see that we have a ton of different information based on what we hit. In our case, we're looking for the impact point. So this is where the line trace is hitting the ground. So for that impact point, just plug that in for the location and unexpand that, and that should be good to go. So hit compile and save. Now if we hit play, if I shoot the ground, you see that we're playing this hit particle effect wherever I shoot. So if I shoot this object right in front of me, it will play our hit particle effect. If I shoot the wall, it will play our hit particle effect. If I shoot into the sky, you can see that it's not hitting anything, so it's not going to play that particle effect, but only if we shoot something here on the ground and it hits an object. So that is our very simple pistol fire function and our line trace function. We set it up so that we do a line trace based on where the player is looking from the camera location. And then if we hit something, we were playing a simple particle effect at that hit location. So currently we have our weapon logic set up. So we set up our simple pistol that we can fire off, and it fires a line trace to see if we hit anything. If we hit something, it will play a little particle effect wherever we hit. Next up, what we want to set up is we want to add some basic user interface to the player's screen. That way they can see a simple crosshair on the center of their screen so they can aim their weapon accordingly. So we're going to add that real quickly in this lecture. So if you never messed around with user interface, you don't have to worry. But essentially what we'll need to do is in our core folder, we'll need to add a new folder in here for our widgets. So right click and add a new folder and name this to widgets, and double click and open that up. And in here, we're going to right click and create a new folder for textures. So now you want to go ahead and download the project files and open them up. And in our Pirate Game folder, we should have a folder for widget textures. And so these are all the widget textures that we're going to be using. And so let's go to our textures folder. And right now we only need the cross, but we can just go ahead and actually just select all of these and just import them all at the same time. So select and drag and drop all of those into our widget textures folder. So now that we've imported these widget textures, we want to set them as user interface textures. So the way that we can do that is if we open up, say, our crosshair, so double click and open this up, we'll open up the texture viewer editor, and in the details, we want to go to the texture group and change this from world, hit the drop down and select UI. We want to change this to UI and save that and close out of there. And if we go back to our content folder, you'll notice that this cross now has this transparent background. And so that's because we're setting the texture and we're telling the engine we're going to be using these textures for user interface. So it has to do with things like compression and much more. So you just want to make sure that you set all of these textures to UI. And one way that we can actually do all of them at the same time is if you shift select all of these, you can right click and we can do asset actions and do a edit selection in property matrix. If you select that, what you can do is now it will select all of these. So we can actually Control A to select all of them. And in the search, we can search for a group. And now we can change the texture group to UI, all of those textures that we have selected. Now hit the save, close out of there. And now you're going to see they're all transparent like this. Now we know that we've set the texture group for all those. So in this lecture, we're only going to set up our crosshair on the center of our character screen. And so we want to go back to our widgets folder and we're going to create our main HUD widget, our heads up display. You want to right click and to create a widget under the advanced asset, you want to go to user interface and select the widget blueprint. So when you select that, it's going to ask you to pick a parent class. In our case, we're just going to select the common user widget. And we're going to rename this to W underscore for our widget, main HUD, our main HUD widget. So double click and open this up. If this is your first time opening up the widgets, in the center, we have sort of this graph or grid. This is what our widget will look like. So this will give us sort of a preview of what our user interface will look like. On the left here, we have our palette and this library tab. Usually this library tab should be docked here at the top. So like this, a palette and library. I actually don't really use the library tab. I use palette. So make sure that it's on this palette tab. But basically, this is all of the different things that you can add onto your user interface, things like buttons, images, progress bars, sliders, text, all of the components. Down here on the hierarchy, this is sort of a layout of all of the things that you add. So if you start adding things like buttons, images, it will show up in a list of all the things that you have. And of course, the details panel here on the right will show you various different details. If you have a button selected, it will show you details about that button. So to get started in our main HUD, what we want to do is we want to add a canvas on which we can start adding things onto. So to add a canvas, you want to, in the palette, search for canvas, and we have this canvas panel. You can drag and drop this canvas panel onto your main HUD right here. And now what you see is when we select that canvas panel, we have this rectangle, green rectangle. And so this is representing our screen. This is what our user interface will look like on our screen. You can see the resolution down here, but this is just our basic heads-up display or user interface. So to add a simple crosshair onto our screen, we can, under our palette, search for an image, and drag and drop this image onto our canvas panel. And now we can select that image, and you can see you can actually drag it anywhere on our canvas. We actually want to make this, put this in the center. And one way that we can actually center this up and get it positioned exactly where we want it is if we take the anchors over here on the details, we can select this center anchor. And what you'll notice, the anchor is basically this little flower icon over here. So if I change the anchor from the top left to the center, you can see that it moves this little flower icon to the exact center of our screen. So now we're anchoring this image to the center. Now we want to reset things like the size. So one way that we'll do that is we'll reset the position X to 0, position Y to 0, and we can set a size. So we want to do 80 by 80 pixels. And that will make this square image. That will set the size. But you can see it's still not lined up in the center. So in the alignment, we can add 0.5 and 0.5. And now you're going to see that this image is perfectly aligned in the center of our screen. It is a perfect square because we set the size X and Y to 80 by 80. Now we just need to set this image to our crosshair image, or in the textures, this cross texture that we have. So with this image selected, in the details, we can change things like the brush. So if you expand the brush, we can select the image. So hit the drop down under the image and search for our cross image. We should have our crosshair image right there. So select that. And if we click anywhere else on the screen, you can see that we've added our simple crosshair widget. So compile and save that. So we have a very simple main HUD. Right now it's just a crosshair on it. But let's go ahead and add this main HUD to our player screen. So the way that we need to add and create our main HUD is in our character blueprint. We want to head over to the event graph in our character blueprint, and we'll just create this off the event begin play. So what we'll do is we'll actually add an event for creating this. So to the right of our shoot weapon logic, we can right click and search for add custom event. And we can rename this to setup main HUD. And so to set up our main HUD, we want to call the event create widget. We want to call the node create widget. And for the class, we can hit the drop down and search for our w_main HUD widget. We're going to create our main HUD widget. For the owning player, we want to drag off here and get player controller. We want to get a reference to our player controller. And then the return value will be the created main HUD that we create. So we want to take that and promote that to a variable so we can save a reference to that. And we want to name this reference to our main HUD reference. Main HUD ref for short. So now that we've created that widget, we want to add it to our screen. So off of here, we want to call the add to viewport node. Then lastly, we can add a comment for this. So select all that and press C to add a comment. This will be called create main HUD widget. And we'll show bubble one zoom. Now we just need to call this event, the setup main HUD, off of our event begin play. So when our player plays the game, when they start playing the game, this widget will be created. So So up here we have an event begin play, which gets fired off when the player is playing the game. We can actually take all this logic and move this up. Just want to modify it a little bit. And we'll actually select this and move this over. So, and we can just expand this comment a little bit bigger. But off of this event begin play, we can do a sequence. We'll do a sequence. Now will allow us to do multiple things. So off of the event begin play, the first thing that we'll do is we'll set up our input mapping context. That's for our input actions. Then the second thing that we'll do is we'll call that event setup main HUD event. So we'll call this setup main HUD, which is this event down here, which creates the widget and adds it to our screen. We're just calling it off the event begin play. Now let's go ahead and compile, save, and hit play. And if I close my content browser, what you'll notice in the center of my screen is the crosshair. And now we can actually use this crosshair to aim. You can see wherever I shoot, you can see that our line trace lines up perfectly because the line trace is done from the center of the camera's position, which is aligned up perfectly with our crosshair. So next up, what we want to set up is we need to set up our reloading logic for our pistol. So currently what you may have noticed is I can fire my weapon as many times as I want. And basically our character has infinite ammo. So the way that we'll modify that is we're going to subtract our current ammo by 1 every time we fire off our gun. That way, if we run out of ammo, we can't shoot our pistol until we go ahead and reload it. So we're going to be setting up the reload logic for our pistol weapon. So first things first, you want to go to your core blueprints and open up your third-person character blueprint. And right by our shoot weapon, actually want to modify our fire pistol to subtract our current ammo. So currently we're checking to see if our current ammo is not equal to 0, because then if so, that means that we don't have enough ammo to fire our weapon. So we're going to modify this current ammo so that we subtract 1 from our current ammo every time we fire our weapon. So where we'll set that up is in our fire pistol function. So double click to open up the fire pistol function. And over here on the fire pistol function, I'm going to drag this node over because here is where we're going to subtract our current ammo and modify that value. So first things first, we're going to get our current ammo, get that on the graph and do a subtract, and subtract that value by 1. And then we want to set our current ammo. So we want to get our current ammo and set that and hook up the execution like so. We want to make sure that we clamp this value. So off of here, we want to do a clamp integer. And so the value will be our current ammo minus 1. That will be the value, but we want to make sure that we clamp that at 0. So our value will never go below 0 because we don't want to have negative ammo. And then our maximum value, we want to make sure that we have a max ammo size or your max clip size. We're actually going to take this max value and drag and drop it on the graph and promote that to a regular variable. So make sure that this is a normal variable, promote to variable. And we'll rename this to the default value. We want to give this a default value of 6. So this will be the maximum amount of bullets that we have in our clip or in our gun. In our case, our simple pistol has 6 bullets. Our current ammo is set to 6. So we start off with 6 out of 6 bullets. And every time we fire our pistol, we'll subtract 1 and set our current ammo to that value. So now if we go ahead and actually test this out, if I hit play, I should be able to fire off my pistol 6 times. 1, 2, 3, 4, 5, 6. Now you can see if I click my left mouse button, I cannot no longer fire my pistol because we've run out of ammo. So we've subtracted that current ammo, and now it's down to 0. And since it's 0, we can no longer fire our pistol and do that line trace. So now that we're subtracting our ammo, we want to set up our reload logic. So the way that we'll do that is we'll need to first add a input action for our reload. You want to go to your core input and actions, right click and search for input We want to select the input action. And we'll need to add a new input action for our input action underscore reload. And we'll double click and open this up. And in this input action reload, we want to, under the triggers, add a new trigger for pressed. So again, the same exact setup with our input action shoot. We're doing the same exact setup in our input action reload. Save that, close out of there. And now we want to add a mapping for that. So we need to map this input action to a key. So go to your input folder and open up the input mapping context. And in there, we'll add a new mapping and select under the none. We want to search for our input action reload and expand that. And under the key, we want to search for our R key or keyboard R. We have keyboard and then we have R. And now we've bound our reload to our R key on the keyboard. Save that, close out of there, and now we can go back to our third-person character blueprint. And in the event graph, right below our shoot weapon, I'm going to right-click and search for our input action underscore reload. So we have this enhance action events, input action reload. And basically, we go ahead and set up our reload logic. So the way that we'll do that is first we need to add a check. So off of the triggered, we're going to do a branch. The check that we're going to see is if we are currently reloading. So we want to get our is reloading. We want to check and see if we are not Boolean. If we are currently not reloading our weapon. Okay, if we are not reloading our weapon, then we want to set our is reloading. We want to set that to true because now we are reloading our weapon. So now we have to play an animation montage that will look like we're reloading our gun. So we're going to do a play montage, play montage. And for the inselected mesh component, montage, we want to select our character mesh, plug that in for our mesh component. Now for the montage to play, we have a reload animation. You want to go to your animations, fire. We have this reload fast, RMB reload fast. Right click, we want to create a animation montage. So right click it and create a animation montage asset. And then we want to do a file save all to save that. And now in our third person character, for the montage to play, we can hit the drop down and select the reload fast montage. So compile and save that. So once that animation is finished playing, so after we play our reload montage, we want to go ahead and reset our ammo. So we want to set our current ammo. So get that on the graph and set it to our max ammo. So get our max ammo and plug that to our current ammo. So we're resetting our current ammo to our max ammo. And so we want to hook that up to the completed, on blend out, and on interrupted. And lastly, we just want to set our is reloading. Set that back to false. So file and save. And we can add a comment for this. So select all this and press C to add a comment. And we can rename this to reload pistol and show bubble when zoomed. So essentially, when we click the R key, our input action input for reload, we're going to check and see if we are currently reloading. If we are not currently reloading, we set that to reloading to true. And then we play our montage, our reload montage. And after that's completed playing, we're setting our current ammo back to our max ammo, which is 6. And then we're setting our is reloading back to false. So if we go ahead and hit play, we can go ahead and fire our pistol 6 times. 5, 6. Then if I press R, we'll reload it. Then we can fire our pistol again 6 more times. And we can keep reloading. Basically, this will allow the player to have a certain amount of time before they have to reload. And so it won't make them have, infinite ammo. So now that we have our reloading logic set up, we want to add a little widget on our player's screen that will show us the current and maximum ammo that they have. That way they know if they're running out of ammo, and if they are out of ammo, whether or not to reload their weapon. So the way that we'll do that is we need to add a widget on our player's screen to show our current and max ammo. So we want to go to our core widgets. open up our W main HUD widget. So currently this is our main HUD widget. We just have a simple crosshair on the screen. But in the bottom right, we want to add a pistol icon 50 by the 215, something like this. For the image, for the appearance, brush, image, we can hit the drop down and search for our weapon icon. So I have this weapon icon. So we imported this from our textures, weapon icon. So basically this is just a simple pistol icon. And we can compile save. And we want to select this image and make sure that we anchor this. So we want to move this anchor from the top left to our screen to the bottom right. We want to change under the anchors and select the bottom right anchor. And anchoring has to do with whether you're resizing your screen. So if I'm playing this on a small device, or if I'm playing this at a different aspect ratio, like if I have a square monitor, you want to make sure that you properly set up the anchors. That way the images aren't off screen and are properly anchored and shown on your screen. So we have our simple pistol image. We also want to add a text for our ammo. So in the palette, we want to search for text. And we have this text. We can just drag and drop it onto our canvas. We can position it underneath the pistol icon. Then with this text block selected, we can actually change the text. So in the details, under the content, we have text. It says text block. We can actually select that and rename this to 6 out of 6 for our current ammo. Then we can actually resize this, so it's that. And we can scale the font as well. So if you select that text in the appearance, we have things like the font. You can change the font type, or you can change things like the size. We can scale that up, just so that it's a little bit more visible to the player. And of course, you want to anchor this as well. So we want to change the anchor from the top left to the bottom right as well. So compile and save that. So now if we play test this out, in the bottom part of our screen, you should see that we have our pistol icon and our current and max ammo, which is 6 out of 6. So now all we have to do is when we fire our pistol, we want to update that icon or the count to properly show how much ammo that we have in our weapon. So the way that we're going to do that is we need to select this text in our main HUD. And we want to set this to a variable. So in the details, we want to check this is variable. And then we also want to rename this text. So we want to rename this to our ammo text and compile and save that. Now, in any of the widgets, whenever you create a widget, each widget has its own blueprint graph. So you can set up the logic behind the widget. So over up here at the top, we have designer. This is the designer. This is what we're in. We're designing what the user interface will look like. But if we head over to the graph, this is where we can actually set up the blueprint logic behind things like our buttons, our text, and do things like update our ammo text. So in here, what we want to do is we're actually going to select all these events that we currently have and just delete them. We don't need those. But we want to add a custom event to update our ammo text. I'm going to right click in here and search for add custom event and select that. We'll rename this custom event to update ammo text. It will be called update ammo text. We want to add an input down here and change this to an integer and rename this to current. That will be our current ammo. And then add another new input, which will also be an integer, and this will be our max ammo. So compile, save. And then to update our text, we want to get our ammo text. And since we checked that is variable, we should be seeing it in the variables tab. We can drag and drop it onto our graph and get it and do a set text, widget set text, look up the execution, and for the in text, we can do a format. So we want to do the format text. The reason why we're doing this format is because we need to format our text to be our current / max ammo. So in this format, put your cursor in there and you want to type in squiggly brackets. So type in these squiggly brackets, and then inside that squiggly bracket, you want to type in current. And then outside of it, you want to do a slash and do another squiggly brackets, and then inside of there, type in max. So it should look like this, where we have squiggly brackets current, slash squiggly brackets max. And when you press enter, it should add these two inputs for our current and max text. So we'll just need to take our current, and before we plug that in, we want to do a toText integer. So we want to convert our integer to a text, plug that in for the current, and copy and paste this, and get our max, and also convert that to a text like so. We'll compile, save. We could add a simple comment for this. If we select all this and press C to add a comment, this will just be called update ammo text. We'll compile and save. And now all that is left to do is call this event update ammo text whenever we fire our weapon or whenever we reload our weapon. In our third person character, we can go into our fire pistol function. And right over here where we're modifying the ammo, we can move this over, and we have a reference to our widget. We have this main HUD reference, so we can drag and drop that on the graph. And now that we have that reference, we can call any events inside of that widget. So the event we want to call is our update ammo text. Update ammo text. So hook that up for the execution, and also hook this up like so. So now we can plug in our current and max ammo. We just want to get our current ammo and plug that in for the current. And we want to get our max ammo and plug that in for the max. So now when we reload our pistol, so head over to the event graph, and after our play montage, over here we want to move this over. We want to get our main HUD right. And the same exact thing, we want to plug in the execution like so, and plug in our current ammo to the current, and also plug in our max ammo to the max. So basically now we're calling that update ammo event inside of our main HUD, which will set the text or that ammo text on our player screen whenever we fire our weapon, and also whenever we reload our pistol weapon. So if I go ahead and play this, if I fire my weapon, you can see that our ammo count is going all the way down. So we'll hit 0. Now that it's 0, you can see we can't fire our weapon because we're out of ammo. But if I press R, we'll go ahead and reload, and now you can see that our ammo is set to 6 out of 6. We can again fire our pistol, fire off all the shots until we run out, until we have to press R again to reload our pistol weapon. So that is our very simple reload logic in our main HUD ammo text. We got it set up so that it will showcase how much ammo the player has left, and if whether or not they need to reload their weapon. So we've set up things like our character's pistol, our weapon, firing logic, our reload logic. What we want to set up now is the enemy character that the player will have to fight during the game, which will be our skeleton enemy character. So to get that character downloaded, we're going to download the character from the Unreal Engine Marketplace because it's also a free asset. So go ahead and open up the Epic Games launcher and go to the Marketplace tab. And in the search products, you want to search for Gideon. Type in Gideon, and you want to filter this by free. And you should see this Paragon Gideon character. So if you select on this, these are some high quality character assets that Epic Games has made free for you to use in your games. And this character in particular has this skeleton skin. As you can see, there's a skeleton character. So we're going to use that in our game. And before we click add to project, what you can actually do is, since we only need this single character, we can actually create a separate project in which we can add this to, and then we can migrate just the character, because we only really need the character mesh. We don't need any of these other characters, and this will take up extra space in our game anyways. So the way that we can add this to a blank project is you want to go ahead and create a blank project, and in the Unreal Project browser, you can just click this blank project, and you can rename this project to dump project and click create. And we're going to go back to the Epic Games launcher and search for our Gideon, our Paragon Gideon character. And now we can click add to project, show all projects, and search for our dump project and just add it to that project. So as you can see, it's 2 gigs, the entire character with all these different skins and the variations, all the animations, total of 2 gigs, which we just don't need in our project because we only need a specific character and we don't need all the animations and particle effects and sounds and all that stuff. So this way it'll just save us some size in our project. So now you can see it's been added to our project. So we should see a new folder in this dump project called Gideon, Paragon Gideon. And we only want to migrate a single character model. We want to go to the characters, heroes, Gideon, and we want to go to the skins. We have skins. And then we have this Undertow folder. So double click, open that up. And there we should have a meshes folder. So open that up. And then we should have this Gideon Undertow skeletal mesh. We just right click that. And once we have that right click, you want to, under the asset actions, we want to select this migrate. So this will allow us to migrate, copy this asset into another project. So select that. It's going to show us the following assets that will be migrated as well. Basically all the textures, the materials associated with that character mesh. So just click OK. And then it's going to pull up the destination folder. So you want to navigate on your hard drive to wherever you have your Unreal projects on your hard drive. So in my case, I have mine under my E drive. But if you don't have it under your E drive, you're going to probably have it under your C drive or in your documents. So you just want to navigate to wherever you have your Unreal project saved. Then you can go to your Pirate Game tutorial. So you want to open up the folder and go to the content folder and leave it like that. So you want to go to your Unreal projects, Pirate Game tutorial, content, and click select folder. And then we'll go ahead and migrate those assets over from this dump project over to our Pirate Game tutorial. And again, if you're having trouble finding where your Pirate Game tutorial project is located on your hard drive, you can actually open up the project, and in the content folder, you can right click and click on this show in Explorer. And that will pull up the exact location of where your Pirate Game content folder is located on your hard drive. So just a quick tip. But now what we should see is if we successfully migrated that content over, we should see a new folder called Paragon Gideon. And in there, we should have a characters, heroes, Gideon, skins, Undertow, meshes, and we have that Gideon Undertow. So if we double click open that up, basically it's just this pirate skeleton character, which is what we're going to be using for our enemy AI. Close out of there. So now we want to set up this character mesh. So we want to go to our core folder and go to the blueprints. And in here, we're going to right click and create a new folder and name this to skeleton. We'll then double click that folder up. So it should be in our skeleton folder. And we're going to create a new character blueprint for our skeleton enemy. So right click, and we want to create a basic asset. We want to create a blueprint class. So select the blueprint class asset. And it's going to ask us to pick a parent class. So in our case, we want to select the character, since this will be a character. And we can rename this to BP underscore skeleton. And we can go ahead and double click and open this up. So in the viewport, now that we have this open up, we can select the mesh, character mesh under the components. We want to set this character mesh to that skeleton mesh that we imported. So select the character mesh, and in the mesh, in the details, we can set it to our Gideon underscore Undertow. You can see we have our skeleton mesh here in the viewport. And if we move around, what we want to do is we want to position this the proper way. We're going to take this and move this down so that it will line up with this little capsule. So select the character mesh and move it all the way down, like so. And we also want to rotate this. So press E to rotate, and rotate this 90 degrees so it's facing wherever this arrow is pointing. We'll compile and save. So we have our simple character skeleton mesh. So now that we have our simple character skeleton mesh in our skeleton blueprint, we need to set up the animations. So we need to set up first an animation blend space, an animation blueprint, and then assign it in our character blueprint. So we'll need to go ahead and actually download some animations for that. So open up the project files, You want to head over to, in the pirate game folder, the skeleton folder. And we have a folder for animations. So we just have a couple of different animations. We have an idle, a jog, and an attack. So in our blueprint skeleton folder, we can right click and create a new folder. Just name this to animations. And double click open that up. So we're going to take all three of these animations and drag and drop it in our animations folder. And it will pop open with the FBX import options. And for our skeleton, we actually need to choose the proper skeleton. So hit the drop down, and we have a lot more skeletons, but the one that we want to use is our Gideon_skeleton. So this Gideon one. So I want to make sure that is the proper one, and click import all. Now we'll go ahead and import all of the animations onto our Gideon skeleton. So now that we have those animations imported, we can do a file, save all. And now we need to go ahead and create an animation blend space as well as a animation blueprint. Let's right click and create a new animation blend space. And we want to select the skeleton. So we're going to choose our Gideon_skeleton and rename this to blend space _ idle walk run, and do a file, save all, and then double click and open up that blend space. So this blend space will be super simple because we only have two animations, just an idle and a jog forward. So we're only going to set up one axis, or the horizontal axis, on this blend space. In the horizontal axis, we're going to name this to speed. The minimum value will be 0, the maximum will be 600. And that's all the settings that we need to set. So go ahead and save that. And in the asset browser, we can shift and drag our idle animation here at 0, 0. And then we can take our jog forward, shift and drag that, and put it at speed 300, value 0. So now we should blend. If we hit control, we can blend between our jog forward and our idle. So just a very simple blend space, blending between two different animations, our idle and our jog forward. So save that. We're done with our blend space. We can close out of there. And now in our animations folder, we can right click and create a new animation blueprint. It's going to ask us to select a skeleton to create that animation blueprint onto. So in our case, we want to select the Gideon_skeleton and click create. And we'll rename this to our ABP_skeleton. And double click and open this up. And this will be a very similar setup to what we have set up for our pirate character. So off of this output pose in our anim graph, we can drag off here and add a state machine. And then double click and open that up. And in here, off of the entry, we can drag and drop this and add a new state. And rename this state to our idle walk run. We'll compile, save. Then double click the idle walk run. And in our asset browser, we can select our blend space idle walk run and drag and drop that on the graph and hook that up for the result. Then for the speed, we can take that value and promote that to a variable, name that speed, compile, save. And then lastly, all that we have to do is in the event graph, head over to the event graph tab. We just need to bind the speed variable to our character's movement speed. So just like we set up in our pirate character, off of this return value, we'll do a is valid check. Is valid if our character is valid. Then off of our try get pawn owner, we want to get velocity of our character. And then we're going to take that velocity and get the vector length. And off of that return value, we can set our speed to that vector length. And now we should have our simple animation blueprint set up for our skeleton character. So close out of there, and now you want to open up your BP skeleton. So you want to head over to your skeleton, open up the blueprint skeleton, head over to the viewport, select the mesh, and in the animation, we want to use the animation blueprint, and in the anim class, we want to select our animation blueprint_skeleton. Now you can see that our skeleton is playing our idle animation through our animation blueprint. So we've set up our simple skeleton character. Now we need to give our skeleton the ability to chase the player and detect if we actually see the player. So right now, if I were to take my blueprint skeleton, take my BP skeleton, and just drag it into level and hit play. Right now, all I can do is just stand around and play as idle animation. So we need to give the skeleton character the ability to chase the player around. So let's go ahead and do that right now. Let's open up our BP skeleton. And in here, in the viewport, we need to add a pawn sensing component. So you want to, on the components, add a new component and search for a pawn sensing. So we want to select this pawn sensing component. So what the pawn sensing component does is if you select it in the viewport, you can see that we have these different spheres around the skeleton. Basically what that adds is it adds the ability for this character to sense if there's any other pawns or any other players around in the area. The pawn sensing allows the AI to detect if there's anything in front of it. So we want to tweak some of the settings. So select the pawn sensing, and in the AI details, we can change things like the sight radius. So how far can it see an enemy? We're going to change this from 5,000 down to 600. And you can see it changes this green radius. So this is sort of like the sight, how far it can see. And it can only see the stuff in front of it. So you can sort of think of this as sort of a half circle, and that's the radius of its field of view. So now that we've set that, we can head over to the event graph, and we have all these events. We can actually select and delete all those, and select our pawn sensing, and in the details at the very bottom, we can add an event for when we see a pawn. So we have this on see pawn. So click on that. Now we'll add an event for when we see another pawn. So off of this, what we want to do is we want to do a check. We want to check and see if the pawn that we see, if the actor has a tag. So do actor has tag. I want to use this actor has tag node. We want to check and see if the pawn that we see, is that a player. So we're going to have this custom tag called player. Then off the return value, we can do a branch. So whether or not the pawn that we sense is a player. If it is a player, then we can go ahead and attack that player. Okay, if it is not a player, then we don't want to do anything because it's not a player. It's probably another skeleton character. We also want to give this tag to our player character, so copy that tag and make sure it's the exact same name. So just copy that, go to our blueprints, open up our BP third person character, and go over to the class defaults, and in the details, search for tags. And down here under advanced tags, we can add a new tag and add that player tag. Make sure it has the same spelling, same capitalization as the tag that we gave in our skeleton over here. So now that we're detecting that this is our player, what we want to do is do another branch off the true. So for this condition, we want to give this a random chance. We want to give the skeleton a random chance of chasing the player. So off of the condition, we can do a random bool with weight. So this random boolean with weight will basically choose true or false based on a percentage. So for example, this percentage right now is 50-50, 0.5. That's a 50-50 chance of choosing true or false. Or we can do 0.3, which is a 30% chance of choosing true. So basically, we have a 30% chance of chasing our player. And then if not, we're just going to continue on with whatever logic we have set up. We're just giving this sort of a chance. That way it has a random chance of chasing the player, or it has a random chance of continuing to do whatever logic it has already programmed in. So now off the true, we can do another branch. And for this last check, we want to check and see if we're actually currently chasing a player. So we're going to take this condition and promote that to a variable and name this to chasing player question mark, and compile save, because we want to check and see if we are currently chasing a player, because if we are chasing a player, then we don't need to chase another player, and we don't need to call that again. However, if we're not chasing a player, then we want to save the reference to the player we're chasing, which is this pawn. Take this pawn reference and drag and drop it on the graph and promote that to a variable. And we want to rename this to our player reference. look this up for the false. And then we want to call an event called chase player. So down here under our pawn cpawn, we want to right click and add a custom event. Name this to chase player. And compile save. And then over here, we can call that chase player event. Okay. Let's add a comment for this. This will be our if C character 30% chance of skeleton chasing player. So basically, if we sense a pawn, we're going to check and see if the actor that we sense has a tag of player. If it is a player, we want to have a 30% chance of chasing that player. If we're not currently chasing a player, then we want to set that player reference and then call the chase player event down here. So now for our chase player event, we're going to do a couple of different checks. So we'll do a branch. And the checks that we want to check is, we want to add a couple of variables in here. First, we want to check and see if the skeleton is dead, question mark. We want to get that on the graph and do a and Boolean and hook that up for the condition. And actually, we'll do a not Boolean off of the is dead. So do a not Boolean. So if the skeleton is not dead, and if our chasing player, if we are not Boolean, if we're not chasing a player, basically we want to check and see if all these conditions are true, meaning if we are not dead, if we're not chasing a player. We want to add another condition, call this is chasing heap. This will be later on when we set up our main objective, which is to defend our tower defense, which is our keep. We want to do a not Boolean for that. We are not chasing our keep. And then the last one is, I want to add one last variable for is attacking. Is attacking, question mark. So if we are not attacking, we're not currently attacking, then we can go ahead and chase our player. So basically, if all these conditions are not true, meaning if we're not dead, if we're not chasing the player, if we're not chasing the keep, and if we're not attacking, then we can go ahead and chase the player. Set our chasing player for the true to now true. Because now we are chasing a player, we have a target, we're going to attack it. So we want to now move our skeleton to chase the player. So we're going to use the AI move to node. We have this AI move to. And for the pawn, this will be the reference to ourself. So drag off here and get reference to self. For the target actor, this will be our player reference. Get that on the graph and plug that in for the target actor. And so this will basically be who we're going to target and who we're going to chase. Now we can actually go ahead and test this out. So if we were to take our skeleton and drag it into the level, if we hit play, we're not going to automatically see the skeleton chasing our player. And we actually need to do one more thing to allow the skeleton to actually chase our player. And that is we need to add a navigation volume to our level. That way the skeleton will know where to navigate in our level. So you want to click on this cube plus icon and search for a navigation. It's nav mesh bounds volume. Nav mesh bounds volume. So drag and drop that in the level. And you want to press R to scale this up. Let's go ahead and scale this up. Basically, you want to go ahead and cover the entire level. And if you press P on your keyboard, so if you press the P key, that will show you the navigation that is generated from this nav mesh volume. So the green area will show you the areas where the skeleton can navigate. As you can see, it cannot navigate over here, so we'll need to scale this up even more. So we'll cover the entire level. And then you can press P again, so press the P key to hide that navigation. So now that we set up the navigation, one other thing that I forgot to add is in our BP skeleton, there's one setting that we need to change. And you want to select your chasing player Boolean and make sure that you uncheck chasing player. For whatever reason, mine was checked. We just want to make sure that we are not currently chasing the player. The default value should be set to false. So now if we hit play, we set up the navigation, we set up our skeleton on sensing component. So if I run in front of the skeleton, it has a 30% chance of chasing the player. As you can see, it ran to the player. And once it reaches the player, it will actually stop chasing the player. We're going to actually give this a slower walk speed, because right now the skeleton is actually quite fast. You can catch the player really fast. So we needed to adjust that real quick. So go into your BP skeleton and select this character movement component and scroll down till you see the max walk speed. Or you can search for max walk speed. You want to change this from 600 centimeters a second down to 300. So 300 centimeters a second. Compile and save. And now if we hit play, let's run up to our skeleton. And if it wants to chase the player, you can see that it's a lot more slower. It doesn't automatically catch up to the player. It's a lot slower than the player itself. So that will just make it so it's easier for the player to run away from the AI, and it's not faster than the player. Now we want to adjust some of the skeleton settings. So as you can see, the skeleton's animations is quite snappy. So when it rotates, it's really snappy. And so to change that setting, we can give the skeleton a lot more of a smoother rotation. So let's go into our BP skeleton and head over to the class defaults. And in the details, we want to search for rotation. And down here under the character movement rotation settings, we want to change our rotation rate from 360 degrees down to 180. And we also want to check this orient rotation to movement. And then we want to uncheck use control rotation yaw. So uncheck that, check orient rotation to movement, and set our rotation rate to 180 degrees. So compile and save and hit play. And now what you should see is if I run up to the skeleton, it has a 30% chance of chasing us. Let's see if it wants to chase us. So now it's chasing us. Now you can see if I move, it'll rotate smooth, a lot more smoother. And it doesn't have that snappy rotation. And its targeting is a lot better than what we had set up before. So that is our skeleton chase player logic. As you can see, the skeleton will chase the player, and when it chases the player, when it catches up, it will stop. So now we'll have to set up the attack logic. So we set up our skeleton chase player logic. And essentially, all that is set up is when I run up to the skeleton, we'll go ahead and chase the player. And when it reaches the player, it will go ahead and stop. So now what we want to set up is we want to set up the attack logic so that when the skeleton reaches the player, we'll go ahead and attack the player. So to do that, what we'll need to do is we'll actually need to give the skeleton a weapon, and we'll need to set up the attack logic for that. Let's go to our BP skeleton. Open up your skeleton, BP skeleton, head over to the viewport, and select our skeleton mesh. And with the skeleton mesh selected, we want to browse to it. So in the mesh, you can click on this browse icon, and we'll find mesh in our folder. We can double click and open this up. And we want to head over to the skeleton tab. So we have the skeleton icon over here, Gideon_skeleton. So select that. Now we'll open up the actual skeleton, which is the base character. So we want to add a socket on the character's hand to hold our sword. We want to find the bone that we want to add this to. So in the skeleton over here, we want to scroll down until we find the hand R bone. So now that we have that selected, we want to right click onto that bone and add a socket. So double click on that socket, and we can name this to weapon socket. And with that weapon socket selected, we can right click and add a preview asset and search for our sword. We want to add this SM pirate sword. So this pirate sword mesh right here. So we want to take this sword and move this into our hand. And basically, we just want to position the sword in the player's hand, something like this. So I have positioned and rotated the sword. And if you want, you can copy my relative location and rotation. Just pause the video and copy the values. So I have it positioned where I want it. So we can save that and now close out of there and go back to our BP skeleton. And in the viewports, we want to select our mesh and add a static mesh component. And that with that mesh selected in the details, we can set this to our sword, SM pirate sword mesh. Now we'll go ahead and add our sword to our character. We need to attach it to that socket, that weapon socket that we just added. So in the parent socket, because this again is added to the character mesh, we can set the parent socket to our weapon socket. And you want to make sure that the location and rotation is set to 0. That way it will snap it right at the same location of that socket that we created. And one last thing that we need to do, very important that we need to do this, you want to select the static mesh, scroll down to the collision. You want to set the collision presets from block all dynamic to no collision. So compile and save. So now we've added a simple sword weapon to our skeleton's hand. Now we need to go ahead and set up the attack logic so that when our skeleton reaches our character or our player, it will go ahead and swing the sword to attack the player. So let's head over to the event graph to set up that logic. So currently we have our chase player logic right here. We want to select this and add a comment for this. Press C to add a comment and just name this to attack player event. And we'll just show bubble when zoomed. Select this comment as well and show the bubble when zoomed for that one as well. But basically when we move to the player, we want to call an event to attack the player. So on success, when we move to our target, which is the player, we want to call an event that will attack the player. So down here, we want to right click and add a custom event. Name this event to attack player event. Compile, save, and then over here off of our AI move to, on success, when we reach our player, we want to call that attack player event. Let's compile and save. So now down here on our attack player event, we want to do a couple of checks. So off of here, we'll do a branch. And the checks that we want to do is we want to check and see if our skeleton is dead. So are we dead? So do a not Boolean. We want to make sure that we are not dead and do a and Boolean. And also we want to make sure that we are not attacking. Not Boolean attacking. So if we are not currently dead and if we're not currently attacking, then we can go ahead and attack. So off the true, we want to set our is attacking to now true, because now we are attacking. We're calling our attack logic. So compile and save that. Then we want to play an animation for our attack. So off of here, we want to do a play montage. So we have this montage, play montage. And for the in-skeletal mesh component to play that animation montage onto, we want to call it off of our mesh. So get our mesh and plug that in. Then it's going to ask us what animation montage do we want to play. We'll need to go to our core, blueprints, skeleton, animations. And we have this attack animation. So if you open this up, this is what the attack looks like. So we can right click that attack animation and we want to create an animation montage. So the reason why we want to create an animation montage is because that allows us to play this animation layered on top of our current animation blueprint. We want to do a file, save all, and now that we've created that animation montage, let's go to our skeleton and add that in here. So on the play montage, we can hit this down and select our attack montage. So compile and save. Then one last thing that we need to do in order to see this montage be played is we want to go to our viewport and select our character. We actually want to go into the animation blueprint. So browse and find in your skeleton animations our ABP skeleton or animation blueprint and double click and open this up. You want to head over to the anim graph all the way out to the anim graph where we have the new state machine and the output. So in here, we just want to offer the new state machine at a default slot so that our animation montage can interrupt our current state and be played on top of our state machine. So compile and save that. Now we should be able to test this out. So what we set up is when our skeleton is chasing our player. I actually need to rename this comment. This is our chase player event. When our skeleton is chasing the player, when it finally reaches the target, which is our player, we're going to call our attack player event down here. If we are not dead or currently attacking, now we are attacking, we're going to play our montage, attack montage. So off of the completed, when we are done attacking, we want to set our is attacking back to false, set on the on completed, as well as on interrupted. And then we want to go ahead and set our chasing player as well back to false. And then we want to call our chase player event. So basically, when we call our attack player event, we're going to play our montage, and then once that's completed playing, we're going to set our is attacking and is chasing back to false, and then we'll loop back to our chase player so that we can continue to move and chase our player. And if we get close enough, then we'll call our attack player, and we'll just keep looping on and on until either the skeleton kills the player or the player kills the skeleton. So let's add a comment for this. So select all this and add a comment. This is our attack player event. Show bubble when zoomed, and compile and save that. Let's go ahead and hit play. And now if I run in front of the skeleton, it has a 30% chance of actually chasing the player. Let's just trigger and make sure that we grab the aggro for it. So now that it's aggroed onto the player, let it go up to the player and attack. We'll do a swing attack. And then once it's done attacking, it will continue to chase the player. So you can see that it's continuing to chase the player. Then it will attack again. And basically, it will just keep looping and keep chasing and attacking the player. And if I actually just stand here, it will keep attacking the player like so. So that is our very simple skeleton attack logic. It will just keep chasing the player, and when it reaches the player, it will attack and do its attack logic. So we have set up the skeleton chase player and attack player logic, or at least the basic setup for that. Right now, what we want to set up next is we want to give the player the ability to damage this line trace. Don't do any damage to the character whatsoever. Let's go ahead and set up the damage events to damage the skeleton character so that the player can actually apply damage to it. So the way that we'll do this is we need to first go into our BP third-person character. So go to your core blueprints and open up your BP third-person character. And we need to go over to where our shoot logic is at. So over here we have our shoot weapon. So when we play our animation, we call this fire pistol function. So we need to go into this fire pistol function. So currently, what we have set up in here is we have a simple line trace that if we do hit something, we spawn this emitter or this particle effect at the location where we spawn it. So what we want to add is we want to check and see if the actor that we hit, is it a skeleton? And if so, we want to apply some damage to that skeleton. That way we can actually go ahead and apply damage and kill the skeleton. So the way that we'll do that is off of this break hit result, you can expand it and we have the hit actor or a reference to the actor that we hit. So off of that hit actor, we can check and see if that actor has a tag skeleton. So type in skeleton. We're going to have a capital S and copy the tag. And off of the return value, we can do a branch. We can hook up the execution like this. So basically, we're checking to see if the actor that we hit from our line trace, is it a skeleton? And if so, then we can go ahead and apply damage. So off of this hit actor, you want to drag off of here and call the apply damage node. We have this apply damage. We can hook that up for the true. So for the base damage, we can set this to 50. That will be how much damage per shot. So I'm going to make the skeleton have to take 2 shots to kill. So 50 damage per shot from our simple pistol. Then for the damage causer, you want to drag off here and get a reference to self, because this character, the third person character, is the damage causer. Then for the damage type, you need to select the class in here. So just hit the drop down and select this damage type. So compile and save that. So now all that we need to do in order for this to work is we need to copy this tag, our skeleton tag. Let's go to our core blueprints skeleton, open up our BP skeleton, and head over to class defaults and search for tags. And under the actor advanced tags, we want to add that new tag called skeleton. So make sure that it has the exact capitalization, exact punctuation. It's spelled the exact way as what we put in our third person character under this actor has tag. Now back in our BP skeleton, we can set up the logic for our skeleton to receive damage. That way the skeleton can receive damage, and if the skeleton health reaches 0, the skeleton will die. So under our attack player event, we want to add the node event any damage. We have this node event any damage. So basically, if any damage is applied to this actor or to this blueprint skeleton, this node event any damage will be called. So because our character is calling the apply damage, in our skeleton now, we'll call this receive damage, which is event any damage. So basically, this will receive damage from our player. So the first thing that we want to do is off of here, we want to do a branch. So we want to do a check. We want to check and see if the damage causer, if that actor has a tag. The tag that we want to check is our skeleton tag. So we want to make sure that this actor does not, we want to do a not Boolean, have the skeleton tag. We just want to make sure that other skeletons cannot damage other skeletons. That way skeletons can't damage each other, and only the player can damage the skeleton. Then off of the true, we want to do another branch. And the other check that we want to see is if the skeleton is currently dead. We have this is dead Boolean. Let's get that on the graph and check and see if we are dead. Okay, if we are dead, then we don't want to do anything. If we are not dead, then we want to go ahead and apply some damage to our skeleton. So off of the false, we'll do another branch. And for this check, we're going to get our damage. And basically, we'll need to subtract our health by our damage. So we'll need to add a new variable in the skeleton and call this health, because this will be our skeleton's health. We need to change the variable type to a float and make sure that we hit the compile and save button. Then in the default value, we need to set a default value for our skeleton's health. So I'm going to set this to a value of 100. So the skeleton will have 100 HP. Then we want to get our health and subtract this. Subtract our health by the amount of damage that we're taking. So we're going to take our skeleton's health and subtract our health by the amount of damage that we're receiving. And then we're going to check and see if that value is less than or equal to 0. Plug that in for the condition. Because if it is less than or equal to 0, that means that our skeleton is now dead. Because we have less than 100 HP. Because we have less than 0 health. If it is not less than 0 health, that means that we still have some health left. So that means that our skeleton is still alive. So off of the true, let's first set that one up. I should take this and move this down. But let's set our health. Get our health and set it for the true. And our health will be our health minus the damage. So let's copy and paste this. Put that in. So it's our health minus our damage. And that will be set for our new health. Then for the false, we want to do the exact same thing. So we can just copy and paste this down here and hook this up for the false. And for the damage, plug that in for our health minus damage. So we're setting our health variable, and that will update our health. And for the true, what we can do for now is print a print string and just print off that our skeleton is dead. So basically, if our health reaches 0 or below 0, we call this print string the skeleton is dead. So let's add a comment for this. Let's select that and press C to add a comment and rename this to skeleton receive damage event. And I'll just click show bubble when zoomed. Basically, whenever we apply damage to the skeleton, this event any damage will get called to receive damage. We're going to check and see if that actor that is damaging us is not a skeleton. And if so, we want to check and see if our skeleton is dead. If we are not dead, then we'll go ahead and apply damage to our health. And if it is less than or equal to 0, then our skeleton is dead. Let's go ahead and test this out by hitting play. If we run up to the skeleton and left click, you can see that it takes 2 shots the skeleton before it says the skeleton is dead in the upper left corner. And actually, I like to play this in a new editor window. So if you hit these 3 drop down arrows and click on play in new editor window, that will actually pop open a new editor window like this. And it's a lot easier to play test the game this way, in my opinion. But as you can see, it'll take 2 shots before it prints off that the skeleton is dead. Because if you remember, in our character, we do 50 damage per shot, and our skeleton's health variable is set to 100. It'll take 2 shots for the skeleton's health to reach 0 before we call that skeleton is dead event. So we set up our skeleton receive damage and our player apply damage to the skeleton. What we need to set up right now is a visual indicator of showing the skeleton's health on our screen. So we're going to add a health bar to our skeleton enemy. That way the player can visualize how much health that the enemy has left and how much damage it will need to take to die. So let's go ahead and get started. So first things first, we'll need to go to our widgets folder, and we're going to right click and create a new user interface widget blueprint of the type user widget. And we're going to name this to W_health bar. So double click and open up this W health bar widget. And in here, this is going to be really simple. We're just going to add a progress bar. We can search for progress bar and drag in that progress bar onto this W health bar. Then we can set the fill screen to desired on screen. So it should be this tiny little square right over here, and select that. And we want to change the settings. So in the appearance under the fill color and opacity, we can change this to maybe a dark red color. And we can change the percent over here all the way to 1 so you can see what it looks like. But that will be the color that I will pick right over here for our fill color. And then you want to make sure that that is a variable. So make sure that the checkbox is clicked for variable. And this is our simple health bar widget. So to add this health bar to our skeleton, we want to go to our BP skeleton and head over to the viewport. And we're going to add this as a component above the skeleton's head. So to add a widget component to a blueprint, you just want to, under the components, add a new component and search for widget. So we have this user interface widget. So select the widget. With this widget component selected, we can move this up. So it's above the skeleton's head. And then in the details, here's where we can actually set the widget. So down here, first thing that we want to set is the space. I want to change this from world space to screen space. So that way the widget will be facing the player at all times. Then for the widget class, we want to hit the drop down and search for our W_health bar widget and select that. Then we just want to modify this size. So the draw size, we can change this to 100 by 10. So that will change the X and Y scaling. So basically it should be a rectangular, just a rectangle as like a health bar. And then we can just compile and save. Let's go ahead and hit play to test this out. Now you can see we have this very simple health bar widget shown on top of the skeleton's head. And you can really position this wherever you like. I think that's a good position for now. So now all that we have to do is update the health bar's percentage based on the skeleton's health. So the way that we're going to do that is through a blueprint interface. So we need to go to our core blueprints. And if you've never used interfaces before, essentially it's a way that you can communicate between one or two blueprints, from one blueprint to another blueprint. And they are the preferred method for blueprint communication. I have a full, very detailed video explaining blueprint interfaces and why you should use them rather than casting. So if you want to check out that video, it's called the Blueprint for Advanced Users on my YouTube channel. But basically in our blueprints folder, we want to right click and create a new folder and name this to interfaces. So this will be our blueprint interfaces. So double click and open that folder up. And in here, we'll need to right click and create a new blueprint. And we want to select the blueprint interface right over here. So for this blueprint interface, we're going to call this BPI for blueprint interface _ health bar one blueprint to another. So in here, you can add functions. So we're going to select this new function and rename this to update health. And since we're updating the health, we want to have an input. So under the inputs, you want to click on the plus icon and change this from a Boolean to a float. And this will be our health. We have a function for updating health. Now we want to add another function for hiding our health bar. So name this hide health bar. And this will not need to have any inputs or outputs. We'll compile and save that. And now we're done using this interface. We want to just add the interface to our health bar widget. So open up your W health bar widget and head over to the graph. And in the graph, we want to click on the class settings. So click on the class settings over here. And down in the details, we should see this section for interfaces, implemented interfaces. We want to click on this add and search for that BPI underscore health bar interface. So select that and compile save. And now once you've added that interface, we should see under this interfaces those two new functions that we've added, hide health bar and update health bar. So to add those events, all you have to do is double click on those. We can double click on the hide health bar, double click on the update health bar. Now it will add those two interfaces. We can actually select all these other nodes up here and delete those. We don't need that. Let's hit compile and save. And now we can actually set these events up. So first, let's set up our update health event. So we're receiving health from the skeleton. So that means all we have to do to update our progress bar or our health bar is to get our progress bar on the graph and do a set %. So we have this progress set %. And this will set the percentage of this health bar, because we have this value right here, this percentage. And that will control the health bar %. So in the graph for the in %, we want to take our health. We actually want to do a multiply, operator multiply. I'm going to multiply this by 0.01. Plug that into the %. The reason why we're doing that is because the percentage is a value from 0 to 1, and our incoming health is a value from 0 to 100. We just need to shift the decimal point by multiplying this by 0.01 so that we can return that to a percentage. Now for our event hide health bar, all we have to do for this is get our progress bar and do a set visibility and set our visibility of our progress bar to hidden. So basically, we'll call this event when our skeleton dies, when its health reaches 0. We'll hide the health bar because the skeleton is now dead. So we set up our two interface events. Now we can call them in our skeleton blueprint to update the health bar percentage. So go to your BP skeleton, and on the event graph, we want to go over to our skeleton receive damage event. We want to go to the very end over here. But basically, after we modify and set our health variable, then we want to modify and set our health bar widget. The way that we'll do that is we can get our widget on the graph. We can get the widget component. And off of here, we want to get user widget object. We want to get the user widget object of our widget component. And then from there, we can call our interface. But up here first, this is if our health is less than or equal to 0. So that means off of this return value, you want to do a hide health bar. Because our skeleton is dead, we want to hide the health bar. However, down here, we want to update the health. So again, we want to get our widget component and get user widget object. Then off of there, we can call that interface our update health, our BPI health bar interface update health message. So we can plug in the execution, and for the health, we can plug in our health value like so. So now we're calling our interface our update health, which will update the percentage of our health bar on our widget component, which is in our skeleton. Let's go ahead and play test this out. So if we hit play and if I shoot at the skeleton, you can see that our health bar now jumps to 50% because we did 50 damage. If I shoot it again, you can see that the health bar is gone because our skeleton health is now 0. So basically, we're hiding the health bar. So that is our health bar widget for our skeleton. We created a simple widget that is shown on the screen. We added a blueprint interface to modify the percentage of the health bar and hide it if the skeleton's health reaches 0. So now that we set up our skeleton health bar and our damaged skeleton, right now when we damage our skeleton and the skeleton's health reaches 0, you can see that it's still printing the skeleton is dead in the top left. So what we want to set up is we want to set up the skeleton's death event. So basically when the skeleton's health reaches 0, we want to simulate physics on the skeleton so that it will ragdoll and explode into a bunch of pieces and despawn after a couple seconds. So you want to go to your skeleton, open up your BP skeleton, and over here in our skeleton receive damage event, we have this event any damage. So basically when the skeleton's health reaches 0, we're currently just printing this skeleton is dead print string. So what we can do is down below our skeleton receive damage event, we can right click and type in add custom event. And we want to add a custom event and name this to skeleton death and compile and save. So this will be our skeleton death event. And we can call this over here off of our print string. So we can delete that and call that skeleton death event. So basically we'll call that death event. We'll call this event down here. So over here, we want to set up our skeleton death. So first thing that we want to do is we want to get our isDead variable and set that to true because now our skeleton is dead. Then we want to simulate physics on our skeleton's mesh. So we want to get our character mesh, get that on the graph and do a set simulate physics. We want to simulate physics on our character's mesh and click the simulate to true. Then we want to disable the collision on the skeleton mesh because we want the player to run through the skeleton's body when it's ragdolling and on the ground. So we want to get the mesh, character mesh, and do a set collision. We want to select the set collision response to channel. So for the channel that we want to set, we want to set this to pawn. That is the character collision. We want to set the response to overlap. So basically, our character will overlap with this mesh component. We also want to do the same thing for this capsule. So this capsule is the collision for this character, as well as the mesh. We want to set both of those components to overlap. Let's also get the capsule component and hook that up for the target. So both of those will be set to overlap for pawn so that our player can run through the skeleton's body. Next up, we want to disable our skeleton's movement so that the skeleton will no longer move or run around in the level. So we want to get our character movement and do a stop movement. We want to do stop movement immediately. And then we also want to call the disable movement node. So that will disable our skeleton from moving any further. And then lastly, we want to do a delay. So drag off here and do a delay. And we'll wait for about 5 seconds before we call the next node, which is destroy actor node. So the destroy actor node will basically delete this actor or despawn it from the level. So basically after 5 seconds, it will go ahead and destroy itself and it will be despawned from our level. So now this is our simple death logic. So we want to select all this and press C to add a comment and rename this to our skeleton death event and click on the show bubble when zoomed. And so now when our skeleton's health reaches 0, we're calling this skeleton death event, which we'll call this event down here. We're setting our isDead to true. We're simulating physics on the character mesh. We're disabling the collision for the mesh and the capsule component. We're stopping and disabling our movement. And then after 5 seconds, we'll despawn the skeleton from the level. So one last thing that we need to do in order for this to work is, since we're setting physics or simulating physics on our character mesh, we actually need to set the physics settings on the character mesh. So you want to head over to the viewport and select the character mesh. And in the details, you want to scroll all the way down. So you see the section for collision over here. So under the collision presets, we want to change this from character mesh to custom. So select the custom. And then under the collision enabled, we want to change this from query only. We want to change that to collision enabled query and physics. You want to make sure that you change that. And then down under the object type, you want to change that from pawn to physics body. Then we just want to make sure that we block the pawn and block the vehicle trace. So make sure that you have the settings exactly matching what you see here on the screen. And now we can hit compile and save, and we should be all set to actually test this out. Let's go back to our third person map and hit play. So when I shoot the skeleton twice, the body will ragdoll. You can actually run through the mesh. There's no collision on it. And the character will despawn after 5 seconds. I can play test that again. If I run up to the character, it can actually chase me. I can shoot him twice. and he explodes into a bunch of pieces. There's no collision. We can actually run through the mesh, and it will despawn after 5 seconds. So that is a very simple skeleton apply damage and death event. Basically, after 2 shots, the skeleton will ragdoll and despawn after 5 seconds. So we set up in our previous lecture the ability for us to damage and actually kill the skeleton. We set up the skeleton death. What we need to set up in this lecture is the ability for the skeleton to actually damage the player back. So currently, if I go ahead and run up to the skeleton, it will aggro onto the player, and it will chase the player, and its attack currently doesn't really do anything to the player. It's not damaging the player, it just continues to attack. So we want to set up player health and give the skeleton the ability to attack and do damage to our player. So to do that, we need to go to our core blueprints and open up our BP skeleton. And we need to go to our attack player event. So over here, this is our attack player event. So basically, we have this montage where we play our attack montage, and then we go ahead and reset and chase the player. So in our attack montage, we actually need to browse that. So click on the browse icon, and we need to go to our attack montage and double click and open this up. And essentially we need to set up an anim notify so that when the skeleton pulls back its sword and swings it like this, right about at this moment, we want to right click down here under this notify under track 1. You want to right click and add a notify montage notify. So what the montage notify will do is when the animation will reach this point right here, it will fire off in our blueprint in this node, this on notify begin. So because we're playing that montage notify event right here, because we have that in our animation, this notify begin pin will be fired off. And so we can use that pin to set up some logic for doing a trace to see if there is a player in front of us. And then if there is a player character in front of us, we can apply some damage to that player. So let's go ahead and actually move some of this stuff down so we can have some more space to work with. But over here in our attack player event, we can, off of our notify begin, we want to do a sphere overlap actors. So we have this sphere overlap actors, which will essentially do sort of a sphere trace in front of the skeleton. And if I compile this, you can see it gives me an error because I need to hook up all my settings. So the way that we'll hook this up is in the viewport, we're going to add a arrow component so that we can do our sphere trace in front of the player at all times. So select your character mesh and add under that a arrow component. So we're adding an arrow component to our character, and then we can move this up and move this in front of the player and press E to rotate it. It doesn't really matter the rotation, but we're just going to rotate it for visual purposes. But as you can see, this is the location of where we'll do the sphere trace. So this is the center of the sphere, and our sphere will be about this big. So that will be how far the skeleton can damage in front of itself. So compile and save. And now in the event graph, let's get that arrow on the graph and get world location. So we're going to get the world location of that arrow component and plug that in for our sphere position. Then for the sphere radius, we need to determine how big this sphere should be. And we'll set this to 100. Then for the object types, we need to specify what object types we can hit. So off of here, we can do a make array. And in here, we can specify what types we can hit or what types we can collide with. In our case, we want to have world static, add another pin, and we want to have world dynamic, then add another pin, and we want to have a pawn. So we want to be able to hit all of the following types. And then for our actors to ignore, we want to do a make array. And we want to ignore ourselves because we don't want to hit our own character, which is our skeleton. So off of here, get a reference to self. So that will just make sure that we ignore hitting our own self or our skeleton character. Then off of the return value, we can do a branch. So whether or not we actually hit something or overlap something with our overlap. And then it will return an array of out actors that we hit. So off of here, we can do a for each loop. So for each of the actors that we hit, what we can do is off of here do a apply damage. So we can use the apply damage node, which will in turn apply any damage to any of the actors that we overlap. So we want to apply a base damage of 15, not too much damage. The damage causer, we want to get a reference to self, because the skeleton is the damage causer. Then the damage type class, we want to hit the drop down and select the default damage type, and then just hit compile and save. So now we set up our animation montage notify event. So basically when the character swings back its sword and when it comes forward, when it swings it down, we're going to get the location, the world location of this arrow component. We're going to do a sphere trace, and the sphere is going to be roughly 100 units in size. We're going to check and see if we hit any actors and ignore ourselves. If we do hit any actors, we're going to do for each of those actors that we hit, we're going to apply some damage to it. So now nothing is going to currently happen if we actually test this out. What we need to set up is in our character blueprint, we need to set up the event to receive damage. So in order for us to apply damage to the character, we need to in turn set up the event in our character to receive damage. So we need to go to our blueprints, open our BP third person character blueprint, and head over to the event graph. And over here, I'm going to select this create main HUD widget and move this down. And over here, I'm going to right click and add a event any damage. So we're going to add the event any damage. So this event will get called if the player receives any damage or if any damage is applied to the character. And then what we want to do is we need to create a health variable. So in our variables, let's create a new variable and name this to health and change this to a float and compile save. And we want to give our health a default value. So in the default value, we want to set this to 100. That way the player will have some health to start out with. Then the first thing that we want to do is we want to check and see if the damage causer has a tag. So we want to check and see if it is a skeleton that is causing damage to our player. Otherwise, we don't want to apply damage to our player if it's not the skeleton that's causing the damage. So off of this damage causer, we want to check and see if the actor has tag. If the damage causer actor has a tag, and the tag is skeleton. So I want to make sure that's the same tag that we have set up in our skeleton, our BP skeleton. You can search in the class defaults for tags. And you can see in a previous lecture we set up this tag called skeleton. So you want to make sure that it's the same capitalization and punctuation that we have in this event, any damage in our character. Okay, so we want to check and see if the actor has tag, and we want to do a AND boolean because we want to check one other condition. We also want to check if our player is currently dead. So add a new variable and name this to isDead ? And change this to a boolean because we don't want to apply any damage to our player if we are currently dead. So just get our isDead variable and we want to do a not boolean. So if the actor has the tag skeleton and if our player is not currently dead, we can do a branch. So if both of those conditions are true, then we can go ahead and apply some damage. So what we'll do is we'll take our health, which is set to 100, and we'll subtract that. Do a subtract, and we'll minus our health minus the damage, and then we'll go ahead and do a check. We want to check and see if this is less than or equal to 0, and then do a branch. So we want to check and see if our health is less than or equal to 0, because if so, that means that our player is dead. If our health is not less than or equal to 0, that means that our health is still above 0, which means that our player is still alive. So for both the true and false, we need to set our new health variable. So we want to set our health up here, and our health will be our health subtract or minus the damage. So that will be our new health variable. And same thing down here, so we can actually just copy and paste this down here and hook that up for the false. The same thing is we want to take our health and subtract it by the damage and set that to our new health. So now we could actually test this out if we wanted to by printing this. So off of here we could do a print string, and we could just print off our health. And then up here, if our health reaches 0, we could do a print string and print off that the player is dead. Player is dead. Let's add a comment for all this. So select all this and press C to add a comment. And we could rename this to event receive damage. So basically when the player receives any damage, and compile and save. So now we should be able to test this out because we set up our skeleton attack logic. So basically when the skeleton gets close enough to the player, it will play this attack montage. The notify will get triggered. It will do an overlap. If it hits any actors, it will apply damage to that actor. And in our case, if it hits the third person character, we'll call this event any damage, which will check and see if the actor that is causing damage has a tag skeleton, and if our player is not currently dead. If so, then we'll subtract our health. We'll check and see if it's equal to 0. If so, we'll go ahead and set our health, and we'll print off our health and whether or not the player is dead. So let's go ahead and test this out by hitting play. And if we run up and aggro the skeleton, we'll let it attack us. You can see our health is printed in the top left, so 85, 70, 55, 40, and 25, 10, and one more hit, and it says player is dead. So now you can see that the player is dead, and our health is 0. So now what we want to set up is we need to set up a health bar for our character so that we can visualize how much health that we have, and the player will know how much health they have left if the skeleton is attacking them. So the way that we'll do that is we'll add it in our widget. So you want to go to your widgets and open up your W main HUD widget. So in here currently we have a very simple main HUD. We just have our crosshair, our ammo over here in the bottom right. And we just want to add a simple health bar to our widget. So you want to search in the palette for progress bar. We want to add a progress bar onto our main HUD. So just drag and drop it like so. And then we can take this and size this up. And I'm going to make it like so. And we want to choose the anchoring because currently it's anchored in the top left. So you want to change that anchor to the bottom right. And then we can set the percentage all the way up to 1. And we can change the fill color and opacity to maybe a dark red color, something like that. And we can compile and save and select that progress bar and make sure that it is a variable. And we name this to health bar. So compile and save that. And now all we need to do is set up the event to update this health bar when we receive damage in our character. So let's go to our character blueprint. And over here on our event receive damage, what we're going to do is we're going to get our main HUD reference, a reference to our widget, get that on the graph, and from there we should be able to get that health bar. So we can get health bar. So you can see we can get the health bar from our main HUD. And then from there, we can set the percent. So we can do a set percent, progress set percent. And for the percentage, to calculate this, all we have to do is get our health. So we can get our health variable down here. And we don't want to plug this directly into the set percent because our health is a value from 0 to 100. And our percent is a value from 0 to 1. So we'll need to shift the decimal point over and convert this health, which is a value of 0 to 100, to a value of 0 to 1. So to do that, we can do a multiply, operator multiply, and multiply our health by 0.01. And what that will do is it will convert our health, which is a value of 0 to 100, to a value of 0 to 1, or a percentage. And we can plug that in for the percent. And we can actually delete our print string right here and just hook this up like so. And then also for our player dead event, we want to just set our percent like so. So compile and save. So now we can hit play and we have our health bar shown on the bottom right of our screen. And now let's go ahead and aggro the skeleton and let it apply some damage. So as you can see, it's applying 15 damage to our health, and you can see our health bar slowly decreasing in the bottom right. And we can just watch it drain all the way down to 0. So that is all that we set up in this lecture. We just set up our skeleton attack and damage player events and our player health bar widget in our main HUD. So currently we have some very basic logic set up for our game. We have our skeleton enemy that will chase the player if it sees a player. But what we want to set up is, since this is a tower defense game, we need an actual tower or an object that the enemies will have to chase or run towards to attack. So in our case, we're going to make what is called a keep, or basically, in other words, this is going to be our tower that we're going to have to defend against our enemies. And so we need to set up the blueprint class for that, and then we need to set up the logic for our skeleton to go ahead and when the skeleton spawns in the world, it will automatically run towards the keep or to our tower, and it will start applying damage to the tower by doing its attack logic. So let's go ahead and get started. So first things first, we need to go to our blueprints. And in here, we're going to right click and create a new folder for our keep. So this will be our tower. And double click, open that up. And in here, we're going to need to add a new blueprint class. So right click and add a new blueprint class. And we're going to choose the type actor. And we're going to rename this to BP_keep. So just double click and open this up. And in here, we're going to add a simple static mesh component. And select that static mesh component. And we're going to set this component to a cube. So just search for cube, and we should have cube 1 like this. So compile and save, and let's actually just drag this into our level right over here. And we could just scale this up, something like this, and save that. And right now we'll just use a placeholder for now. Later on we'll get some models and swap this out, but just for testing purposes we can just use a simple cube. So now what we need to do is we need to set up the logic for our skeleton to automatically, when it spawns in, it will run towards the keep and attack the keep. So let's go to our skeleton, open up our BP skeleton, and in here we'll set up the logic for that. So up here at the very top, we're going to go up here and right click and add a event begin play. So the event begin play will be fired off when the game is started or when the skeleton is spawned in the level. This event begin play will be fired off. So in order to get a reference to our keep or to this blueprint keep that's in our level, we can use the node get all actors of class. So we can get all the actors of the class, and we want to filter this by our BP_keep. So we'll get all of the blueprints spawned in our level of this type, and it will return this for each loop. So we'll just do a for each loop. And we'll just take that array element and promote that to a variable. And this will be called our keep reference. So we'll just save a reference to that. And now that we have a reference to that blueprint, we can go ahead and chase or attack the keep. So down here, right below our event begin play, we want to right click and add a custom event. Add custom event. And name this to move to keep. And compile, save. And so off of this completed, we want to call that event move to keep. Now also one thing I want to do is I want to set some random walk speed, because when we spawn in our skeletons, we just want to have some variation in character movement. So currently our skeleton is pretty fast when it chases the player, but what we want to do is when we're spawning our skeletons, we want to add a little bit of variation with our character's movement speed. So one way that we can do that is we can get the character movement in our skeleton, and then off of there, we can do a set max walk speed. And when we set the max walk speed of our character, that will change how fast the character will move. So off of here, we can do a random float within a range. And that will basically pick a random walk speed to apply to our skeleton. That way they're running at different speeds. That way we can have super fast skeletons or super slow skeletons, depending on the variation. So for our min value, we can give a min value of 200. For our min walk speed and our max walk speed, we can set this to 500. So you can just give it a little bit of variation. So now let's add a comment for this. This will just be our event begin play get reference to keep and set random walk speed. And we'll click show bubble when zoomed. So now we're calling this attack or move to keep. So this event down here. So now what we want to do is, since we have a reference to our keep, we want to go ahead and move our skeleton AI to the keep so that we can attack it. So first we'll need to do a couple of checks. So off of here we'll do a branch. And we just need to do a couple of checks first. So in order to do that, off the condition, we want to do a and boolean. And the checks that we want to do is we want to check and see if the player is not dead. So we want to do a not Boolean. So get your is dead, and we want to check and see if we're not dead. And the other condition is we want to check and see if we are not chasing the keep. So we have this is chasing keep. We want to do a not Boolean. So if we're not currently chasing the keep. And then we also want to add a couple more checks. We want to check and see if we are not chasing the player. So get our chasing player and do a not Boolean. So if we're not chasing the player, and then the last condition is if we are not attacking. So get our is attacking and do a not Boolean. So if all of these conditions are not true, that means that we can go ahead and keep moving to our keep, which is our chasing keep logic. So I want to set our is chasing keep to now true, because now we are chasing the keep. We're moving towards the keep or to the tower so that we can attack it. So now we need to call our move to logic. So off of here we can call the AI move to node. So we have this AI move to. And for the pawn, all we have to plug in is a reference to self. So get a reference to ourself. And for the destination, we want to get our keep reference. So this is a reference to the blueprint that spawned in the level. And we want to get the actor location. So get the actor's location. And off of the location, we can do a get random reachable point in radius. So what this will do is it'll get a random point within a certain radius that we specify of our actor's location. So our actor's location will always return the center of our actor's location, which is this point inside of the cube. So we want to get a random point within a reachable radius. And in our case, we're going to specify a radius of 200. And we'll plug that random location into our destination. Then we want to expand the acceptance radius, because basically the acceptance radius is how close does this AI have to be to the target or to the destination in order for that to be successful. Otherwise, if it is not successful, it's going to try and keep moving closer and closer so that it can be within 5 units of whatever it's targeting. So in our case, we can give this a higher acceptance radius of, say, 30 units. That way it doesn't have to be right up close to our keep or to our tower. Then we also want to click on this check stop on overlap. So if it happens to overlap with the keep, then we know that it's already close enough to attack it. So that is our simple move to logic. Now we can actually just test this out. So let's add a comment for this right now. This will be our move to keep to attack, and show bubble when zoomed. And so now off of our event begin play, we should get a reference automatically to our keep because it's spawned in the level. And since it's spawned in the level, since we dragged it into our level, we're going to call this move to keep, which will basically do a couple of checks. Check to see if our skeleton is not dead, is not currently chasing the keep, is not chasing our player, and is not attacking. And if so, we can go ahead and chase the keep, and then we'll move our skeleton towards the keep. So let's hit play, and it should automatically run to the keep, and you can see it gets within a good distance of it, where it could now call the attack logic. So automatically this logic will be called when we hit play. It will choose a random reachable point within the radius of the cube, and it will run to that point. So now we have the very basic logic for our skeleton to attack the keep. Now we just need to implement the attack logic so that it will be able to swing its sword and attack our tower or our keep and apply some damage to it. So let's go back to our BP skeleton, and off of our AI move to, we can set up the on success and on fail events. So let's expand this like so. And currently what we need to do is we want to add an event for when we damage the keep. So let's actually take all this and move this up. And right below it, we want to right click and add a custom event. And we want to name this to damage the keep. So this will be the event for attacking or damaging the tower or the keep. So up here on the success, we can call that damage the keep. So basically if we move to the keep and we get within a certain radius of it, we can call our damage event. Then if not, if we're not close enough, we can do a delay. So we can wait for about 3 seconds before we set our is chasing keep back to false. And then we can recall our move to keep function or event, which will basically just re-loop and move our skeleton to chase the keep. So basically this is our very basic move to keep logic. So we'll just keep looping until we get close enough to then call our damage the keep event down here. And for our damage the keep event, we want to basically do the same attack logic that we did for our player. We just want to do a montage where we play our attack montage, and whether or not we hit something, we want to apply some damage to whatever actor we hit. So off of here, we want to do a branch. So we just want to do a few checks. The check that we want to do is we want to do a Boolean. And the two checks is we want to check and see if our skeleton is not dead. So get our is dead and do a not Boolean if we are not currently dead. And then the other check is we want to check and see if we are not currently damaging the keep. So we'll need to add a new variable for this and name this to is damaging keep question mark. And compile and save. And we want to get that on the graph and see if we are not damaging the keep. So if either of these conditions are not true, then we can go ahead and set our is damaging keep to now true, because now we are going to damage the keep. And then we want to play our montage, our attack montage. So do a play montage node. Do the montage, play montage. For the in skeletal mesh component to play this montage onto, we want to get our character mesh and hook that in for the in skeletal mesh. And for the montage to play, we want to search for our attack montage and select that. And we already set up the notify event. So on this notify begin, when the montage is played and when the sword is swung down, this notify event will get called. And so we'll set up our overlap logic. But off of the onCompleted, we want to do a delay. And we'll do a random duration. So off of the duration, we can do a random float within range. And we'll wait for about minimum of 1 second and a maximum of 2 seconds before we can continue attacking, just so the AI have more variation in their attacks. That way they're all not swinging the sword at the same time. Then off of the completed, we can set our damaging keep back to false, and we can re-loop and call our damage the keep function or event. So basically this will just re-loop. So we'll check to see if we're damaging the keep. If we are not, we'll set it to true. We'll play our attack montage, and then on the onCompleted, we'll wait for a couple seconds and then re-loop and call that event. And basically we'll keep looping and keep damaging the keep. Then for the onInterrupted, we also want to plug that in for the delay. But for our notify begin, this is where we want to set up the trace logic. So off of the notify begin, we want to do our sphere overlap actors node. We want to set up the same exact logic that we set up for our attack player event, but we want to set it up for our damage the keep. So for this, what we can do is move this all the way over here, and we can double click and add a reroute node, just so it looks pretty. But for our sphere position, we want to get this from our arrow location. So we have that arrow component in front of our skeleton, and we can get that on the graph and get the world location, get world location of that arrow, and use that for our sphere position. For the radius, we can set the radius to 100. Then we need to set the object type, so drag off here and do a make array. And we want to be able to damage world static, world dynamic, and also we want to be able to damage pawn. So that will allow us to damage the keep, and also if the player is standing in front of the skeleton, trying to body block the skeleton, the skeleton will be able to damage the player as well. Then for the actors to ignore, we can do a make array, and we can just get a reference to ourselves. So just compile and save that. And then off of the sphere overlap actors, off the return value, we can do a branch. So whether or not we actually hit something. And then if we did hit something, what we want to do is we want to apply some damage. But also we're going to spawn an emitter at the location where we hit it. So we want to search for spawn emitter spawn emitter at location. So this will just spawn in a particle effect wherever we hit. And for the emitter, we can choose a particle effect. And since we downloaded those military weapon assets for like our particle effects for our pirate weapon, we can choose any of the particle effects that come with the project. And in our case, I'm going to choose the Impact Wood Large 01. And for the location, I'm just going to use our arrow location. So we can copy this get arrow component, get the world location, and plug that in for the location. So that will play a little particle effect where we swing our sword and where we hit the keep. So the player will notice and see the visual impact of the sword hitting the keep, and they'll know that the skeleton is applying some damage to the keep. Now to actually apply the damage off of this out actors, this will return an array. So we can do a for each loop. So for each of the actors that we hit, we can, off of the array element, do a apply damage node and hook up the execution and compile save. And for our base damage, we can give this a damage of 25. And for the damage causer, we want to get a reference to ourself. And for the damage type, we want to select the default damage type class. So compile and save that. So now let's add a comment for all this. So select all this and add a comment by pressing C, and this will be our attack the keep logic. And move this over, and we'll show bubble when zoomed. So basically, we're going to move to the keep. When we get within a certain radius, we're going to call our damage the keep. We're going to check and see if our skeleton is not dead and not currently damaging. If so, then we are now damaging the keep. We're going to play our attack montage when our notify begin is played. So when the skeleton character swings back its sword and it comes down, we're going to do a trace, and we're going to check it and see if we hit the keep. And we'll play some emitter, a little particle effect at where we hit it, and then we'll apply some damage to the actor that we hit. So we could actually see this in action. We should only be able to see the particle effect be played, and currently we don't have the event receive damage set up in the keep. But let's actually just go ahead and test this out real quick. So let's hit play. And we should see the skeleton go ahead and play its attack montage. And you see it's playing the particle effect where it swings back and hits the keep. So you can see that it's attacking the keep, and it will just keep attacking over and over and over and apply damage to the keep. So now all that is needed to be done is we need to set up the keep's health, and also we want to give the keep a visual health bar so that the player knows how much health the keep has left. So we'll actually go ahead and set that up in the next lecture. So what we set up in the previous lecture is we gave the skeleton the ability to run and attack our keep. So basically it will run and chase the keep. When it gets within a certain radius of the keep, it will go ahead and do its attack logic. It will play its attack montage, do a little particle effect, and it will apply some damage to the keep. So now all that is left to do is we need to set up the event receive damage in the blueprint keep so that we can receive damage, and also set up a health bar so we have a visual representation of the keep's health. So let's go to our blueprint keep. So go to your blueprints keep and open up the BP keep, and in the event graph we want to head over there, and let's just delete all the current events that we get on the graph, and we want to right click and search for the event any damage. So this will get called if any damage is applied to this blueprint. In our case, the skeleton is applying damage. So for the damage causer, we want to check and see if the damage causer, if that actor has a tag. We just want to make sure that the actor that is applying damage is our skeleton. That way the player, if the player accidentally shoots the keep, it won't apply damage to it. So off the return value, we can do a branch and hook this up for the true. And then we need to add a health variable for our keep. So in the variables, add a new variable and name this to health, and then change this to a float, compile and save. And for the default value, I'm going to set this to 1,000. So we have 1,000 health. So we have a lot of health. That way it takes a lot of damage for our keep to be destroyed. So let's get our health on the graph and do a subtract. And we want to take our health and minus it by the damage. And then we want to check and see if that is less than or equal to 0. And so off of there, just do a branch and hook that up for the true like so, and compile and save. And then for the true, what we'll do is we'll get our health, and we'll set this on the graph and hook this up, and we just want to get our health and subtract that by the amount of damage that we're receiving and set that to our new health variable. And again, we want to do the same thing down here as well. So let's just copy and paste this down here, and again get our health and subtract that by the amount of damage that we're receiving. And now we're actually setting the health of our keep. And lastly, we just want to update and add a health bar to our keep. That way we can have a visual representation of the health. Now we've already set up health bars in this project before. And in fact, in our BP skeleton, if you head over to the viewport, we set up this widget component, which is our W health bar, which is a in-game widget for our health bar that will show how much health the skeleton has. So we can use that same widget component in our keep and use that same blueprint in here for our keep's health. So all we have to do to add that is in the components, add a new widget component. So we have this widget component and select that. And in the details, we just want to set the details of that widget. So with that widget component selected, we want to change the space from world space to screen space. That way it will always rotate and face the player's screen. In the widget class, you want to search for that W_health bar widget, the one that we created in a couple of lectures ago. We want to set the size so that it will be a long rectangle. So we're going to set the size to 300 pixels by 15 pixels. So it'll be 300 by 15. And then that should be good. We just want to change the location of it so we can move this up like so. You can position this wherever you want, but it should be like that. And if we hit play, we can see what it looks like. Maybe we might move this just a little bit down like this. That way we can see it better. But that's what the health bar looks like on our keep. Now we just need to set up the event to update the health bar when the skeleton attacks and applies damage to the keep. So in our event graph, off of our set health, we can call an event to update our widget component or our W health bar widget. So to do that, we can just get our widget on the graph, and on here we can call the node get user widget object. And we set up a event or interface on that widget to update the health percentage. So off of this return value, we can just call that interface the update health message for our health bar interface. And now we can set the health value to that new health value that we're setting. So just hook up the execution, and for the health, we'll need to multiply our health. So let's get our health value, and we need to multiply this. And we're going to multiply this value by 0.1. Now the reason why we're multiplying this value by 0.1 is because our health value is a value of 0 to 1,000. And what this will do is it will convert this health down to a value of 0 to 100. Because in our health bar interface, if we actually go to our health bar, let's go to our W health bar, head over to the graph where we set up that health bar interface event, we're already multiplying the incoming health by 0.01. So it's already doing this multiplication. So all that we have to do is shift our health, which is a value of 0 to 1,000, to a value of 0 to 100, because in the health bar, it will shift that value from a value of 0 to 100 down to a value of 0 to 1, which is a percentage. So you just want to make sure that you're doing this right. Otherwise, the health is not going to update properly. So that's why we're doing that times 0.1 instead of 0.01, because we're already multiplying it in the health bar widget. So that's just why I'm doing it like that. So hit compile and save. And then we want to do the same exact logic down here. So let's just copy our update health and plug it in like so. And so now we should be able to see the widget be updated when we receive damage. So we can add a comment for this. This will be our keep receive damage, update health bar. And we'll click show bubble when zoomed. Now let's hit play, and we should be able to see the skeleton run up to the keep, and you can see that it applies 25 damage each hit, and you can see that our keep has over 1,000 health, so it's going to take quite a long time for the skeleton to destroy the keep. But obviously when we set up our actual game mode and the logic for spawning skeletons, there'll be a lot more skeletons swarming the keep. So they will do a lot more damage combined when there's, more than just one of them attacking it. So that is our simple skeleton chase, keep, and attack logic. So basically we're applying damage to the keep, and we set up the receive damage in the keep blueprint. That will set as a new health variable and also update the widget for the health bar for the keep. So now that we set up the basic gameplay logic or a basic gameplay loop, the skeletons currently will spawn in and they will automatically go and attack the keep. So since we have the basic gameplay loop set up, the skeletons will spawn in and they will automatically go and attack the keep. If they see the player, they'll attack the player as well. We set up all the damage for the skeleton to damage the player or to damage the keep. And we also set up our player's ability to damage and kill the skeleton. So we have all of our basic gameplay logic set up. Now what we need to set up is the actual game mode logic, which will handle spawning in the skeletons, and it will keep track of the waves. So we'll keep track of each wave and determine how many skeletons will it need to spawn for the next wave to make it more and more difficult. And also we want to have things like a grace mode. So basically you'll have a grace period. So after each wave, it will give the player about 30 seconds to buy different types of items, place down certain items before the next wave starts. So in order to set up this waves logic and spawning our skeletons, we'll need to set up the actual game mode that will handle that logic. So let's go ahead and get started. So first things first, we'll need to, in our core blueprints folder, we want to right click and create a new folder and name this to game mode. And in our game mode, we want to double click, open this up. We need to add a new game mode blueprint. So we want to right click and search for blueprint class. So select blueprint class. And down here, we want to choose the game mode base. So simply the game mode base is a class that defines the game being played, its rules, the scoring, and other facets of the game type. So this is the class that we'll need to keep track of the score, to keep track of the different waves, how many skeletons should be spawning in, and all that stuff. So we can use the game mode base class as our blueprint class to determine all that logic. So rename this to our game mode underscore tower defense, because that is our tower defense game mode. We want to a file save all, and then we can go ahead and double click and open up this game mode blueprint. Now this game mode blueprint is very similar to other blueprints, in which case you have a viewport, you have your event graph, and all that stuff. But over here in the defaults, under the class defaults, you'll notice that we have a couple of different important variables that we can set. We can set things like the default pawn class, so the default character class. You can also set other things like the game state, player controller, a whole ton of other different types of blueprints that we're not going to be actually using in this course. The only thing that we really need to set in here is the default pawn class. So under the default pawn, we need to add our BP underscore third person character pawn, because this is our default character blueprint. So it's important that we set that, otherwise it's not going to spawn in this character when we set this as our default game mode. So just make sure that you set your third person character as a default pawn class and hit the compile and save button. Then we want to head over to the event graph to set up the logic for our tower defense game mode. So what we want to do is we can delete the event tick, but off of the event begin play, basically when the game starts, we want to go ahead and spawn in some skeletons and start the very first wave. Now the way that we'll spawn in skeletons is we're going to actually create a custom blueprint so that we can determine where in our level should we spawn our skeletons, just so it gives us, the developer, an easy way of choosing where we want to spawn in the enemy. So the way that I'm going to do that is I'm going to create a custom blueprint that we can move around in our level, and we'll determine sort of where the skeleton should spawn. And so you can think of this as sort of like the skeleton spawner. So let's go to our blueprints and go to our skeleton folder, and in here we can right click and create a new blueprint class of the type actor. So we can select actor and just rename this to BP underscore spawn point. So it'll be a spawn point blueprint. Double click, open that up, and in here this will be really simple. I'm going to, under the components, add a capsule collision component, like so, and I'm going to scale this up to 2 by 2 by 2, so it should be this big. And then also I'm going to add, under the components, search for billboard. So we have this billboard component, and a billboard component is more or less just a visual for the developer, and this will be hidden in the game. So only the developer, the developer, can see this icon. So we can take this billboard and just scale this up like so. And this will just make it, a visual representation, so we know that this is a spawn point. You could change the sprite to whatever you want, but this will be fine. But now we can just take this BP spawn point and drag it into our level. And we want to move this up above the ground, so that's not in the ground. But this will be a visual representation for us to know that this will be where a skeleton will be spawned. And what we can do is we can duplicate this by holding down Alt and dragging. That will duplicate it. And so we can choose where we want to spawn the skeleton based on these spawn points. So we can position these randomly in wherever we want. And we'll know that a skeleton will spawn, has a chance of spawning at one of these spawn points. So let's save that. Let's actually move these up a little bit. But basically, now we can get these spawn points in our game mode, and we can spawn skeletons at these spawn points. So let's go to our game mode tower defense. And now to get a reference to those spawn points, we can do a get all actors of class. So we can get all actors of class, and you want to filter this by that BP_spawn point that we created. So then we can take that and promote that to a variable, save a reference to that, and this will be called our spawn points. So now we're saving all of the spawn points in this array, and then we can just call an event down here to start spawning our skeletons. So we want to right click and add a custom event and name this to spawn skeletons. Then compile, save, and up here we can call that event spawn skeletons, and then our spawn skeletons event will be called down here, which basically we're just going to do a loop. We're going to check and see what current wave we're on. We'll determine how many skeletons should we spawn based on the wave, and then we'll spawn the skeletons at our spawn point location. So for our spawn skeleton event, what we'll need to do is we'll need to add a couple of variables to keep track of how many waves do we have, how many total skeletons should we spawn, and so on. So in our variables, we'll need to add a new variable and name this to current wave. So this will be our current wave. We want to set this to an integer so we can keep track of how many waves we are currently on. So our current wave will be wave 1, because that will be our first wave. And we want to add another variable and name this to our max waves. So our max waves will be basically how many total waves do we have before the player wins the game. So we could add, say, 10 max waves just for now. And then what we want to do is we're going to add another variable in here. So click on the plus icon and name this to skeleton total. Compile and save. And so our skeleton total will set. So get that on the graph and set that. And this will be how many total skeletons we want to spawn. And we also want to take that variable and promote that to a variable. So we will add another integer and name this to skeletons left. So that will be how many skeletons we have left. So in order to calculate how many skeletons we should spawn in, we're going to get our current wave and multiply this by 4. So for our current wave, for our first wave, since our current wave is set to 1, that will just multiply 1 times 4, which is 4. And that will be how many skeletons will spawn in on the first wave. Now on the second wave, that will be 2 times 4, so that will be 8 skeletons. And then on the third wave, 3 times 4 will be 12. And as you can see, the number keeps increasing depending on the wave. And that will just be how we're going to calculate how many skeletons should spawn in depending on the current wave. So now off of here, we can do a for loop. So we want to do a for loop. And we want to choose this one down here at the very bottom, this for loop. And so for the first index, we want to set this to 1. And for the last index, we want to get our skeleton total. So get our skeleton total and plug that in for the last index. And so this will be doing a loop. So for each amount of skeletons that we calculate, in our case, it'll be 4. It will call this loop body 4 times. So off of the loop body, we want to do a spawn actor from class. So we can spawn in an actor. And the actor that we want to spawn is our BP_skeleton. So our BP skeleton. For the spawn transform, we want to right click and split the structure so we get the full transform location, rotation, and scale. In our case, we only want to modify the scale. And so to determine where we should spawn our skeleton, we have that spawn points array. So basically wherever these spawn points are located in the level. So in our tower defense game mode, we can get our spawn points array, and to get a random spawn point, all you have to do is do a random array item. And so we'll get a random spawn point from an array, and off of there we can do the get actor location. So we can get the location of that spawn point and plug it in for the spawn transform location. So now we're just getting a random spawn location to spawn our skeleton at. So now let's go ahead and add a comment for this. So add a comment, this will be our event in play set references, setting our references. And then down here we can call their spawn skeletons in game, show bubble when zoomed. And now we have our very basic tower defense game mode logic, which will basically spawn in some skeletons at our spawn points. So now we need to set this as our default game mode. So because we created this custom game mode, our tower defense game mode, we need to set it as the default game mode in our level. So each level has a game mode assigned to it. So to find that game mode, you want to go to your window and you want to open up the world settings. So go to window, world settings, and I usually dock my world settings window over here on the details tab. So you can take the window and just dock it over here. But basically you can switch between details and world settings. But in the world settings, we have this game mode. And you can see currently we have our game mode set to the BP third person game mode. But we want to change this now to our game mode tower defense. So we want to hit the drop down and select our game mode tower defense. And if you expand this selected game mode, it will show you things like the default pawn class, the default player controller, and all that stuff. In our case, we only set the default pawn class to be our third person character. So just make sure that you set that. And if that is properly set, then we should be able to hit play. We'll spawn in as the third person character. Now what you'll notice is when we spawn in, it spawned all 4 of these skeletons, but they currently are not moving. So we need to fix that real quick. And actually let's delete this other skeleton over here, the one that we dragged in, we can delete that. Now the reason why those skeletons aren't moving when they're spawned in is it has to do with the blueprint. So we want to go to our blueprints and open up our skeleton folder and open up your BP skeleton. And in the class defaults, you want to search for auto possess. So we have this pawn auto possess AI, and we want to change this from placed in world to placed in world or spawn. So whenever we spawn the skeleton, it will be auto possessed by an AI. So we want to make sure that we change that to place in world or spawn. That way the AI will be able to possess this skeleton blueprint and actually move it to wherever we need to move it. The other thing that we need to do is we want to change our spawn collision handling method. So search for spawn, and down here we have this actor spawn collision handling method. So basically this is what happens when we spawn in this actor. So currently it's set to try to adjust location, don't spawn if there's something in front of it. We want to change this to always spawn ignore collisions. That way it will always spawn this skeleton in no matter what, even if it's colliding with other skeletons. So we made those 2 different changes. We made sure that we auto possess the AI if it's spawned in, and we also make sure that we're always spawning the skeleton and we're just ignoring collisions. That way we can always spawn in the skeleton and it won't be not spawned. So now let's hit play, and now you can see that we have these 2 skeletons spawn in. This third one looks like it's having some issues. We don't have enough spawn points, and it's actually spawning 2 skeletons at a single spawn point. So we actually want to go to our BP skeleton and change our spawn method. We want to actually change it to try to adjust location but always spawn. So we actually want to use this instead, because this will actually adjust the location of the spawn location, but it will always spawn the skeleton. So because we have only 3 spawn points, our game mode is bound to spawn another skeleton or 2 skeletons at one spawn point, because on our first wave, we're spawning in 4 skeletons. So now if we hit play, you can see that it spawns all 4 skeletons. They don't have any issues navigating, because it will adjust the spawn location if they're merged together, so that all of them will spawn and run and attack the keep. So now you can see that we have our basic skeleton spawning logic. And you can see they're all attacking the keep. They're all moving to the keep. And when they're in a certain radius, they can damage the keep and attack it and do damage to our tower. So now we have our basic tower defense game mode, which basically after the event begin play, we're going to get our spawn points. And then we're going to spawn our skeletons based on how many waves we're currently at, calculate how many skeletons we have left, and spawn our skeletons at random spawn point locations. So we set up our basic tower defense game mode logic, which will basically spawn in the skeletons at our spawn point location, and those skeletons will automatically run and start damaging the keep. Now what we want to set up in this lecture is we want to keep track of each skeleton that is killed. So basically when I kill a skeleton, we want to tell the game mode, hey, we've killed a skeleton, there's only this many skeletons left, because we want to keep track of how many skeletons are killed, how many skeletons do we have left, before we go to the next wave. So basically the player will have to kill all of these skeletons in the level in order to go on to the next wave. So the way that we'll keep track of that is we'll need to add an interface in our game mode to call an event to update our skeletons killed so that we can keep track of how many skeletons we have left before we start the next wave. So go to your core blueprints folder and go to the interfaces, and we're going to right click and create a new blueprint interface. So under the advanced asset, select blueprint and select the blueprint interface. And we're going to rename this to our BPI underscore tower defense game mode. So that will be our tower defense game mode blueprint interface, and just double click and open this up. And in here, we're going to add a function, and we can rename this function to skeleton killed. And that's all that we need to do. So hit compile and save and close out of there. And we just need to add this blueprint interface to our game mode. So go to your blueprints, game mode, and open up your tower defense game mode. So double click, open it up, and head over to the class settings. And in the details under the implemented interfaces, we can add that new BPI underscore tower defense game mode blueprint interface and compile and save. And now in our interfaces section, we have the new interface event for our skeleton killed. So just double click and add that event. So now we have this event that we can call that will basically update how many skeletons we have left. So to update our skeletons that we have left, basically we'll call this event every time we kill a skeleton or kill one skeleton. So we can get our skeletons left. We can get that variable and do a d-increment. So d-increment integer, basically what this node does is it subtracts 1 from the specified value and then it sets it. So basically it's getting our skeletons left, subtracting it by 1, and then we're setting it. Then we just want to check and see if this is equal to 0 and do a branch. Because we want to check and see if the skeletons left, do we have any skeletons left? If the skeletons left is equal to 0, that means that we should go ahead and start the next wave. So what we can do off of the true is just do a print string, and we can just print off all skeletons are killed, next wave starting soon. So just compile and save that, and let's add a comment for this. This will be called count skeletons killed, and show bubble when zoomed. So now we just need to call this event, this interface event, whenever a skeleton dies or whenever we kill a skeleton. So let's go to our blueprints skeleton, open up our BP skeleton, and in the event graph, let's go over to our skeleton death logic. So at the very bottom, we have our skeleton death logic. So down here, before we destroy our actor, so in our skeleton death event, before we delete ourselves from the level, we want to go ahead and show that the skeleton has been killed. So in order to call that interface event in our game mode, we can right click and just get our game mode. So you can search for the get game mode node. So we have this game, get game mode, and that will return the game mode or our current game mode. And now off of that, we can call our skeleton killed interface message, which will call our BPI tower defense game mode interface skeleton killed, which will call that event in our game mode, which will say, hey, we killed a skeleton, update how many skeletons we have left. And if we are done killing all the skeletons, we can print off that the next wave is starting soon. So now in our skeleton death, we're calling that skeleton killed event in our game mode when the skeleton is dead. So let's hit play and test this out. So I'm going to kill all the skeletons. So let's reload, shoot this guy over here, reload our gun, and shoot this guy, and then shoot the last skeleton. And you can see that all skeletons are killed, next wave starting soon. So basically, that is our simple wave logic. Now what we want to set up next is, now that we've killed all the skeletons, we want to start the next wave. So basically we want to increment and set that we're on to wave number 2. And then we want to go ahead and spawn in and calculate how many skeletons we should spawn in next. So let's go back to our game mode tower defense. And right below our skeletons killed, we want to right click and add a custom event and name this to wave increment to increase our waves. And then we want to get our current wave and do a equal and check and see if our current wave is equal to our max waves. Because we just want to check and see if the player has reached the last wave. And then if so, we can do a branch. Because if the player has reached the max wave, then we can print string, do a print string, and just print that the game has been won. Game won. Because if the player reaches the last wave, then the player has won the game. Now, if they have not reached the last wave, what we want to do is get our current wave and do a increment integer. And so what that will do is we'll add 1 to our current wave and we'll set that value. So now that we're increasing our current wave, we want to go ahead and start our next wave. But before we do that, we want to actually start a timer because we want to give the player a little bit of a grace period. And later on, what we'll set up is we'll set up a buy menu so that the player can buy certain different types of items, like a cannon or a explosive crate. So the player will have some certain amount of time to set up their defenses before the next round starts. So to set up this timer, we can right click and add a custom event and just name this to pre-round timer. Compile, save. And so off of this current wave, we can call that pre-round timer. So basically that will start the pre-round timer and add a comment for this because this will be our check if player won game, start next wave. And we'll show bubble 1 zoomed. And now we're calling our pre-round timer. So basically this is like our grace period. How much time does the player have before the next round starts? So off of here, what we can do is just do a set timer by event. So the set timer by event will allow us to call a custom event. So off of the event, we need to add a custom event that will get called. And this will be called start next wave. And then for the time, we can set a time. So we'll set this to 30 seconds. So basically after 30 seconds, we'll call that event, which will be our start next wave. Then to start the actual next wave, all we have to do is call our spawn skeletons function or event. So basically after 30 seconds of waiting, we'll call our spawn start next wave, which we'll call our spawn skeletons event up here, which will get our current wave, which we increase to 2. And then we'll calculate how many skeletons we need to spawn. Then for each of those skeletons, we'll go ahead and spawn them at random spawn locations. Now what I want to do is I actually want to decrease this time to, let's just say about 5 seconds, just so we don't have to wait 30 seconds for the sake of this video. But let's go ahead and hit play and kill all the skeletons. Reload our gun here real quick and kill all the remaining skeletons. So all skeletons are killed, next wave starting soon. So we should see a total of 8 skeletons spawn in. And any second now, it should call that event. And maybe we need to go ahead and actually take a look at our logic. Maybe we actually missed something. Let's go back to our tower defense game mode. And off of our count skeletons killed, it looks like we forgot to call our wave increment. So off of our count skeletons killed, off of this print string, we want to call our wave increment. So basically when we kill a skeleton, when all the skeletons are killed, we have 0 skeletons left. We want to call our wave increment. To increment the wave, start the pre-round timer, wait 5 seconds, and start spawning skeletons. So now we should be able to actually test that out. Let's go ahead and kill all the skeletons real quick. Shoot and damage all of them. And one last one. So all skeletons are killed, next wave spawning soon. In 5 seconds, we should see all the skeletons spawn in. And as you can see, it spawns in 8 skeletons total. So we have a whole ton of more skeletons being spawned in, and they're doing a lot of damage to the keep. So if I were to continue to kill all the remaining skeletons real quick, I can show you that the logic will basically just keep looping and looping for however many max waves that we have set up. So let's kill all the remaining skeletons in here. And now next wave, all skeletons are killed. Next wave starting soon. We should see a whole lot more skeletons spawn in. And as you can see, it will just increase and keep getting harder and harder for the player because there'll be more and more skeletons spawning in. So that is our very simple game mode logic for our skeletons spawning in, keeping track of the current wave and the next wave, and calculating how many skeletons should be spawned in based on our current wave. So what we set up in our previous lecture is we set up some simple wave-based logic for our game mode. So we set up the game mode, which handles calculating how many skeletons should we spawn in, how many skeletons are left, and when should we start the next wave based on if all the skeletons are dead. What we want to set up in this lecture is we need to set up some visuals for the player so that the player can see what current wave they are on, how many skeletons are left in the level that they need to clear, and then later on we need to set up things like how much time do they have during the grace period before the next wave starts. So we'll need to set up widgets or visual indications on the player's screen. That way the player will know and see these values on their screen. So in order to do that, we'll need to go to our widgets and open up our main HUD widget. And in our main HUD, we're going to add a simple widget on the top left that will show us our current wave and how many skeletons we have left. So let's, in our palette, search for a border and drag and drop a border onto our screen, and we'll just size this up like so. And select this border, and we're going to go ahead and modify the brush color. We'll actually rename this border first, so rename the border to Wave Info Box. And then in the appearance under the brush color, we can change the brush color. We can change it to a dark tint like so. And we can give this an alpha of 0.7 so that it's a little bit transparent like so. And hit compile and save. And then into that border, we can add a vertical box. So search for vertical box and drag and drop it onto that border. Then inside of that vertical box, we want to add a horizontal box onto that vertical box. And then inside that horizontal box, we want to add some text. So search for text and drag and drop it into that horizontal box. Now with that text selected, we want to set this to fill. So it fills all the way around. And we want to set the justification to center align text. Then for the name, we can change this to wave : 1 out of 10. And we can increase the size. So we'll increase the font size to 35, like so. And we could change the font style. We can change the typeface from bold to regular. And just compile and save that. And then we want to add another border. So search for border. And just drag that border into our vertical box. So it should be right below the horizontal box, like so. And we'll just add a nice line to separate, the wave from the rest of our text that we'll add. So right below that border, we want to add another horizontal box onto our vertical box. So it should be right below the border. And then onto that, we can add a text. So search for text and drag and drop it into that horizontal box. Then with that text selected, we want to set that to fill. So select the text and set that to fill, and set that to center align text. So align text center, and rename this to skeletons left : and I'm going to set this to regular. So change the typeface from bold to regular, and compile, save that. Then right below that, we can copy actually our horizontal box. So right click and copy that horizontal box and paste it on our vertical box again. So we should have that duplicated, and select that text, and we can go ahead and rename this to 5 out of 10. So that will just show how many we have left. And I'm going to change this to italic like so, and just compile and save. And just to set this to fill all the way around, just to adjust some of the settings, I'm actually going to select this wave text. So make sure that you have that selected. And I'm going to give this a padding of 10 all the way around. That way it will kind of space things out. And let's take our wave info box, this border, and just move this up. And just hit compile and save. And this border is already anchored to the top left, so we already have the anchor set up. And now if we go ahead and hit play, we should be able to see that wave 1 out of 10 and the amount of skeletons we have left. So now all that we have to do is we need to update that text so that when I kill a skeleton, it will update how many skeletons are left. And also if there's a new wave starting, we want to update the text for the wave text. So let's go back to our main HUD and select the text. Select the wave text, set that to a variable and rename this to wave text. Also select the skeletons left, so this text down here, the 5 out of 10. Set that to a variable and this will be our skeletons left. So compile and save that. Then we'll need to add events to update those texts. So head over to the graph, and in the graph we can program in the logic for updating the text. You can see we already have an event for updating our ammo text. So basically this will be sort of the same exact logic that we have set up, but in our case we'll be setting up and updating the skeletons left and the wave text. So we want to right click and add a custom event and name this to update skeletons left. And this event will have 2 inputs, so add a new input, change this to an integer, and just rename this to skeletons left. And then add another variable, and this will be the total skeletons, and compile save. So now that we have both of those values, we can set our skeletons left text. So get that on the graph and do a set text. We want to choose the set text here at the very bottom. So hook up the execution, and for the in text, we want to format that. So off of here, we can do a format text. And for the format right here, we can type in squiggly brackets current, and then do a slash and squiggly brackets total. And then press enter. Now we'll add a pin for current and total. So if you format it exactly like this, we'll add those 2 inputs. So we can just take our skeletons left and do a toText integer. So convert our integer to a text and plug that in for the current. So that will be our current skeletons left. Copy and paste this again, and for our total skeletons, we'll plug that in for the total. Then just add a comment and name this to update skeletons left text. So compile and save that, and now we have our update ammo text and our update skeletons left text. But we also want to update our waves text as well. So again, down here, we're going to right click and add a custom event and do the exact same setup, but this will just be for our updating the waves text. So name this to update waves text. Have 2 inputs. The first one will be our current wave, and then the next one will be our max or total waves. So compile and save. And then all we have to do is get our waves text on the graph and do a set text. We'll set the text, hook up the execution. For the in text, we'll do a format text. And for this, we'll type in what we have set up. So you can see that in the graph or in the designer, we have wave colon 1 out of 10. So in the format text, we'll do wave colon current brackets colon squiggly brackets current. Then do a slash squiggly brackets max or total waves. So if you press enter, it'll add a pin for current and max. So all we have to do is take our current wave and do a toText integer, plug that in for the current, and then also do a toText for our total waves and plug that in for the max. And then just add a comment for this. This will be called update waves text. So we'll update the waves text of our widget. And now all that we have to do is call these 2 events whenever we kill a skeleton and whenever we update the wave. So to do that, all we have to do is go into our third-person blueprint. So let's go to our content, core, blueprints, open up our BP third-person character, and we'll need to add an interface to our third-person character so that we can update and call those interface events and call those update widget events. So we'll need to add a blueprint interface for our character so that the game mode can call that interface on the character. So we'll want to go to our interfaces, and in our interfaces, we want to right click and create a new blueprint interface. So select the blueprint interface, And we'll rename this interface to BPI_pirate character for our pirate character interface. So just double click and open this up. And we're going to rename this function to update skeletons UI. So basically how many skeletons we have left. And select that function, and we want to add 2 inputs because we want to pass some information to the character. So the first value will be an integer. This will be the skeletons left. And then add another input, which will be the total skeletons. So compile and save. And we want to add one more function in here called update waves UI. And add 2 inputs. So the first one will be our current wave, and the other input will be a max waves. So compile and save that, and now we have those 2 interface functions. So we just want to add this interface to our third-person character blueprint. So in order to add an interface, we want to go to class settings, and under the implemented interfaces, click the drop-down for add and search for our BPI_pirate character interface to add it. Hit compile and save, and now we should have those 2 interface events. So we have our update waves UI, update skeleton UI. So to add those interface events, just double click on them, and then we'll implement and add those events onto our event graph. And we can select these and move these over. And we'll move these right next to our create main HUD widget. So down here on the graph, to call the respective events in our main HUD, all we have to do is give our main HUD widget reference. So we can get that on the graph, and then we can call those events that we set up in our main HUD. So we have our update waves text. So we can call that event and plug in our current wave to the current wave and max wave to the total waves. And we can also get our main HUD down here and call our update skeletons left event. And that will update the skeletons text. So we can hook up the skeletons left and the total skeletons like so. So let's just add a comment for this. So select both of this and add a comment and name this to update UI events. And we'll just click show bubble when zoomed. So basically we have an interface events that will update the main HUD and call that update waves text and update skeletons left, which will update the player HUD text so that the player can see how many skeletons are left and how many current waves do we have left. So now all that is left to do is to call these interface events from inside of our game mode whenever a skeleton is killed or whenever the next wave is starting. So let's go to our blueprints in game mode and open up our tower defense game mode. And in our tower defense game mode, we want to go all the way up to when a skeleton is killed. So when a skeleton is killed, we want to go ahead and update and call that interface on our character to show that the skeleton has been killed and update the player's UI to show how many skeletons are left. So in order to do that, we need a reference to our character blueprint. So currently we don't have a reference to our character blueprint. So the way that we'll get a reference to our character is we want to go to our event begin play, and we want to modify this because currently we're getting references to our spawn points. So in addition to getting references to our spawn points, we also want to get a reference to our player character blueprint. So off of the event begin play, we can do a sequence. We can call the sequence node. And that will just allow us to have more pins or more execution logic. So the first thing that we'll do is we'll get all actors of the class spawn point. And then the next thing that we'll do is we'll want to get all actors of class. And we want to search for our BP_third person character blueprint. And then for that, off of our out actors, we can just get that array. We want to get the first thing that we get in that array. In our case, it should be the first index in that array, which is our character. We want to take that and promote that to a variable and name this to our character reference. So that will be our character reference. So now we're getting our character when the game is started, and we're saving a reference to our character blueprint, which then we can use to call our interface events. So now we can go down here to our count skeletons killed. And basically what we can do is, let's expand the comment. So off of our wave increment, we can get our character reference on the graph. Whenever you have a reference to something like your character or any sort of reference, you want to make sure that it is valid. So you want to do a is valid check. And then if it is valid, we can call our interface. So we can call that update skeletons UI. We want to call the message. So we'll call that interface message. So update skeletons UI message. So we'll call that interface event in our player character or in our pirate character. And now we just need to plug in the skeletons left and the total skeletons remaining. So when we want to get our skeleton total, plug that in for the total. Then we also want to get our skeletons left and plug that in for our skeletons left. So now we're passing those variables to our character, which in turn will be updating the UI on our player screen. Also for the false, we want to also take that and plug that into the is valid, because if our skeletons are equal to 0, we'll also want to update our skeleton UI. So off of the false, we'll plug that in for the is valid, and let's add some reroute nodes. So double click to add some reroute nodes like so, and compile and save that. So we're updating our skeletons left UI. We also want to update the waves UI. So down here on the start next wave, we also want to call that update waves UI event. So let's expand the comment over here. And right over here, what we want to do is get our character reference and do a is valid check. We just want to check and see if it is valid. And then if so, we can call that update waves UI. We want to call the update waves UI message, the interface message. So hook that up for the is valid. Then we want to plug in our current wave. So get our current wave and plug that in like so. And our max wave, get our max wave and plug that in like so. So compile and save. And then off of our game 1, we can plug that in for our update waves UI, and also our pre-round timer, we can plug that in for our update waves UI. So basically, when we're incrementing our wave, we're checking to see what our current wave is equal to our max wave. If not, we're going to increment our current wave. So we're going to increase our current wave to from wave 1 to wave 2. And then we'll update our waves UI in our player widget so that the player can see that we are starting the next wave. So now we can test this out. We should be able to see the skeletons left update whenever we kill a skeleton. And we should also, in addition, see when the next wave is started. We should see that wave increment to see that the next wave has been started. So let's go to our first person map and hit play. And now you can see we can update the user interface. So we have wave 1 out of 10, skeletons left 3 out of 4. And let's go ahead and kill a skeleton. You can see it's 2 out of 4. If I kill another skeleton, it's 1 out of 4. If I kill this skeleton, it's 0 out of 4. So now we're on to wave 2. You can see it's wave 2 out of 10. And now we have skeletons left 0 out of 4. Now currently we need to update the skeleton's text, because when we start out, when I hit play, you can see that it says 5 out of 10 by default. So the way that we can change that is in our third person character. Actually, we can go to our blueprints widgets. Let's go to our core widgets, main HUD. Let's change this default text to be 4 out of 4. So we have skeletons left 4 out of 4, because on the first wave we have 4 skeletons left. And then when the next wave starts, we want to update the text. So basically when we spawn the skeletons, we want to update the text of how many skeletons we have left. So let's go to our tower defense game mode. And over here in our spawn skeletons in game, off of the completed, after we spawn all these skeletons, we want to update our player's widget or update the skeleton's UI. So let's actually move all this up here and move that up like so. Because off this completed, what we want to do is we want to do a is valid check and see if our character reference is valid. And then we want to go ahead and call that update skeleton UI message, hook that up for the is valid. And for the skeletons left, we can plug in the skeletons left. For the total skeletons, we can plug in the skeleton total. So compile and save, and now we should see that update when the next wave starts. So we have 4 out of 4 skeletons. Let's go ahead and kill all the skeletons in the level. So let's go ahead and eliminate these guys over here. So now you can see it's 0 out of 4 left. We're starting the next wave, and when the next wave starts, you can see it's automatically updated. We have 8 out of 8 skeletons left. So we can go ahead and test this out even further. We can kill all the skeletons. You can see that it's updating the text. We have 5 out of 8. Kill some more, 4 out of 8. Got to kill 4 more. So we have 2 left. We can kill these guys over here. And 1 left. We can kill that one over there. Now you can see it's wave 3 out of 10. And again, it'll update the text. So you can see it's 12 out of 12 skeletons left. And it will just keep on updating it as every wave increments and increases. So the next thing that we're going to be setting up is we're going to need to set up the items that the player can purchase so they can help defend themselves against the skeletons attacking their tower. So we're going to create 2 different items in this course. The first one will be an explosive barrel. So the explosive barrel item will be an item that the player can place down, and if a skeleton or multiple skeletons walk by it, the player can shoot that explosive barrel and it will deal sort of a AoE damage. So it'll affect within a certain radius of the barrel. So if there are skeletons standing nearby, it will automatically apply 100 damage to the skeletons and kill them off. So let's go ahead and get started. So first things first, we need to go to our core blueprints folder, and in here we're going to right click and create a new folder and name this to items. And then we want to go back to our core folder, and in here we want to make a new folder for meshes so we can import our custom meshes. So in our meshes folder, we're going to right click and create a new folder for barrel, and then double click, open that up. And then you'll need to go ahead and download the project files and go to the pirate game meshes barrel, and we're going to just go ahead and drag and drop our sm explosive barrel.fbx and just do a import all. It might say no smoothing group was found. We can just ignore that message. It'll import the mesh. Then we can go ahead and import the textures. I believe all that we're going to need is the base color, the normal, and then the metal base color and the metal normal. So I'm going to go ahead and drag all 4 of those. And once we have all those in, we can do a file save all. And let's open up the barrel wood texture. All we're going to do in here is plug in the barrel wood base color and barrel wood normal. So shift select both of those textures and then drag and drop them into your material, and delete that and just plug in the RGB for the base color. So this red texture is the base color, then this blue texture here is the normal, so plug that in for the normal map and save that. And we can close out of there and open up our metal material. And again, same thing, we can shift select these 2 textures, the metal base and the metal normal, drag and drop it in there, delete the parameter, take our color and plug that in for the base color, and take our normal and plug that in for the base normal. And then I believe I set the metallic in here to 1. That's all the settings I set, so just save that and close out of there. And our barrel should be all set. So we have our SM explosive barrel model. So now we can go ahead and create the blueprint. So let's go to our core blueprints, items, and in here right click and create a new blueprint class of the type actor. And you can rename this to BP_explosive and just double click and open this up. So in the viewports and the components, we want to add a single static mesh component, which will be our barrel mesh. So select that static mesh component, and in the details we can change this to our barrel, SM explosive barrel, and just compile and save that. And then head over to the event graph where we can set up the logic for this. So we can go ahead and delete all of these events on the graph because we only need to set up one event, and that is if there's any damage applied to this barrel. So currently our player, the way that our player is set up is that when we fire our line trace, when we shoot our weapon, it will apply damage to any actor that we hit, regardless of what type of actor it is. So in our case, if we shoot this explosive barrel, it will apply damage to this explosive barrel. So all we have to do to implement the explode logic when the player shoots this barrel is right click and search for the event any damage. So we can add this event any damage. So if it takes any damage, we can just go ahead and explode the barrel. So off of this, we only want to do that logic once. So we want to do a do once. That way, if there's any additional damage applied to the barrel while it's exploding, it won't explode twice. So off of the completed, what we want to do is we want to spawn an emitter. So do spawn emitter at location. The emitter that we want to play is a big explosion. So search under the emitters. We have a lot of different explosions. This is again from the military weapon Dark. So make sure that you have that downloaded from the marketplace. But this is called P_grenade. P grenade explosion 01. So this will be a big explosion. For the location, we can just drag off here and get actor location. Get the location of the actor in the world. And then what we want to do is, now that we're playing explosion effect, we want to check and see if there's any actors nearby the barrel. And if there are, we can apply some damage to those actors. So to do that, we want to do a sphere overlap actors. So the sphere overlap actors will do a sphere trace, where the center of the sphere position will be our actor location. So right click and search for get actor location and plug that in for the sphere position. For the radius, this will be 300. So that will be how big the sphere will trace. Then we need to make an array for our object types. And we only want to overlap pawn. So basically, we only want to check and see if we hit skeleton. And then the actors to ignore, we can do a make array and just get a reference to ourself. So we ignore ourself. We don't want to damage ourself. But then off of the return value, we can do a branch, whether or not we actually hit anything. And then if so, off of the out actors, this will return an array. So we can do a for each loop. So for each of the actors that we hit, we want to apply some damage. So off of the array element, we can do a apply damage node and hook up this for the loop body. And then for the base damage, we want to set this to 100. So if it's a skeleton, we can just apply 100 damage, which will kill immediately the skeleton. The damage causer, we want to get a reference to self. And the damage class will be our damage type. Then what we want to do is off of the completed, we want to destroy actor. So I will go ahead and delete this explosive barrel from the level because it's exploded. It's applied some damage if there are any players, but also off of the false if we do not trace and hit any players. If the player accidentally shot the barrel and there's no skeletons nearby, we also want to destroy this actor. So now we have our basic logic for when the barrel is shot. When it receives any damage, it will spawn this big explosion emitter. It will do a trace to see if there's any skeletons nearby. If there are skeletons, we'll apply some damage to all of those skeletons. If not, we'll go ahead and destroy ourselves. But also after that loop is finished, we'll destroy this actor as well. So now we can test this out by just dragging and dropping this into our level and hitting play. And if I shoot the barrel, it looks like it is not receiving any damage from us. And I believe that is because we need to go into our core blueprints third person character. So BP third person character. And the reason why it's not receiving any damage is we need to go into our fire pistol function. And over here, you can see that in our line trace function, we only apply damage if the actor has the tag skeleton. In here, we can modify this logic to include damageable things. So for example, we want to be able to damage and apply damage to our barrel. So what we can do is do a OR boolean and plug this in for the condition. And the other condition that we can check is if the actor has tag, and we can create a new tag called damageable and plug that in for the OR condition. So basically, if the actor that we're hitting with our line trace from our character, if it has a tag skeleton or if it has a tag damageable, then we can apply damage to it. So all we have to do is copy this tag and go to our explosive barrel and head over to class defaults and search for tags. And we can add a new tag named damageable. So make sure that it has the same capitalization, punctuation, and spelling as what you've added in your third person character. But now if we hit play, we can go ahead and shoot the explosive barrel. And you can see it fires off a particle effect. In our case, we actually need to move this closer, so it'll be in the path of the skeletons. Let's hit play. They should run up near it, and if I shoot it, you can see that it does a big enough trace that instantly eliminates all 4 of the skeletons at once. So the explosive barrel will do a trace about 300 units from the center of the barrel, and if there's any skeletons in that radius, it will apply 100 damage instantly and kill instantly the skeletons that are nearby. So the explosive barrel will be a very useful item for the player to defend their tower in this game. So we set up our first item, which is the explosive barrel that the player can buy. Next up, what we need to set up is the cannon turret. So basically the cannon turret will be an item that the player can place down, and the cannon will automatically rotate and focus on an enemy target, in our case a skeleton, and every couple of seconds it will shoot a cannonball at the skeleton, in which if the cannonball hits the skeleton, it will go ahead and damage it and kill the skeleton. So basically the cannon turret will allow you to place down sort of these turrets that will help you defend your tower against the different waves that will be spawned in. So let's go ahead and get started. So first things first, we need to go to our core meshes folder, and we'll need to right click and create a new folder for our cannon. So in our cannon folder, double click and open that up. You want to go and get the project files if you haven't already. And under the meshes cannon folder, we need to go ahead and import both of these meshes, the cannon and the cannonball. So shift select both of those and drag and drop them and click import all. And we can close that message. No smoothing group was found, but we have our assets in here. We can do a file save all. We also want to import the textures, so shift and select all the textures here and drag and drop them into our folder. And once those are imported, we can do a file save all. And we can set up the materials. So let's set up the first material, which is this Lambert 1. So double click, open that up. We can shift select all of the textures and drag and drop them in the material. And in here, I delete the parameter. We can take this base color and plug this in for the base color. And this blue texture is our normal map, so we'll plug that in for the normal. And then this other one is the metallic and the roughness. So the G is the roughness, and the B is the metallic. So that is looking good. We can save that and close out of this material, and then that is actually all set. This is just the mesh, so we set up both of the materials. So we have the cannon and the cannonball. So now let's go ahead and set up the blueprints. So let's go to our blueprints, items. First things first, we'll set up the cannon. So right click and search for blueprint class. And we're going to choose the parent class of pawn. So we're going to use the pawn. So select that and rename this to BP_turret cannon. And double click and open that up. And the reason why we're using the pawn class is we're going to add a pawn sensing in here, so that whenever a skeleton runs within the range of the cannon will rotate and track the target. Basically, we'll set up the on sensing component, just like we set up in our skeleton enemy. So in the components, we'll need to add first a static mesh component for our cannon. So select that and search for our cannon, our SM cannon, and select that like so. Then we'll need to rotate this and scale it up. So rotation, we're going to change this to 90 on the Z. So it should be rotating this direction. And then for the scale, I set this to 1.5, 1.5, and 1.5, just so it's a little bit larger in our scene. And then we want to add a pawn sensing component so that this cannon will be able to sense or see any targets. So we want to add a pawn sensing component right here. So again, the pawn sensing component will allow the cannon to see if there's anything in front of it, and that will allow us to program in some logic to track the target and shoot and fire cannonballs at it. So we'll need to modify our pawn sensing component. So select that, and in the sight radius, we can modify how far the cannon can see or what is its range. So I'm going to set this to 1,650, so 1,650 for our sight radius, and we can uncheck only sense players because we want to sense other types of pawns as well. Then for the peripheral vision angle, I set this to 180 so that it has better field of view and it can track more targets that way. So now all we have to do is click on the on see pawn. So click on that event, and now we'll add an event for when we see a pawn. And we can actually go ahead and delete all these other events. We don't need that. But down here, what we can do is we can check and see if the pawn is a skeleton. So the first thing that we'll do is off of here, check and see if the actor has a tag. If the pawn that we're seeing, is that a skeleton? So type in the skeleton tag, and then off of here do a branch. Because we only want to track and attack skeletons. We don't want to attack the player. And then if so, off of the pawn, we want to do a is valid check. Just make sure that that actor is valid. And then if so, we want to go ahead and check and see if we currently already tracking a target. Do we already have a target in our sights that we're tracking? So we'll need to add a new variable to store that. And we'll name this to has target question mark. So if we currently have a target, and then we'll get that on the graph and do a branch. So if the pawn that we see, if it is valid, if so, we want to check and see if we're currently tracking a target. Then if we are not tracking a target, actually what we want to do is do a not Boolean. So if we do not have a target, then we offer the true, we now have a target because we've sensed this new skeleton. So now take that pawn reference right over here, and we want to take that and promote that to a variable because this is now our new target. So this will be our target pawn. So because we don't have a target, now we do because we sense this pawn. So we have a target, we set that to true, and now we can go ahead and set a reference to the pawn that we sense, which is now our target pawn. So we're saving that reference because now what we want to do is track that target. So down here we want to right click and add a custom event that will be called track target, and compile save, and then we just want to call that up here called track target. And let's add a comment for all of this so far. This will be our event see target. So basically if we see a target, we'll check and see if we are currently tracking a target. If not, then we'll set that as our new target, the thing that we saw, and we'll track it. So for our track target logic, basically how this will work is once we have a target, we can rotate the cannon to face that target. So it's sort of like tracking it. That way, every time we shoot a cannonball, it will be in that target's direction. So for our track target, we'll need to have sort of a timer event. So an event that will fire off on a timer to rotate our cannon. So off of here, we want to use the set timer by event node. So that will go ahead and set a timer. So we can plug in an event that we want to fire off. So drag off here and do a add custom event. And we'll name this to move turret. So that will rotate the turret. We want to do this every 0.05 seconds. And we'll set that looping and max once per frame. Then we'll take the return value and promote that to a variable and save a reference to that and call this our timer reference. So we just want to save a reference to that because if for whatever reason, if our target is dead, as in if we shoot the target and if it dies, then we want to go ahead and stop our timer and stop tracking the target. So we just want to save a reference to our timer. So then for our move turret logic, we're going to get our target pawn on the graph and do a is valid check. We want to do the is valid check because if the pawn is dead, then we're not going to be able to track it anymore. It's dead. We can go ahead and start tracking another target. But if it is not dead, meaning if it is valid, we can go ahead and set the rotation of our actor, in our case our cannon, to rotate and face our target pawn. So off of our is valid, we're going to use the set actor rotation node. And for the new rotation, we want to right click and split the structure because we're going to do some math to calculate what rotation should we set our cannon based on where our pawn is located in our level. So the way that we'll do that is off of our target pawn, we want to get the actor location of our target. And then we also want to get the actor location of ourself, which is our cannon. Then off of there, we can do a find the look at rotation. So we have this find look at rotation. Basically, we'll find at which rotation value should we set our cannon so that it can look at our target pawn location based on our current location. So this will find the look at rotation. And then what we can do is off of our Z value, we only want to change the Z rotation because that will rotate the cannon in the Z axis like this. So we only want to rotate it so that it will face this target and track it like so. So off of the Z value, what we'll actually do is off the return value, we'll do a R interp. So we have this interpolation R interp2. So unhook this. For the return value, you want to right click and split the structure and only hook up the Z, because we only want the Z rotation. For the target, this will be our new look at rotation. For the current rotation, we want to right click and get our actor's current rotation. So get actor rotation, because that will be our current rotation and we're interpolating to our target rotation, which is the rotation that is facing the target pawn. We need to hook up the delta time, so drag off here and get delta, get time in delta seconds. So we have this get world delta seconds, and then our interp speed will determine how fast we should interpolate to this, and I set this value to 100. So now let's compile and save that. And off of this is not valid, we want to set this up. So basically if our target is for whatever reason no longer valid, meaning if it's dead, we can get our timer reference, which is our track target timer. We want to call the node clear and invalidate timer by handle and plug in the execution for the is not valid. So basically if our target is dead, we can clear and stop this timer from firing off. And then we want to set our has target boolean to false, because now we no longer have a target set. So compile and save that. And we can add a comment for this. So press C and add a comment. This will be our rotate cannon to face target. And so now we should be able to test this out. So basically we set up our pawn sensing component, and the cannon will rotate and face the skeleton. It will track it and it will rotate it, and if for whatever reason if the target pawn has been killed, then we'll clear and invalidate the timer and stop and set our has target back to false. So let's go ahead and drag this into our level and hit play. You can see it automatically is tracking the target and is rotating to face that target. And so if I hit play again, you can see it automatically lock in to a target and it will start moving and tracking it. Now currently we don't have any other logic set up, so it's not going to shoot at the skeleton. Right now it will just lock onto a target that it sees and track it. So in our previous lecture, we set up our basic cannon logic for our cannon turret. All that it does right now is it tracks a target when it sees an enemy skeleton. So now what we want to set up next is when it sees an enemy skeleton, we want to set up the firing logic so that it will fire a cannonball every couple of seconds, and that cannonball will apply some damage to the skeleton and it will one tap the skeleton, so it will do 100 damage to it if it hits the skeleton enemy. So let's go ahead and get started. So first things first, we'll need to go to our BP turret cannon, and down below our rotate cannon to face target, we're going to right click and add a new event. So right click, add custom event, and we'll name this to fire loop. And this fire loop will happen or get called up here on our event C target. So expand this and call that fire loop. So just make sure that you're calling this event up here when we see the target. We want to start the fire loop event down here. So for our fire loop event, again, we want to do a set timer by event because we're going to do some looping logic. And in our case, for the time, we want to set this to 4 seconds because only every 4 seconds will we call this event. And for the event, we'll add a custom event named fire cannon. We'll set this to looping, and then for the return value, we'll take that and promote that to a variable and call this our fire timer reference. And compile save. So the fire rate of the cannon will be slow, only every 4 seconds. And that will just make it so that it will be a little bit more balanced, so that the cannon will fire off a cannonball that will do a one shot. So if it hits the skeleton, it will instantly destroy the skeleton. But it's limited because it's only going to fire off every 4 seconds. So you just want to make sure it's balanced and not spamming cannonballs across the map. So for our fire cannon event, we want to first check and see if we have a target. So we want to get our has target and do a branch. So we just want to double check and make sure that we have a target. in order to fire our cannon. And then if so, we want to check that target. So we want to get the target pawn, get it, and right click and convert this to a validated get. So click on convert to validated get and hook this up for the true. So if we have a target, we want to check and see if our target pawn is valid. And if it is valid, we want to do a check. And that check is to see if the skeleton is dead. So the way that we'll do that check is we're going to add an interface for that. So we want to go to our blueprint interfaces, and we don't have an interface set up for our skeleton character. So we can add an interface for that real quick. So just right click and search for blueprint and select the blueprint interface and just name this to our BPI underscore skeleton character for our skeleton character blueprint interface. And then double click open that up. And this will just only have one function, which is get is skeleton dead ? Basically, we're checking to see if the skeleton is dead. So since we're getting if the skeleton is dead, we want to return or output a Boolean whether or not the skeleton is dead. So rename the output and name this to is dead ? Compile and save. And then we want to go to our blueprints skeleton and open up our BP skeleton. So in here, we can go to the class settings and under the implemented interfaces, add our BPI underscore skeleton character blueprint interface. So now we have that BPI skeleton character interface, compile and save. And now to finish that interface event, under the interfaces, we have this get is skeleton dead. So if we double click on this, since we are having an output, what that does is it creates this interface function where basically we have this function that we're inside and we're only returning this value, this variable is dead. So all we have to do inside of this interface function is plug in our is dead Boolean and return whether or not the skeleton is dead. So we're getting our is dead variable and returning that. And now what we can do is in our turret cannon, off of our target pawn, we can call that interface get is skeleton dead interface message. And now we're returning that Boolean whether or not the skeleton is dead. So now we can determine whether or not the skeleton is dead. So we can do a branch off of that. And if the skeleton is dead, then we don't want to fire our cannon because, well, the skeleton is dead. Our target is dead. We are in no longer need to fire our cannon. So we can actually get our fire timer reference and do a clear and invalidate timer by handle and just hook that up like so. Now, if our skeleton is not dead off the false, then we can go ahead and spawn in a cannonball to shoot our target. Also, off of the is not valid and also off of this false, we want to also clear our timer for our fire ref timer. So copy and paste this down here. Hook this up for the is not valid and also the false. So basically, if we no longer have a target and if our target pawn is no longer valid, we can clear our fire timer reference. So compile and save. Now for this last part, we need to spawn in a cannonball, but we actually need to create the cannonball blueprint first. So let's go to our blueprints items, and in here we'll right click and create a new blueprint class of the type actor and name this to our BP underscore cannonball. And let's do a file save all. So we'll need to set up our cannonball logic. So open up our BP cannonball, and in here first we'll need to add a sphere collision. So click on the plus icon and search for sphere. And we need to add this sphere collision. So select that. And once we've added that sphere collision, we need to make this as the default scene root. So in order to do this, it's very important that you do this, otherwise our projectile will not work. You want to take the sphere and drag and drop it onto the default scene root. And now the sphere is the default scene root. So we have this cannonball itself and then the sphere. So you just want to do that because this will allow us to set up this cannonball as a projectile that will fire off when we spawn it. So now onto that sphere, we can add our static mesh component and select that, and we can, in the details under the static mesh, set our cannon ball mesh like so. Then we'll just want to scale this up because right now you can see it's a little bit tiny. So we'll set the scale to 2, 2, and 2. So the scale will be 2 all the way around. We'll also want to add a particle system, basically sort of like a trail. So when this cannonball is fired off, we want to have a trail of smoke behind the cannonball, just so it has sort of a visual on it. So under the components, we can add a particle system, a cascade particle system. Since we're using the old particles from the military weapon pack, those are legacy particles, which are called cascade particle systems. If we were making new particle systems, they would be called Niagara particle systems. But since they're the older ones, we're going to be using the older particle system component. So we can actually just attach this to the sphere, like so, by dragging and dropping it. So it should be right next to the static mesh. But select that particle system, and in the details, we can set the particle. So under the template, we can hit the drop down and search for our P_grenade trail. So we have this grenade trail. And basically, it's sort of like this smoke trail that will be spawned in behind this cannonball. So it'll look like a cloud of smoke in a trail behind the cannonball. Then lastly, we need to add a projectile movement to actually move this cannonball. So under the components, search for projectile and add a projectile movement component. And then select that component because we'll need to configure the settings. So in the details, we can set under the projectile the initial and max speed. So this will be how fast this projectile will move when we spawn it in the level. So we need to give these some default values. So I set mine to 4,000 for the initial speed, and the max speed I set to 4,000. So that will be our projectile speed. And then also for our projectile gravity scale, I set this to 0.3. So that will be the gravity scale. 0 for no gravity if you want it to just fly in a direct line. But this will allow for a little bit of fall off, so the cannonball will not directly go straight. We'll have a little bit of fall off at the end. And then you can configure other settings down here, but I believe that's all that we need to configure for now. So let's head over to the event graph. Let's delete all our event begin plays. And actually, just to see this in action for now, what we can do is we can just spawn in this cannonball. So we set up all the basic logic for our cannonball, all of the components. We can go back to our turret cannon and actually just spawn in the cannonball to see it be spawned in. So off of this false, we can call the spawn actor from class node to spawn the actor in. For the class, we'll search for that BP_cannon ball actor. For the spawn location, we want to spawn this at a certain location. So first things first, let's go ahead and go to the viewports of our cannon here. We want to spawn this projectile right in front, right at this position, right in front of the barrel of the cannon. So the way that we'll do that is we'll add under the components a arrow component. And we can move this arrow up and over. And we can just basically position this in front of the cannon like so. And we can just get that arrow's world location right here. So we can use that for the spawn transform. So now we can get the arrow location or get the arrow components and get world transform. Get the world transform of that arrow and plug that in for the spawn transform. So hook up the execution like so. And now we're going to spawn in that cannonball right in front of the barrel of our cannon turret. So let's go back to the event graph and add a comment for this. This is our fire loop logic. So basically this fire loop logic, this event is called up here when we have a target. We're going to call our fire loop. So every 4 seconds, we're going to be looping, calling our fire logic. We're going to check and see if the skeleton is dead. If it is not, we'll spawn in our cannonball, which will spawn in our projectile, our cannonball projectile. So let's go ahead and test this out real quick. Let's hit play, and we should see a cannonball be fired off. So you can see that it fired off a cannonball. It has a little particle effect trail as well. So you can see what the smoke looks like. And currently, you can also see that it is shooting through the wall. Because we haven't set up the projectile quite yet, we haven't set up the hit event when the projectile hits something, and we haven't set up all those settings. But as you can see, the cannon is now doing its firing loop. Every 4 seconds, it's firing off a cannonball, and the cannonball projectile is moving towards the target. So what we're going to finish setting up in this lecture is we'll need to set up the cannonball hit logic. So basically we set up the turret to fire the cannonball, and the cannonball projectile movement is set up. The only thing we need to set up is when the cannonball hits something, we need to set up the logic for it to apply damage to a skeleton and also play a little explosion particle effect. So open up your BP cannonball blueprint and head over to the event graph, and we have an event for if we hit something. It's just called the event hit. So that will get called when this cannonball hits something. Now, in order for this event to actually get called, we need to change the collision settings. So in the viewport, you want to select the sphere. This is our collision, the sphere collision. Scroll down until you see the collision settings down here. So currently our collision presets are set to overlap all dynamic, which means that it will overlap any actor that it hits, which we don't want. We want it to block whatever it hits. So change this from overlap all to block all, and just hit compile and save. And now when this collision hits something, this event hit will get called. So for this event hit, what we want to do is spawn an emitter. So we'll call the spawn emitter at location. And the emitter that we want to spawn is our big explosion. So we want to search for P_grenade explosion, and compile and save. And for the hit location, we can plug that in for the location. So wherever we hit something, we'll play that particle effect at. Then what we want to do is we want to set our static mesh, which is our cannonball. We want to set that to hidden. So we're going to get this on the graph and do a set visibility and set that static mesh to hidden. So we just want to make that hidden for now, just so it's not visible from the screen, because we want to do a trace, a sphere trace, to check and see if there's any actors around the cannonball, and if so, we'll apply some damage to those actors. So off of the set visibility, we'll do a sphere overlap actors. So we'll do a sphere trace. For the sphere position, this will be our hit location, wherever we hit something. For the radius, we'll set this to 100. For the object types, we need to do a make array and change this to a pawn. So compile, save. And then for the actors to ignore, we're going to do a make array. And off of here, get a reference to self. So compile and save. And then off the return value, we'll do a branch, whether or not we actually hit something. If we do hit something, off of the out actors, we'll do a for each loop. So hook that up for the true. So for each of the actors that we hit, we want to apply some damage. So off of the array element, we wanted to apply damage node. And for the base damage, we want to set this to 100. So basically, if it hits a skeleton, that will automatically do 100 damage, and it will automatically destroy the skeleton or eliminate it. And then off the damage causer, we want to get a reference to ourself, because the cannonball is the damage causer. And for the damage type, you want to set this to our default damage type class. Now off of the completed, we want to do a destroy actor, because we want to destroy this actor and despawn it from the level. Now one last thing that we need to do is we need to set a initial lifespan for this projectile. So basically this projectile will be despawned automatically even if it does not hit anything. We don't want it flying off in the distance and just going forever and ever into space. We want to give this an initial lifespan. So under the class defaults, in the details, we want to search for initial. And we have this value called initial lifespan. So this will be how long the actor will be alive in our level. So in our case, we can give this a value of 3 seconds. So after 3 seconds of being spawned in the level, it will destroy itself automatically. So we'll just give it some time to be fired off before we'll destroy it. So now we should be able to test this out. So let's hit play. And we should be able to see the cannon turret fire off its cannonball. And you can see it exploded that skeleton and killed it. Now it needs to lock onto a new target, which it has. It's found this target right here. And it's shot its cannonball. It's exploded that skeleton. It needs to find a new target, but I believe it's having some trouble because of this big cube that's in front of it. It's not able to see these other skeletons behind it. So let's go ahead and kill these. And once we kill the skeletons here, the next wave will start. So once the next wave starts, it will spawn in more skeletons, and you can see it tracks a new target and it will fire off its cannonball and damage and kill those skeletons. So that is our basic cannon turret logic and our cannonball logic. We set it up so that it will continue looping to fire off cannonballs and to continue tracking its target, which is the skeleton enemy. So the next thing that we'll need to work on is we set up our turret, cannon, our explosive barrel. Basically, these are items that the player can use to their advantage to place down in the level to help them defend the tower or the keep against all the enemies that are spawning in. So we'll need to give the player the ability to actually purchase these items and place them down in the level through what is called a buy menu. So the buy menu will be sort of a widget that the player can open up before the start of the round. So before the start of the round, we'll have a grace period of about 30 seconds for the player to place down some more defenses before the next wave is starting. So let's go ahead and start creating our buy menu to give the player the ability to purchase these items. So we'll need to go to our core folder and into our widgets. And we're going to create a new widget for our buy menu. So in here, right click and create a new user interface widget blueprint of the type user widget. And we'll need to name this to w_buy menu for our widget buy menu. So double click and open this up. And the way that we'll design this is in our palette, we want to search for a size box. So we have our size box. We want to drag and drop that onto our buy menu and then select that. And as you can see, what it does is it just creates this box that we can add content onto without the need to use a canvas. So then what we want to add is a background blur. So search for a background blur and just drag and drop it onto that size box. And select that background blur, and in the details we can give a blur strength. So that will increase the blur of this. And in our case, I'm just going to set this to 20. So that when the player opens up the buy menu, everything in the background will be blurred so they can focus on the items that they're purchasing. Then onto that background blur, we'll need to add a vertical box onto it. So just drag and drop it. And then onto that vertical box, we can add our actual items. So first things first, we'll add a text into that vertical box and select this. Actually, select the vertical box. We'll need to set this to center align horizontally, center align vertically. So our text and our vertical box should be in the exact center of our screen. Then select the text, and we're going to rename the content of our text to buy items in caps. And we'll set the scale or the font size up to 64, like so. And I'm going to set the justification to text align center. So compile and save that. Then into this vertical box, we want to add a horizontal box into that vertical box, like so. So we have our text and then our horizontal box right below it. And into that horizontal box, we'll need to add a button. So search for button and drag and drop it into the horizontal box like so. And so this button will be for our item to purchase that particular item. So onto that button, we'll need to add a vertical box onto the button. So we're going to add things like an image, a text, and the cost of that item. So first, let's add a size box for our image. So in the vertical box, we're adding a size box. And then select that size box, and in the details, we want to set the width and height override. So setting the width and height override will set the specific dimensions of that size box. So in our case, we want to set the dimensions to 200 pixels by 200 pixels. So that will make it a square like so. Then into that size box, we want to add a image. So search for image and drag it and drop it onto the size box so we can place the image of our item that we're going to buy. Lastly, we'll need to add some text. So search for text and drag and drop this into the vertical box. So it should be right below the image. And we'll need to select that text and set this to center align horizontally, center align vertically, so it's centered. And we can rename this to cannon turret, like so. And I set the font size down to 20. So let's compile and save that. Then for this image, we can set the appearance. So under the image appearance brush, we can change this to our cannon. And we have this cannon icon texture that we imported in a previous lecture. So these icons were the icons that we imported. It's in our widgets textures. We have this cannon icon. So this is the item icon that we're going to purchase for our cannon. So we set it like so. Also, we can set things like the button style. So first let's select actually the vertical box, and under the padding we can add some padding settings. So expand this, and for our left padding we'll add 10. For the top padding we'll add 20, for the right we'll add 10, and for the bottom we'll add 20. So this will give the vertical box some padding all the way around. And then also select the button over here, and we're going to actually set this to fill, because we're going to add 2 of these buttons, and we'll give this a padding of 20 all the way around. And for the style, expand under the appearance style. Under the normal, we'll change this to a dark gray tint. So save that, and then we can copy and paste that for the hovered and pressed. But for the hovered, we can give this a yellow tint. And for the pressed, we can also give this maybe like a green tint. So the tints will make the button look different when you hover or press over that. But let's compile and save that. And lastly, we want to add the price of this cannon item. So basically, how much does this item cost? So we'll need to add underneath our vertical box. You want to search for a horizontal box, and we'll need to drag and drop this horizontal box into our vertical box. So we have this vertical box, and inside that we have the horizontal box. This actually needs to be inside the vertical box, like so. So we should have vertical box, text, and then horizontal box. So it should be at the very bottom right there. So into that horizontal box, we'll need to add a size box. So drag and drop a size box into there. Then select it, and we want to set a width and height override of 40 by 40 pixels. So it should be a little square like that. And then into there, we'll add an image. So type in image and drag and drop it into that size box. And for this image, select that and change the appearance to our coin, our gold coin image, just like so. So we'll put the price of how much will it cost to purchase this item. So we'll need to add a text, so type in text and drag and drop that text into the horizontal box, so it should be to the right of that gold coin icon. Now with that text selected, we can change the text. We can name this to 100 coins. So that will be the price of this item. And we can change the color to a yellow or gold color. I'm going to change the font to italic, and we'll change the font size down to 20. And I believe that should be all the settings that we need to set. Maybe we'll need to make sure that we center align horizontally and center align vertically. That way the text is just in the center like so. So compile and save that. That is our basic item, our item button. So we can take this button and unexpand all that and just copy and paste it again to add a second item like so. Now all we have to do to customize our second item is select the image, change that icon for our barrel explosive barrel icon. Select the text here, and we can rename this to our explosive barrel. And then we can change the price of the coins, so this will be only 10 coins. So those are 2 items in our buy menu. We have the cannon turret item, which will cost 100 coins, and then we have the explosive barrel, which will only cost 10 coins. So now all that is left to do is we'll need to set up the logic for showing and hiding this buy menu on the player's screen. So in our previous lecture, we set up our buy menu widget, which basically just shows the 2 different items that the player can purchase. In our case, the cannon turret and the explosive barrel. What we want to set up is the ability for the player, when they hit the B key on their keyboard, it will show the buy menu. So the B key will be bound to our buy menu, and it will display this widget on the player's screen. So in order to do that, we'll need to first open up our widget main HUD, our main HUD widget, because this is where we're going to overlay our buy menu on. So in the palette, you want to make sure that you're in the palette and not the library. You want to search for our buy menu. So W_buy menu. And you should see under the user created our buy menu widget. So we can just take that and drag and drop it onto our canvas panel. And then we'll need to scale this up. So select the buy menu and we want to anchor this, change the anchor to all the way around. So it should place anchors all the way around. And we'll need to reset the offset left, so set that to 0. We want to reset the offset right and bottom all the way to 0. And as you can see, if we reset all those values over here, it will go ahead and make it stretch and fill the screen like so. Then we also want to set the Z order to 1. That way this will be in front of any other widget on the screen. So hit compile and save, and that is our simple buy menu. Now we want to set this to hidden by default. So select it, and in the details we want to scroll down to visibility and set this to hidden so that it's hidden by default. So compile, save, and now we can toggle the visibility in here. We can just set that to hidden because we don't really need to see it right now. But we want to, in our character blueprint, set up the logic so that we can hide or show that widget on our screen if we click on the B key for our buy menu. So the first thing that we'll need to do in order to set it up is we'll need to add an input action for our buy menu. So let's go to our core folder, input actions, and we'll need to right click and create a new input action. So right click, create a new input action, and name this to input action underscore buy menu. And then double click and open this up. So we'll just need to add a trigger for this. So under the triggers, we'll need to add a new trigger of the type pressed. So when we press this key. So save that and close out of there. And the next thing that we'll need to do is we'll need to add a binding. So we'll need to go to our input and open up our IMC default for our input mapping context. And under the mappings, we can add a new mapping for our input action underscore buy menu and expand that. We want to add a key, and the key that we'll bind this to is our B key. So just type in B and look for our keyboard B and select that like so and save that. And now we can go into our core blueprints, open up our third person character. So open up the BP third person character and head over to the event graph. And right below our reload pistol, we can right click and search for buy menu or our input action buy menu event. So basically when we press the B key, this will be triggered. This will be called. So now what we want to set up is the ability to hide or show this buy menu widget in our main HUD. So off of our triggered, we're going to do a flip flop. And the flip flop will keep track of whether or not the buy menu is open or closed. So to set it to visible, we'll need to get our main HUD reference. And then off of there, we can get the buy menu. So we can get W_buy menu cursor. So we're resetting our widget, we're hiding that, and we're resetting our input. That way we can actually go ahead and spawn in the buildable or the item that we purchase, whether that is the cannon or the barrel. We're going to spawn it into our level and put it in front of the character. That way the character can move around, and when they left click on their mouse button, they can place the structure down wherever they want to place it. So the next node is we're going to spawn the actor. So in order to spawn the structure, we'll need to keep a reference to the structure or the different items that we're going to spawn, the actual blueprint classes. So we'll need to, in the variables, we'll need to add a new variable and name this to structure types. And we're going to change this to a actor. Actor, you want to choose the class reference over here. So it's going to be an actor class reference. Then we're going to change this from a single to an array and compile and save. So now we can add different structures. So if I add an element in here, this first element in our array can be a structure that we choose. In our case, a blueprint class. So we can search for BP_turret, turret cannon. So that is our first item. And then we have another element, and under here we can search for our BP_explosive barrel item. So as you can see, we can add references to our different items, the classes that we can spawn in based on our buy menu. because in our buy menu we have our first item, which is our cannon turret, and our second item, which is our explosive barrel. And when we place those buildables, you can see that we're using the index, and then we can use that index to retrieve that structure, the blueprint class, from this array using the index. So you can see the index is 0 for the turret, index is 1 for the explosive barrel. So now we can, off of here, call a spawn actor from class node. And for the class, we can get our array, our structured types array, and we can drag off here and do a get a copy. And for the index, all we have to do is plug in our buildable index. So we can get the buildable index and plug that in like so, and plug in the return value for our class. So that will get our structure based on the buildable index, based on which item the player selected. For this spawn transform, we'll need to add a location for where we should spawn this actor in our level. And the way that we're going to do this is we need to head over to the viewport, and in here we need to select our character mesh and add a arrow component. You want to take this arrow and move it in front of the player, and this will rotate it. But basically we need to have it in front of the player, and this is where we're going to spawn the actor so that the player can place it down in the level. And actually I'm going to attach this arrow to the capsule component, so it should be over here. And then I'm going to set the values. So you have set this to 180 on the location, and then -89 on the X location. So these are all the settings that I have set. You guys can copy the location of this arrow, but that will be basically where we're going to have it. And if I hit compile, looks like we're getting an error because we need to plug in the transform for our spawn actor node. So let's really quickly just get the arrow component that we just added, and then we can get the world transform. So get world transform of that arrow, and plug that in for the spawn transform, and that will get rid of that error. So now we're spawning the actor at this location right in front of the player. Now what we want to do is we want to actually attach this actor that we spawn in to this arrow component. And the reason why we want to attach it to this arrow component is so that it's attached to the player, so the player can move around and the item will be in front of the player, sort of like if you were to place down a structure. So let's go ahead and do that logic. So we need to take the return value and promote this to a variable, and we'll rename this to build preview. So this will be a preview of what we built. Then we just want to check and see if this is valid. So we just want to do a quick is valid check. And then if it is valid, we want to attach this build to our arrow right here in front of the player. So we can get our arrow on the graph and do a attach. We want to use the attach actor to component because we want to attach this actor to this component. So hook this up for the is valid for the target. This will be the actor. So plug in your build preview into the target. And then we can do snap the target, and snap the target for location, rotation, and scale. And compile and save. So that is our settings for our spawn build preview. So now we should be able to test this out. So when I click on my buy menu, and when I click on a particular button, whether it's the cannon or explosive barrel, it will call this interface in our character over here, which will call the function inside of our character. It will check and see if we have enough coins to purchase this item. If so, we'll subtract our coins, we'll set the build index. If our build mode is enabled, we'll set that to true. We'll hide our buy menu and set our game mode back to game only. We'll spawn the actor, and then we'll attach that actor to our arrow component, which should be in front of the character. So now if I hit play, I can press B to buy an item, and I can select the cannon turret, for example, and you can see that it's attached to our character. I can move around, and we actually can't buy any more items because we're out of coins. But as you can see, this is sort of like the preview. So now what we need to set up next is we need to give the player the ability to actually place down the structure because it's in front of the player, but we want to give the ability to, when I left click on the mouse, we want to place down the structure in the world. So in our third person character, we need to go to our event graph and modify where we have our input action shoot, because this is where we have the logic for when we use the left mouse button. In our case, we're doing our shoot logic. But we want to modify this so that if we have our build mode enabled, if we have a structure in front of our player, if we left click on the mouse button, we want to go ahead and place down that structure. So let's go ahead and modify this code. So let me move this up over here, and we can move this over. But we just want to have an additional check. So off of the triggered, we can do a branch. And for the condition, we want to check and see if our build mode is enabled. So if it is enabled, we'll go ahead and place the structure down. If it is not enabled, we'll go ahead and continue with our firing logic. So we can go ahead and just move this down. So for the true, we'll create a function that will spawn in the structure. So in the functions, add a new function and name this to spawn structure function, and compile save. So inside of this function, we just need to add some logic to spawn in the actor. So we already have our build preview shown. So we just want to check and see if our build preview, you want to get the build preview variable, and we want to right click and convert this to a validated get. So we just want to check and see if this actor is still spawned in the level and attached in front of our player, because if so, we want to go ahead and destroy it. So off of here, we want to do a destroy actor, so we can despawn that actor. And then we just want to spawn in the actor again, just like we're doing in our spawn build preview. But this time we won't attach it to our player, we'll just spawn it in the level. So we can do a spawn actor from class node. And for the class, we can just get our structure types array and get a copy at our buildable index. And then we can return that for the class. Then for the transform, we can just get our arrow component and get the world transform. And then plug that in for the spawn transform. Then lastly, we just want to reset our build mode. So let's set our build mode enabled. We want to set that Boolean back to false. That way we can go ahead and place structures again in the future. So compile and save. And now off of the true, off our input action shoot, we want to call that spawn structure function for the true. So if our build mode is enabled, then we click on our left mouse button, we'll spawn that structure in front of the player. So compile and save, and now let's test this out by hitting play. If I purchase the cannon turret and place it down, you can see that it spawns in that cannon. I can't actually buy any other items because that used all my coins. And later on, we're going to add a visual to see how many coins the player has. If I hit play again, I can actually place and spawn in some explosive barrels. So I can buy another explosive barrel. And I have 100 coins, so I can actually place down at least 10 of these explosive barrels. But as you can see, our buy menu and build mode works. So I can buy a certain item, I can place it down, and I can preview where I want to place down the structure. Now one thing you may have noticed is the cannon actually doesn't work if I place it down. And that's because we need to fix a setting in the cannon blueprint. So let's go ahead and fix that real quick. So we want to go to your blueprints, items, and open up the BP turret cannon. And we need to go to our class defaults and search for auto possessed AI. So over here, since this is a pawn, this is the parent class pawn, it will need to be possessed by an AI. And currently, it only gets possessed by an AI if this is placed, manually placed in the world, meaning if I were to drag in this actor into level. So we want to change this to place in world or spawn. That way, if the player spawns in this actor, it will go ahead and get auto-possessed by an AI. So if I hit play and spawn in the turret, you can see that the turret is automatically tracking as soon as I place it down. So we know that the AI is possessing this turret cannon. Now obviously we're going to make it so that the player can only place down structures at the start of the round. That way the cannon won't automatically rotate while they're trying to, place it down. But as you can see, that is our very basic buy menu logic, so that the player can select an item that they want to purchase. They can purchase that item and place it down in the level wherever they want it. So we've added a buy menu. We need to add a way that the player can see how many coins that they have in their shop. That way they can see how many coins they can spend to purchase different items. And also we want to add a coin pickup so that the player can get more coins to purchase more items. So this coin pickup will be a simple pickup that will spawn in when the player kills a skeleton. So let's go ahead and get started. So first things first, we'll need to update our main HUD widget so that we can show the amount of coins that we have. So we'll need to go to our core widgets, open up our W main HUD widget. And over here, we're going to add a little widget on our screen that will show us how many coins we have. So add first a vertical box and drag and drop it onto our palette. And we can scale this up like so. And in here, we'll first add a text into that vertical box and select that text, and we'll rename this to, in brackets, B space key colon open shop. So this will just show us what key to use to open up the shop. And then below that, we're going to add a horizontal box below that text. So just drag and drop it into that vertical box. And in that horizontal box, we're going to add a size box into that horizontal box. Select that size box. We'll set a width and height override of 50 by 50 pixels. And then in that size box, we'll add an image. And select that image. And for the brush type, we're going to search for our coin. And we're going to use the gold coin icon that we have from our project files. Then add a text. And add that text into the horizontal box. So it should be to the right of that image. And select that. And we're going to set this to fill. And center align vertically. And we'll rename this to coins colon 100, as that's how many coins we have to start out. And we're going to set this from bold down to italic and compile and save. Then I'm going to take this vertical box and just rearrange it like so. So now we have our simple coins icon. We actually want to take this text over here, set that to a variable, and this will be our coins text, because we'll need to set the amount of coins that we have based on if we receive more coins, if we pick up more coins, or if we purchase items and spend coins. So in the graph, we want to set up that logic to update the coins. So we'll just need to add an event just like we have set up here. So right click and add a custom event and name this to update coins text. And just add a new variable in here. So under the event, add a new input and change this to an integer. And rename this to coins. And then we just need to set the text. So let's get our coins text over here and do a set text. We'll choose the widget set text. And we'll just need to format it. So do a format text. And for the format, this will just be coins colon, and then in squiggly brackets, the amount of coins that we get. Press enter, and that should add a pin. So just take the coins and do a toText integer and plug in the return value into the coins and add a comment. This will just be update coins text. And now we just need to call this event inside of our character whenever we either pick up some coins or purchase some items. So let's go to our core blueprints, open up our third person character, and we can go into our place buildable, our spawn build preview function. So over here, we subtract our coins. So when we set our coins, we need to update the widget. So to call that event, we can simply select all this and move this over. And then we can get our widget, our main HUD widget reference, and call that update coins text. So hook up the execution. And then for the coins, we can just plug in the coins value or the variable like so. So compile and save. So let's hit play. If I buy explosive barrel, you can see our coins is 90. If I purchase that item again, our coins is set to 80. I cannot purchase the cannon turret because you can see it costs 100 coins. But as you can see, we're updating the coins text on our screen whenever we purchase items from our buy menu. So now we need to add a simple coin pickup that the player can go and pick up to get some coins. So first things first, we'll need to go to our core meshes and right click and create a new folder and name this to chest. And double click open that up. And you'll need to open up the project files, and over in the meshes we have a folder for chest. So we'll need to take this static mesh chest and drag and drop it into our chest folder. Click import. Then we'll go ahead and import the chest and the material there. We'll just need to drag and drop the textures and import those. Once we have those imported, we can do a file, save all. And we'll just need to set up the material, so double click open up the material, and let's take the textures and drag and drop them inside of the material. And to set this up, let's delete the parameter there. We can plug in the RGB and plug in the normal. And I'm actually not going to use this specular map, so we can delete that. But we can just save that and then close out of there. So now we have our chest set up. So let's go to our core blueprints. And in our blueprints folder, I'm going to right click and create a new folder and name this to pickups. So this will be different things that we can pick up. And double click, open that up. We'll need to right click and add a new blueprint class of the type actor. So this will just be an actor. And then name this to BP underscore coin pickup. And double click and open this up. And in here, we'll need to add a sphere collision. So first add a sphere. So we have a sphere collision. So this will allow the player to overlap with our pickup, and when the player overlaps with this pickup, we can go ahead and pick up the item or add the coins to our inventory. So let's scale this sphere up. We want to set the scale to 3.25. So just copy and paste that for the X, Y, and Z. So that will scale that sphere up. Then onto that sphere, we want to add a static mesh component. So we'll need to add a static mesh. And in the details, we're going to set that static mesh to our chest, SM chest, like so. And we're going to scale this down. Actually, that's the scale that I used, so that should be good. Lastly, you want to remove the collision on this chest so the player cannot be blocked by it. So in the details, we want to change the collision presets from the static mesh, from block all dynamic to no collision. So compile and save. Then also we're going to add a little bit of rotating movement so that this item is spinning around and rotating. So it kind of catches the player's eye. So under the components, add a rotating component. And that should be all that we need to do. So compile, save. Let's drag this coin into the level. And you can see it's just this rotating chest that we can run through. So you can see I can run through it. So now we just need to set up the logic so that when I run through this coin item pickup or this chest, it will go ahead and add some coins to our player's inventory. So in the BP coin pickup, let's head over to the event graph and delete all these events. We want to select our sphere collision over here, and in the details we can add the on begin overlap, so when the player overlaps with the sphere collision. So add a plus, click on the plus icon for the on begin overlap. That will add the event for when something overlaps the sphere. We just want to check and see if the actor that overlaps the sphere actor has tag, and the tag that we want to check is player. So if the actor that overlaps this, if they are the player, then do a branch and hook this up for the condition. Then we'll want to copy over this tag, so copy that tag and go to our third person character, head over to the class defaults and search for tags. And we just want to make sure that we have that tag named player in our third person character. So make sure that it has the same capitalization, same punctuation as what we set in this BP coin pickup. Then if that is true, we want to do a do once because we don't want to add multiple coins to our player's inventory. And then we need to call an interface in our character to add some coins to our inventory. So let's go to our blueprints, interfaces, open up our BPI pirate character, and in here we'll add a new function and name this to add coins, and compile and save. We don't need to add any inputs because we'll just set the amount of coins to add in the player blueprint. So now go back to your coin pickup, and off of the other actor we can call that interface add coins. So add coins message and plug that in for the completed. And then after that we can do a destroy actor, so that will destroy this coin pickup because we picked up the item, we're adding the coins to our inventory and we're destroying this actor. So now let's go to our third person character and to the event graph, and we can add that interface for our add coins. So just double click on that to add that interface event. So let's take this and actually move this over to our place buildable right over here. So for our add coins, we're going to get our current coins over here and just do a add. So we can add some coins to our current coins. And the amount that we'll add is we'll add 25 per each time we pick up a crate. And then we'll set our coins to that new value. Then we just need to update the coins UI. So get our main HUD reference and call the update coins text event. And just plug in our coins to the new coins like so. Add a comment. This will be add coins if pickup chest. And show bubble when zoomed. And so now this should work. So when I hit play, I can run up to our coin pickup and overlap, and now you can see we have 125 coins. So I should be able to purchase a cannon turret and also explosive barrel. But as you can see, now we have our coins set up, so we can actually purchase different items using our coins, and we can pick up these coin pickups to add more coins to our player's coin collection. Now one last thing is we need to make this coin pickup be spawned in when skeleton is killed. So go ahead and delete that from the level. We want to give the skeleton a rare chance of spawning in that coin pickup when the skeleton is killed. So let's go to our blueprints skeleton, open up our BP skeleton, head over to the event graph, and you want to head down to our skeleton death event. And right below it, we can right click and add a custom event and name this to spawn coin crate. So basically we'll have a certain % chance of spawning in a coin crate when the skeleton is killed. So to program that in, we'll do a branch. And for the condition, we can do a random bool with weight. So this will be a random boolean with weight. And we can just leave that as 0.5. So this will have a 50% chance of spawning in a coin crate. So then if true, we can do a spawn actor from class. And we can just spawn in our BP coin pickup. For the spawn transform, we want to get our capsule component and get the world location of our actor or our capsule component. And we also want to do a add operator because we want to spawn this coin pickup above the ground. Because if we drag in our coin pickup, you can see that it will just be in the ground like so, if the value of this is set to the actor's location. So we just need to move it above the ground so that it is up and the player can see it. So in the skeleton, we can take that world location and add to the Z value to move it up. So I'm going to add 20 units. And then we can right click the spawn transform, split the structure, and only hook this up for the transform location. So let's add a comment for this. This will be our spawn coin pickup and show bubble when zoomed. And then up here, we can call that spawn coin pickup event. So right over here, after the skeleton is killed, we can, before we do our delay, we can call that spawn coin crate. And then we can just compile and save. So let's hit play. Let's go ahead and see if we can kill a couple of skeletons here. You can see that this one spawned a coin pickup, so let's go overlap with it. And now we have 125 coins. If we kill these guys over here, that one didn't drop any, and that one didn't even drop any. So you can see that it has a rare chance of spawning in a coin pickup. I believe a 50-50 chance. Basically, it will give the player the ability to get coins and collect them as the game is progressing. So we've set up our buy menu, we've set up our coin pickup. We need to set up the logic for our grace period. So basically when we kill all the skeletons, we need to have a certain amount of time that the player can be granted in order to place down structures to prepare for the next wave. And only during this time will the player be able to buy stuff from the buy menu. So we basically want to lock it down so that the player can't buy additional items during the actual game, during the actual round. And also we want to add a countdown timer to show how much time the player has before the wave is starting. So we need to implement all this logic in this lecture. So first things first, we're going to implement the timer, the countdown timer. So let's go to our widgets and open up our WMain HUD widget. And in the top right, we'll add a countdown timer that will show us when the wave is starting. It's starting in 30 seconds. It'll count down all the way down to 0, and then the wave will actually start. So to add this countdown timer, we're going to first add a border. So search for border and drag and drop it on our canvas. And we'll just scale it like a rectangle like so. We need to set the anchoring, so select that and anchor it to the top right, since this will be in the top right. Then for the brush color, I'm going to change this to a dark color and an alpha of 0.5, just so it's transparent like so. Hit the compile and save. And onto that border, we're going to add a horizontal box like so. And then into that horizontal box, we can add a text into that horizontal box. Select that text and we'll set this to fill and center align vertically. And we're going to rename this to wave starting in 30. I believe that's all the settings that we need to do. I might just scale up this border like so. And actually, I'm going to set the text to center align. So we'll center align that text. And that should be good. So select the text. We want to set that to a variable. And this will be our wave starting text. And also select this box. So this border over here. We want to set that to a variable and also name this to wave starting box, because we'll set this to hidden or visible. So first things first, we'll set this to actually hidden by default. So compile and save. So this should be hidden from our screen like that. Then in the graph, we can set up the logic for our countdown. So down here, we're going to right click and add a custom event. And this will be called start next round event, and compile save. And we're going to keep track of how many seconds we have left. So in our variables, up here in the variables, we can click on the plus icon, add a new variable, and we'll name this to current seconds, and just change this to an integer. Compile and save, and we'll set our current seconds to 30. So we have 30 seconds left. And then when we're starting our next round event, we want to get our waves starting box. So that border, you just want to set the visibility to visible so we can see it on the screen. And then we want to go ahead and start our timer. So we're going to do a set timer by event. And for the event, we want to just drag off here and add a custom event and name this to update text, and compile and save. And for the time, we want to do this every 1 second, looping and max once per frame. And then take this timer and promote that to a variable and name this to timer reference, and move that up like so. So compile and save. And down here under the event, all we're going to do is take our current seconds and do a de-increment. So de-increment integer that will subtract 1 each time, and set that. And then we can set and update our text, which is our wave starting text. So let's get our wave starting text and do a set text. So we'll do a widget set text, hook up the execution. And for the in text, we can do a format text. And for the format, we want to type in here wave starting in, and then put in squiggly brackets, seconds, press enter, and we'll just take this result integer and do a to text integer and plug that in for the seconds. So basically we're subtracting each second, and we're setting and updating that text each second to show how many seconds are left. Then off of this result, we want to check and see if this is equal to 0 and do a branch, because if so, that means that our time is up and the wave is starting. So if true, we want to get our timer reference and stop our timer. So we can do a clear and invalidate timer by handle for the true. And then we can also hide our wave starting box. So this widget over here that we set to visible, we can just get our wave starting box and set visibility, set that back to hidden like so. So just plug that in, and let's add a comment for this. This will be our update waves text and timer. And now we can call this event inside of our character, and we can call it from our game mode as well, so that it will call the event in our character to then call this event in our widget to show the starting wave text and update the timer. So let's go to our core blueprints, open up our third person character. And over here, we'll need to add a event, interface event, and call that next round event in our main HUD. So we'll actually go to our update UI events because this is where we'll put it. Let's go to our blueprints, interfaces, open up our BPI pirate character interface, and add a new function and call this to next round starting. Compile and save. And now in our character, we can add that interface. We'll expand the interface and added that next round starting event and move this to our update UI events. So now we just need to call that next round event in our main HUD. So get our main HUD reference and call the start next round event. And then also we want to disable or enable our buy mode. So we're going to keep track of whether or not the player can purchase items from our buy mode based on if the next round is starting. So we're going to add a new variable and name this to isBuyEnabled ? Compile and save, and we're going to set this to true because our buy mode is enabled as long as we have enough time during our grace period. So we'll have 30 seconds. So after the timer runs out, we'll reset this back to false. So now that we have that variable in here and this event, we can call this event in our game mode, but also we want to check and see if the buy mode is enabled. So off of our hide or show buy menu over here, we can simply do a branch and check and see if our buy is buy enabled and compile and save. So now we can only purchase items during the time that our buy is enabled. We also want to add an event for disabling the buy mode, but right now this will be good for now. Let's just call this next round event starting so that we can see that the timer is properly updating. So let's go to our game mode. So let's go to our blueprints, game mode, open up our game mode tower defense. And we need to go down to our pre-round timer. So down here, this is where the countdown starts to start the next wave. So currently we have this set to 5. We want to set this up to 30 seconds because that's the amount of time that we set in our main HUD. So add a comment for this. This will be our countdown to starting next wave. So before we start the timer, we want to go ahead and also start the timer in our player character. So get our character reference. We want to do a isValid check, and then we can call that interface to let the player know that the next round is starting. So off of here, call the next round starting interface message, hook that up for the isValid and hook that up for the set timer by event. Also for the isNotValid, we can plug that in for the set timer by event like so, just so that we can start the timer anyways. And then once the timer is up, after 30 seconds, we'll need to set our character reference to stop the buy mode. That way the player can no longer buy any items. So first let's actually test this out. So if I hit play, let's first kill all the skeletons here. So I just killed all 4 of them at once by shooting that barrel. I can collect the coins, and you can see it says next wave starting in 23, 22, and it's basically counting down till the next wave starts. So if I press B, I can buy items and place certain items down before the start of the next round. And if we wait about 10 more seconds or 5 more seconds, we should see the next wave starting soon. So the widget should disappear and the next wave is started. And I can still open up the buy menu, so we'll need to set up the logic to disable our buy mode. So to set up that logic, let's go to our interfaces, go to our blueprints, interfaces, open up our BPI pirate character, and we'll just need to add a new function in here called stop by mode. So stop by mode, compile and save, and let's head over to our third person character, and under our interfaces we should have that stop by mode. So just double click on that interface to add that event, and then we can just move this up here right next to our by menu. So when we're stopping our by mode, all we have to do is set our is by enabled. We can set that to false, and then if our widget is shown, we want to go over here and set the by menu to hidden and reset our input mode back. So basically, if the player has the by mode open, it will go ahead and close that widget. So now let's hit compile and save, and we just need to call this interface event in our game mode. So go to your game mode tower defense, and off of this start next wave, we can get our character reference and call that interface to stop the by mode. So let's first do a is valid check. And then if it is valid, we can call that stop by mode message. So plug that in for the is valid like so, and compile and save. And now let's hit play. And if I press B, you can see that I can't open up the buy menu. So let's kill these skeletons real quick, and so that we can actually buy items. So now the buy menu is enabled, so I can buy certain items. Let's pick up these coins, place them in a cannon turret, and let's just leave our buy menu open so that we can see basically if the game mode will close it when the next round starts. So if I have this open, and we'll just wait a couple seconds. So if the player has this open, you can see that when the round starts, it will go ahead and hide the widget and reset our input mode, and we can no longer open up the buy menu like so. So that is our simple countdown timer and restricting the player so that they can only open up the buy menu before the next wave starts. Alright, so in this lecture we need to fix a little bug with our coin pickup system and also with our skeleton's collision. When we kill the skeleton, there's two different bugs that we need to fix. So the first thing that we need to fix is with our coin pickup. So currently our coin pickup, if we hit play, will not despawn no matter how long. So if I kill a skeleton real quick, you can see that it spawns this coin crate, and the coin crate will stay as long as the player does not pick it up. So we want to have a little time for the coin crate to despawn. That way the player is pressured into having to collect these coin crates before they despawn from the world. So the way that we can add a little despawn timer is we need to go to our core blueprints, items, actually into our pickups, open up our BP coin pickup, and in the class defaults we can search for our initial lifespan, and I set this to 10 seconds. That way, after 10 seconds of this coin pickup being spawned into the world, it will despawn. So let's go ahead and test this out. So we have a coin crate right here. Let's go ahead and wait for about 10 seconds. And then it should likely despawn from the world like that, and the player cannot pick it up. So we're just giving it a little bit of time before it despawns. That way the player will be forced to collect these items, otherwise they won't be able to get the reward. Now the other thing that we need to fix is with our skeleton collision. So I'll show you what the bug is. So what happens if I shoot the skeleton is the collision on the skeleton is still right there, as you can see. Not until the skeleton is despawned will the collision be removed. So for example, if I shoot this guy, I can continue shooting his capsule, and then after he despawns, you can see now I'm shooting the wall. So we need to fix that. Basically, when the skeleton dies, we want to disable the collision. So let's go to our skeleton, BP skeleton, and over in our skeleton death event, down here when we set our collision response to channel, we also want to do the same exact thing for the mesh and capsule component for another different channel. So let's go ahead and move all of this over so we have some room to work with. Basically, we just want to copy the same exact node right here, the set collision response to channel. We want to set the collision response for our mesh and capsule component. But for the channel, we want to pick the channel that we're doing our line trace. So if we go into our third person blueprint, into our fire pistol function. We're doing this line trace over here from the camera position. And so because we're doing it from the camera, we can go to our skeleton and choose our camera channel, and we can set that to overlap. So basically when the skeleton dies, since we're doing our trace from the camera position or from the camera channel, we'll set that to overlap. That way we will no longer hit the capsule when the skeleton is dead, because the skeleton takes about 5 seconds for its body to despawn. So we'll just set it to overlap. That way the line trace can overlap with the dead skeleton body before it's despawned. So let's go ahead and test it out. So let's kill the skeleton here. And now you can see that we can just spam it and it will hit, and there's no more collision on the skeleton's capsule after it is dead. So those are just the 2 quick fixes to our game. Just a quick fix for our coin pickup and our skeleton blueprint. So we'll need to create next a win or lose logic. So basically when the player reaches the max waves, if they survive long enough to reach the last wave and they finish the last wave, we want to set up a little widget that will show on the player's screen to show that the player has won the game, and they can either quit to the main menu or quit the game, restart the level or whatnot. And if they lose the game, we also want to show a widget that says the player has lost the game. So that's whether or not player's tower has been destroyed, so the keep has lost all of its health, or if the player has been attacked by the skeletons and the player's health reaches 0. We want to go ahead and show a widget on the player's screen that will show that they lost the game. So let's go ahead and get started. So first things first, let's go to our core widgets, and in here we can add that win screen. So right click and create a new user interface widget blueprint of the type user widget, and name this to w_win screen, and double click open this up. And in here we're going to add a size box onto our win screen, and select that size box. And we're actually not going to set any width and height override, so we'll just leave it like this. We'll add a background blur onto the size box, and then select the background blur. We want to give it a blur strength of 20. Then onto there, we're just going to add a vertical box onto the background blur. Select that, and we'll set this to center aligned vertically, center aligned horizontally, so it'll just be in the center like so. And let's add some text into that vertical box. Let's select the text and size the font up to 64. And for the text, we can rename this to U1 exclamation mark, compile save. Then we'll add a button into the vertical box, and onto the button we'll add some text like so. And for the padding, let's expand this on the button. So actually select the button and expand the padding, and we're going to add 20 padding on the top, 10 on the top, 10 on the right, and 10 on the bottom. Actually 20 on the right. So let's match this up. So it should be uniform like that. And let's select the text on here. This will just be restart level. Let's copy this button and paste it again. Select the text. We can do quit to main menu. And then copy and paste this again. And we can just name this quit game. And we can select the button style and change the tint. So maybe it's a darker color like so. Copy and press that for the hovered. And press, and then copy our style. Go to our quit to main menu and paste the style. And select the other button and paste that style as well. So compile and save. That is our simple win screen. Let's select our buttons and rename this. So this is our restart level button. Then select our quit main menu. This will be our quit to main menu button. And then our quit game button is our quit game button. So compile and save. Let's head over to the graph and set up these buttons. We can delete these events. But let's select each button and add a on pressed for each event. So for our quit game button, this will be really simple. We just call the quit game node, which will close the game for the player. The quit to main menu button, we want to do a open level by name. And currently we don't have a main menu level, but we can just name this to main menu for now. Later on, we'll set up a main menu level, and this will open up the main menu level. With the on pressed for the restart level button, all we have to do is get current level name, get the current level name that is open, and then open reopen that level. So we'll open the level. So we'll take the return value and do a toName, string to name, and plug that in for the level name. So that will just get our current level name and then reopen that level, and that will reset everything. So those are our simple buttons for our win screen. Select also the text. We also want to make this a variable, and this will be our win text. So that's all that we need to do inside of this widget. We can go ahead and close out of there, and let's open up our main HUD widget. So in our main HUD, we're going to add that win screen in here. So under our palette, we can search for our win screen and just drag and drop it onto our main HUD. We can select the anchor and anchor it all the way around and reset our offset left, top, right, and bottom, and that will make it fill the screen. We want to set the Z order to 2. That way it's in front of all the other widgets. And then we can scroll down until you see visibility and set this to hidden by default, so that this will be hidden from our screen by default, and we can just show it later on. Now let's head over to the graph to set up the event to show that widget. So down here we can right click and add a custom event and name this to set win or lose. And let's add an input of the type Boolean, and this will be won game ? Whether or not we won the game. And then we can get our win screen. So let's get our W win screen widget, get that on the graph and set a visibility. Set this to visible because we're going to show the win screen. We're going to set it to visible. Then we just need to set the win screen text. So that text is in the win screen that says whether or not you won or you lost. So drag up here and get win text. Get the win screen text and do a set text widget set text. And for the in text, we can do a format, or actually we want to do a select. So drag up here and do a select text down here at the very bottom. And for the index or the wildcard, we can plug in this won game Boolean, and that will give us a true and false format. So we can type in either for the true, if we won the game, this will say you won ! For false, we can put in you lost. Okay, so very simple select there. You can add a comment for this. This will be our show win screen widget. And now all that is left to do is to call this event inside of our character whenever we lose or win the game. So that will be if the player's health reaches 0, if the skeletons swarm our player and attack it and our health is 0, or if the keep's health reaches 0, meaning that the skeletons destroy the keep. So let's go into our core blueprints third-person character, and we're actually going to head over to the event graph, and down here under the hide or show by menu, we're going to add a couple of blueprint interfaces so that we can call the lose or win logic in our character. So we need to go to our interfaces, open up our BPI pirate character, and add a new function in here, and we'll name this win or lose game. And for the input, we can add a new Boolean, and this will be won game ? And compile and save. And now let's head back to our third-person character and implement that interface. So under the interfaces, we can double click on our win or lose game. So off of our won game, what we want to do is first add a new variable. So create a new variable and name this to game over ? Compile and save, and we want to set this game over to true. So we're going to set that to true. And we also want to save this or check this game over in our receive damage. So let's get this game over here. And we want to do a branch because we don't want to apply any damage to our character if the game is over. So let's hook this up. And if the game is over, we won't do anything. If the game is not over, we'll continue with our apply damage logic. So we're setting the game over. Then we want to get our main HUD reference and show the lose screen logic. So off of here, we can call the set win or lose function. And whether or not we won the game, we can plug that in for the condition. Then we want to show our mouse cursor. So basically, we want to show the win screen widget or win or lose screen widget. and the player will be able to click on the buttons on that widget. So we want to show our mouse cursor. So get player controller, and we want to set the input mode, set input game and UI. Hook that up. We also offer the player controller want to do a show mouse, set show mouse cursor, and set that to true, and compile and save. And let's add a comment for this. This will be our show win or lose screen widget. And just like that. So we can call this interface event lose, win, or lose game if the player's health reaches 0. So let's go over here. So on the event receive damage, off of this true. So if the health is less than or equal to 0, our player is dead. We can call that event lose or win or lose game, BPI character. And we can set this to false, meaning we lost the game. So now we'll call this interface down here that we've implemented, and it will say that we lost the game. It will show the win screen widget, and it will show that we lost, and it will show our mouse cursor. Now the other way that we want to show our lose screen or our win screen is from the game mode, and also from our BP keep. So basically, if the health in our keep reaches 0, then we want to show the lose screen widget. So we'll need to add an interface for our game mode to call that. So let's go to our interfaces, BPI tower defense game mode, and add a new function in here and name this to game over. And for the inputs, we'll add one input of the type Boolean, and we'll name this to lost game question mark, and compile and save. And then we can go into our blueprints keep, BP keep. And over here in our BP keep, if our health reaches less than or equal to 0, up here on the top, we can call that interface for our game mode. So you want to right click and get game mode. That will get the game mode. And we can call that interface game over, or game over interface message. And we'll set the lost game to true. So compile and save. So if our keep's health reaches 0, then we'll set the game as game over. So now we just need to set up this interface event in the game mode. So let's go to our blueprints game mode tower defense, open that up. And down here at the very bottom over here, we're going to implement that interface. So expand our interfaces, and we have that game over interface. So double click to add that event. And then we want to get our character reference and check and see if it is valid. If our character reference is valid. If so, then we can call our interface on our character that will show our win or lose screen widget. So that interface message is this event win or lose game. So off our character reference, we can call that win or lose game message. So hook that up for the is valid. If we won the game, we can basically plug that in for the condition. So if we lost the game, we can do a not boolean. So that'll reverse that. If we lost game, if it's true. If it is not true, that means that we won the game. So now let's add a comment for this. This will be our show win or lose screen on the player widget. And then the other condition that we want to call this event for is if we actually win the game. So how do we know if we won the game? Well, basically, we can tell if we won the game if our wave, our current wave, is equal to our max waves. So we know that we've won the game because our player reached the max waves, and we call this off the true the game won. So we can delete that function and instead call our event game over, our BPI tower defense game mode game over, and we can set this to none or false, meaning that we haven't lost the game, meaning that we won the game. So if we leave that as empty, basically that will return that we won the game. So now let's go ahead and actually test this out. And to test this out, we can set our max waves to 2. That way that we don't have to play the whole 10 waves. And now we should be able to test out 3 different conditions. The first condition is if the player's health reaches 0, it will show the lose screen. The second condition is if the keep's health reaches 0, we'll show the lose screen. Then the third condition is if we kill all the skeletons and move on to wave 2, then kill all the skeletons, we should see the win screen. So let's hit play, and let's go ahead and let the skeletons damage the player. Let the skeleton attack us, and now you can see that we lost. We have restart level, quit the main menu, and quit game. So restart level will reopen the level like so. And there is a little bit of a bug when we restart the level that we'll need to fix with our input. So we'll fix that in a second, but let's check the second condition when our keep reaches 0. So for that, we'll actually might need to delete this cannon to test that out. And let's let the skeletons damage and destroy our keep real quick. So our health is almost down to 0. And when the health reaches 0, we should see the you lost widget. And again, restart or quit the main menu or quit game. So the other condition is if we win the game. So let's go ahead and just win the game real quick by killing all the skeletons. And let's let the next wave start. We'll have to finish the next wave in order to win the game. Okay, and so the next wave, let's go ahead and shoot this right there. And we have 3 more skeletons left, 2 more, and the last one. And then you can see that you won the game, and we're not going to be respawning any skeletons because we won the game. So that is a very simple win and lose screen logic. So to fix that bug with the reset widget, or with our reset level, basically off of the event begin play, off of the setup main HUD event, this gets called up here off of the event begin play. We just want to set our input mode back to game only. So we want to right click get player controller and do a set input mode game only. Then also we want to set show mouse cursor, set that to hidden. So let's test this out. If we hit play, and let's let the skeletons kill the player. Stand in front of the skeletons here. So the you lost, we'll click reset level, and now you can see that it resets the input like so. So that is our very simple win and lose screen logic. We can show the widget if we lose the game or if we won the game, and we can restart the level, quit the game, or quit to the main menu. So we've created all of the gameplay logic at this point. Now it is time to create the actual map that we will play our game in. So we're going to create a simple island map that will have some various different assets that we download from Quixel Bridge and some other different sources. So we'll need to get started with creating that map. So let's go into our core folder, and in here we're going to make a new folder. Right click, make a new folder, and name this to maps, and double click open this up. And in here we can create a new map by just going to File, New Level, and we'll select our basic level. And we can do a File, Save Current Level As, and save this into our core maps, and name this map to Shipwreck, like so. And just do a File, Save All. And so in this map, we're going to add a very simple landscape terrain. So we can go ahead and zoom out, delete this floor. And let's go into our landscape mode. Let's go into the selection landscape. And we're going to create a simple 505 by 505 overall resolution landscape. So it's not going to be very big in size. So we're going to click create. And we're going to create a really simple island with some other different islands over here and some water. So we're going to add some water body oceans to our map and create sort of like the shipwreck level. So to add the water, we need to enable the water plugin. So you want to go to your edit plugins and search for water. And we can use the built-in water plugin inside of Unreal Engine. So enable the water plugin and click yes, and click restart now to restart your project. And once that's restarted, we can go ahead and reopen our shipwreck level. And now, if this is your first time enabling the water plugin, you might see in the bottom right that it's compiling the shaders. But also if you click the Q+ icon and search for ocean, you should see this water body ocean. And if you drag and drop it into your level, if this is your first time, again, you're going to see compiling shaders in the bottom right. So it might take 15 to 20 minutes, depending on your PC. But as you can see, it adds a very simple water body ocean into our level. But now what we'll need to do is we'll need to size this down because this island is too big. So we can take any of the points over here and size them down. And what I did was I sized this down to the absolute smallest that I can get to create a very small level. So we're going to take all these points and just move them all the way in and just make a very small island. And to play test this out, what you want to do is change the game mode. So open up the world settings, go to Window, World Settings to get this window. And under the game mode, we can select our game mode override. We want to change this to our game mode tower defense so that it has our BP third person character. So let's hit play in here, and we'll need to reset our character spawn. And also it spawns the skeletons over here. So we'll need to set up the skeleton spawn points. And it looks like obviously we're having a lot of issues because we haven't set up anything from our game mode. So let's go ahead and set that up. So let's add first in our player start. So we actually have a player start. So search in the outliner for player start. Select that and let's move this over here. So this is our player start capsule. Let's move this above the ground and we'll put it right there. And then for our skeleton spawn location, we'll worry about that in a second. Let's actually add some more islands to our level. So to add another island, we can search for a island. So we have water body island, and if we drag and drop this in the level, you can see that it adds another island to our map. And we want to select this and go to the details and scroll down, and we're going to adjust this curve. So as you can see right now, it's a very steep island right here. So we want to, in the water curve settings, expand that, and we're going to increase this curve ramp width to 21,000. So something like that. And I believe that's the only setting that I changed. So the ramp width will change basically how big the fall off will be on the island. So something like that. We can take each of these points as well and move these in because we want this to be as small as possible, just like so. And then if you select off of that island and then reselect it, it will select all the points, which will allow you to move it like so. And then we can take this and duplicate by alt dragging. That will duplicate it. And we'll just move it around like this. And we're going to create 3 of these. So we'll have one over here and duplicate this again. And I think we can even rotate this and move this over like so. So we should have 3 separate islands like this. And you can adjust the size and select the points and move them around and resize them to your liking. But this should be good. Then to add our skeleton spawn points, we need to go to our blueprints, skeleton, and we have our BP spawn point. So we're going to drag a couple of these spawn points into our level, and we need to pull these above the ground. And then let's duplicate this by holding alt to drag like so, and duplicate 3 of these. And then we can alt drag these again and move this over here and put 3 on this side over here. And then just alt and duplicate and move these over here and rotate it just so we have a couple of different spawn points on all the separate islands like so, and save that. And then to actually test this out, we'll need to add that navigation volume for our skeleton. So I want to click on the Q+ icon and search for a nav mesh bounce volume and drag and drop it in the level. And we need to scale this up like so, and hopefully fill the entire level. And if you press P, that will show you the volume that the skeletons can navigate in. So let's increase this like this. So press P again to hide that. Hit play. We should see that the skeletons will spawn in. And we don't really have a keep location yet. So I think they're just going to run randomly. So we need to add a reference to the keep. So obviously you can see that the AI move to is receiving an error because there's no keep for the skeleton to move to. So we need to go to our blueprints, keep, and drag in our BP keep and scale this up. And now they should have a target to run towards. So you can see that they spawn over here, and some of them have a very slow movement speed. So as you can see, we set different variations of movement speed in the blueprint. So when they spawn in, some of them are fast and some of them are slow. And as you can see, they're moving to the keep target. So this is exactly what we want. So we set up the very basic spawn points and the keep. So this is just the very basic blueprints that we need to set up the game mode. Now we can actually just start decorating the level and swapping out some of the different meshes. So what we can add is we can add a shipwreck model in our scene. And I have this mesh that we can download, that we can add from the project files. So in the meshes folder, we want to add a new folder for shipwreck, and double click, open this up. And then let's go to the project files. So double click and open up the project files. And in there, we should have a folder for shipwreck. And inside there, we have the shipwreck.fbx. So just drag and drop that FBX file into our shipwreck folder and click import all. And we can ignore these error messages or these warning messages, close out of there. Then we just need to import the textures. So let's just shift select all the textures. And I believe I just didn't import these roughness. So I imported everything else instead. Drag and drop it like so. And let's set up the materials real quick. So we have the AI standard surface 4. We can delete the parameter for this one. This is this very first texture group right here. Just drag and drop that. Hook up our base color and our normal and save that and close out of there. Then the next material, which is this AI standard surface 7, double click, open that up. Same thing, we're going to delete the parameter and drag and drop the second group of materials into there and hook up the base color and the normal, save that. And then the last one, the ropes 1, we can shift select both of those textures, drag and drop it, and plug in our base color and normal. So save all of that. And now we should have our shipwreck model. So if we drag and drop our shipwreck in here, we need to scale this up. So let's scale that up like so. And part of the texture will need to be set to two-sided, because you can see on the cloth here, we can see through it. So we can just set the texture to two-sided. So let's do a file, save all. And I believe we need to open up the ropes 1, select that texture or the material over here and set that to two-sided and save that. And now we should be able to see that that material is two-sided. So we can just take this shipwreck and you can place this anywhere in your level. It's up to you, but I'm just going to position mine right over here. And we can rotate it and just kind of position it like this, however way you want to. It's completely up to you. And now we can start adding some other different meshes. So we'll need to add some assets for our pirate game. And we're going to use this free app called Cargo from Kitbash 3D. So you want to head over to their website, kitbash3d.com, and we'll download their Cargo app. And I'm not affiliated by them in any way, so I don't have any kickback for telling you guys to download this app, other than the fact that they have free assets. So that's really the only reason why we're downloading this, is because it has some free pirate assets, and these are the ones that I used in creating this game. So go ahead and click the download Cargo app. So basically it is a program that you use to import assets from their app into Unreal Engine. So it's like a third-party application that you'll have to download. And again, you'll have to create an account and register, and it's completely free to sign up. So just note that it shouldn't cost you any money. So once you download the Cargo app, it'll ask you to run the setup. So you need to extract the files and double click. And basically you'll just need to go through the installation. So I'll ask you to install the program, and we'll click finish to run the app. And so it'll ask us to log in with our account. So go ahead and log in with the account that you created. And then it's going to ask you to connect a 3D software. So we're going to click setup software. That's going to run you through the setup. So you just select your software, in our case Unreal Engine. Select our version. You can see that we have 5.4, and click advanced setup. It might ask us where to install the location, where the installation is located. If you don't have yours in your C drive in your program files, you need to click on the folder icon and navigate to where you have your Unreal installed. In my case, I have mine on my E drive, Unreal install 5.4. So Unreal and 5.4, and click install. And it will say installing. Okay, so it took a bit, but now if I search in my plugins, you should see this cargo plugin pop up. And we can click on the checkbox to enable that plugin and click restart now. And so now we have that plugin enabled. And now you want to, over here, you can see that the button is right here. We can click connect to cargo. And now that will connect to the app that we have open over here. So you want to have this open in order to download assets from this program into your project. Then let's open up our recent level, shipwreck. And let's go ahead and download some assets. So open up the cargo app and we want to go to the models section. And under the models, we want to filter the access by free because we only want to see the free models. And in here, we have the pirate large home. So this is some free pirate assets that we can download. So we can go ahead and change the sizing. You can change the target software, the texture size. I'm going to leave this as the default and click download. And now we'll go ahead and download the asset. And once that's finished downloading, you can click the import button. And what you should see is in your project, it calls the importing meshes. So it's importing the assets into your project because we have that connected to the app. So I'll just give it a second to import everything. Okay, and once it's finished importing, you can see that it automatically spawns in the asset that we downloaded, which is this pirate, I don't know, town or village. But as you can see, this is what the asset looks like, but it comes with a lot of these assets that we can use. So we can actually just delete that. And now we can go into the cargo folder. So we should have a folder for cargo and geometry. And you can see we have all these meshes to work with. So it comes with all these free meshes. And hopefully by the time you're watching this video, the assets that I'm showing in here are still free. Sometimes they take the assets and make them not free, which is kind of dumb, but there were a lot more assets that were in this section, but they removed them. So hopefully by the time you're watching this video, these are still free and you can still claim them without having to purchase anything. We can also get this dock building over here. This is also another pirate asset. We can click download and also import that into our project. And you can check out some of these other free assets and download them, add to your project. But those are really the only pirate themed assets that we're going to use. So we can actually just close out of the app. And now we should have all those assets and this little pirate dock over here. We can delete that, but it comes with all the models that we need. Now, all of these models are okay quality. You'll need to note that none of the collisions are set up properly. So when you use this for your game, it's going to be a pain because you'll need to set up either manual collision or use the complex collision as a default collision. Also, some of the pivot points are messed up. So you can see if I drag in this palm tree, the pivot point is all messed up. So it just makes it really a pain to use some of these assets because they're just not set up properly, or at least designer friendly. And also some of the palm trees, we'll need to set up a two-sided material because you can see I can look through that palm tree leaf material. But other than that, we can use any of these free assets to design our level. And so the first thing that we'll set up is we'll swap out our BP keep. So we need to browse to our keep and open that up. Head over to the viewport and let's select the static mesh and swap this out for our new mesh. And I'm going to use one of the building meshes from our cargo geometry. We have this building right here. And if we rotate it 90 degrees, this is what the keep will look like. So we're going to use that mesh, so select it, and in here we can set it to that mesh, like so, and compile and save, and now we have that in our level, and it's way too big, so let's reset our scaling, and move it down, and we can rotate this 90 degrees, but this will be our main keep right here. Now we need to set up the collision, so you want to double click open this blueprint up, or the static mesh up, scroll down, and in the collision settings, so under here down in the collision, we can either add a simple collision to our mesh or we can generate a collision. So under the collision, we can actually add just a simple box collision and select this box collision, and we can scale this. So let's just scale this down, and let's turn off the scaling snapping. So turn off scale snapping by clicking that little button over there, And then we should be able to scale this to exactly the size that we need. We might need to move this a little bit in the center and scale this up like that. But that is our very basic collision. So now if we hit play, we should see that the actor has collision. Now obviously not on the steps, but just the building, which is what we need. And the skeleton should be able to run up and still hit the keep as well. So this one will run up and start damaging the keep. And that's exactly what we need. And so we can get more assets and keep decorating our level. So I believe we have some boardwalk assets in here. So things like these boardwalks. We should have some other different assets in here as well that we can use. This big section, which is this dock section, we can use that for the platform. And we'll need to double click open that up and go into the collision settings. And for this, I'm going to use the complex collision. So under the collision complexity, we can change this from project default to use complex collision as simple. And you don't want to really use this all the time because that will use basically the actor geometry as the collision, which can be really expensive, CPU expensive. But if you have the time, you can go in and just, instead of doing that, use simple collision and add your capsules and your boxes to add the actual collision. But for the sake of this video, I'll just use the complex collision. Now we can rearrange this and we can create a very big dock section. So let's duplicate this over and we can rotate this. And we'll just create basically a platform on which the skeletons will have to run up to reach this building. And then we can drag in some of these other pieces. And if you remember, if you use any of the other pieces, we'll also need to set the collision settings on these as well. So you'll need to modify those settings. So for this one, we'll need to open this up and also set the collision to use complex collision as simple. Save that. And we might need to add some ramps so that the skeletons can get up here. So I believe I used one of the meshes inside of here. So I selected this mesh down here, this deck, and we can scale this up, make it a little bit more wide, and we can rotate this and basically position this to create sort of a ramp. So let's make it a little less steep and just line it up like so. So that will just add a little ramp for the skeletons to run up. And we can turn off the snapping so we can precisely place it. And we also want to double click open that up and also give that some simple collision or use complex collision as simple. So we can add a ramp on that side, also duplicate it and rotate it over here on this side. So we can add a way to access that side as well. So now let's test this out, hit play, and we spawn on here. We can change the spawn point as well, but we should see that the skeletons are able to run up the pathway. So they'll take that pathway, and you can see that the skeletons automatically know where to navigate based on the pathways that we give it. And you see they can damage our keep. So you can just keep moving around assets and adding more assets in here. It's completely up to you how you design it. I'm going to add some extra buildings in here as well, like so, just so we can give it some more better look and appearance. And we can just rotate and move this right next to the keep and move that over like so. We can duplicate this, move it over and rotate this just like that. And we'll need to give collision to that building as well. So you could just go and set all the collision settings like this. That way we don't have to open up each individual one. And of course we have other different props that we can add in, things like barrels, palm trees, and much more. Now this next part, we're just going to speed through the video. Basically, I'm just dragging in various different assets and setting up the scene. So you can take any of the assets that you get from the cargo app in the geometry folder and just drag and drop them in the level, scale them up, rotate it, place it around, and make it look nice. Also, another thing that I did in here that I'm going to speed through is we have to fix the palm trees. So to fix the palm trees, you need to first fix the material. So you just browse to the material location and open that up and search for two-sided and set that to two-sided. That way the leaves will be two-sided and the light won't pass through and you can't see through it. Also, the other thing that I fixed on the palm trees is the pivot location. So if we watch really closely, I'm going to show you how I fixed the pivot location. Basically, I dragged all the palm trees in the level, set the location to 0, 0, 0. Then I position the palm trees at 0, 0, 0 so that the bottom of the palm will be at the origin, the world origin. And then you can go into the modeling mode and there's actually a section for choosing the new pivot. So all you have to do is click on the edit pivot over here, and then you need to enter in and click on the world origin as a new pivot location. And since we place the base of each palm tree carefully at the world origin, which is 0, 0, 0, if we click accept, we now have edited the pivot point for these palm trees. And this will just make it easier for us to actually paint in the palm trees and place them in the level now that the pivot point has been adjusted to the very bottom of the palm tree. So now what you can do is you can select all of the palm trees and go into the foliage mode and drag and drop them into there. You can adjust things like your brush size, your paint density, and also the min and max scale, and that will adjust and add some variation to painting the palm trees. Just copy the values that you see here on the screen, and as you can see, I'm just painting this on our landscape, and you can erase and delete, of course, some palm trees if you don't like it. And of course, I'm just dragging more assets in here. Like I said, you don't have to follow exactly what I do in this part. You can just eyeball it and add your own different props and rearrange them as you like it. Okay, so this is what our final level looks like with all of the assets that I dragged in. So you can see all the different assets that I dragged in are just in random locations. And of course we have the skeleton spawn points on each of the islands. And so this is what it basically looks like. We need to add a landscape material. So let's go ahead and add that right now. So let's go to Quixel Bridge and get some materials and 3D assets. So go and click on the Q+ icon, and under the Q+ icon we have the section for Quixel Bridge. So double click and open that up, and this will open up Bridge or Quixel Bridge, which has a ton of free high quality 3D assets and materials, which are completely free to use as long as you have an Epic Games account. So to use any of these assets, you need to sign in with your Epic Games account. So you want to click on this profile icon and click the sign in. And once you click the sign in over there, you'll be able to access all of the library of assets. And so for here, we're going to create a landscape material, which will consist of basically 2 different materials. So you want to go to the home section and search for beach sand. And we'll actually filter this by surfaces. So basically surfaces are sort of materials. So you can search for beach sand. And so the material that I used was this Thai beach sand. So go ahead and download this. I'm going to download this as medium quality. The quality will change the overall resolution of the texture. So we don't really need a really high quality. We just need medium quality. So click download and it will go ahead and download it. And once it's downloaded, once it has a green check mark, you can click add, and that will go ahead and add the asset in your content browser. You also want actually this rippled sand right here, which is what we're going to use for the wet sand layer. So let's take this and also download this. And once we have that downloaded, we can click the blue plus icon to add it to our project. So now we should have the 2 surfaces. We have the beach sand and the rippled sand. So now that we have those, we have the textures. To create it, we'll need to create a material, a landscape material. So let's go to our core, and we'll need to right click and create a new folder for materials. Then just double click, open this up, and right click and create a new material over here. So click a basic material and name this to m_landscape material. And let's double click, open this up. So in here, we're just going to use material attributes. So what that does is, if you're not familiar with materials, you don't really have to worry too much about materials. So without going too in depth, we're going to just select this node over here, and in the details, we're going to check this use material attributes. So it'll just be one node, and then we can do a layer blend, landscape layer blend. And with the layer blend over here, we need to add some layers. So we're going to add 2 layers. So click the plus icon over here in the details to add 2 layers. And you can expand these layers, and you can see we have things like the name. So we can give these layers a name. So we just want to go ahead and name the layer name up here to sand wet for the first one. And then for the next one, this will be sand dry. And then just save that. Okay, as you can see, it's giving us an error. And that's just because we haven't hooked up the material attributes yet. So now that we have the 2 layers, we have the wet sand and the dry sand. Off of here, we can do a make material attributes. And that will give us all those nodes that we had previously over here. And we can just copy and paste this and plug this also in for our sand dry. So now we have our 2 layers. We have our sand wet up here on the top, and then we have our sand dry. So all we have to do is plug in the textures to the base color, the normal map, and all that stuff. So very simple setup. So let's just go to our materials. So let's go to our Megascans, surfaces, and let's get first our Thai beach sand. And shift select all the textures and drag and drop them in our landscape material. And this will be our sand dry. So bring it down here and let's organize this. So first for our base color, this will be our yellowish texture over there. Then for the metallic, we want to drag off here and do a constant. Choose this constant. So it'll be a constant value. It's not going to be metallic, so we'll set that to 0. For the specular, we're going to also copy and paste this and be 0 for the specular. And then for the roughness, we're going to plug this into this yellow texture right here. This texture has the information for roughness in one of the following layers. So if you're to open up this texture, so you can see if I only preview the blue channel, you can see what that texture looks like. So we're going to use the blue channel for the roughness. So that means that we can take this blue pin and plug that in for the roughness. Then the R is actually the ambient occlusion. So we can plug that into the ambient occlusion. But basically, the way that they set up these textures is that they have these different layers in the different channels. So you'll plug them in accordingly. Okay. So just follow along like what I'm doing in the video. Then for this one, this is the normal map because this is our blue normal. We'll take the RGB and just plug that into the normal. So now that we've set this up, we also want to set up the material up here. So we'll do the same exact thing. Let's go to our surfaces and this time grab the rippled sand. So shift select all the textures and drag and drop it on the graph and up here at the top. And let's organize this. Let's put our base color on the top. So let's hook up our base color. For the metallic and specular, let's copy over these values, but we're going to adjust some values. So for our metallic, that will be 0. For our specular, this will actually be 0.5. So this will have some specularity to it. And what the specular value does is it makes it sort of shiny, which is what we'll need for this wet sand effect. We're going to make it a little shiny so it looks like the water has touched the sand. Then for the roughness, we'll take the B channel from this texture, plug that in for the roughness. For the R, we'll take that into the ambient occlusion. Then for this blue texture, we'll plug that in for the normal. And now we have both of our textures set up. The last setup that we want to do in this landscape material is we'll need to add some texture coordinates to handle the tiling of the material. So if we were to apply this to our landscape, the tiling might be too small or too big. In order to control the tiling, we can right click and search for a texture coordinate. So this texture coordinate, and plug this in for the UV channel on all of our textures. And we'll copy and paste this again and plug this in for the UVs down here as well. So the texture coordinate will allow us to change the tiling in the details of the following textures that we have hooked up. And so for the texture coordinates of this texture, I set mine to 0.3 by 0.3. So that is our tiling for these textures. And then for these bottom ones down here, I also set them to 0.3 as well. So just save that. And we can play around with these values later on, but let's go ahead and apply this material to our landscape. So to apply the material, just select your landscape, and in the details, we can scroll down to the material. And let's go to our core materials. And we can right click and let's create a material instance first. So right click and create a material instance. Name this mi_landscape material. And do a file save all, and then take that material instance and plug it into our landscape material. Usually you'll create a material instance of your material, which will have different parameters you can tweak and control. We don't really have that in this material, but in the future, if you'd like to add that in your material, you could add a little bit more of an advanced setup. Like I said, we're not going to go too in depth into materials in this course just to save some time. But right now, what you're going to notice is when we apply that material to our landscape, everything is black. And that is the normal behavior when you apply a landscape material that has more than one layer. So in order to see our actual landscape material appear, or the sand appear, we need to tell the landscape, hey, there's sand at this location. So we need to go into the landscape mode. So go to your selection mode and change this to landscape and close your content browser. That way we can see everything. And you want to head over to the paint tab over here. And now we can see we have a layer for sand wet and sand dry. So all we have to do is add a new layer info for each of these layers that we want to add. So over here under the sand wet, we can create a layer info as well as for the sand dry. So first, let's actually do the sand dry, create a layer info, and we'll do a weight blended layer info normal. It's going to ask us where to save that layer info asset. We can save it in our materials folder, click save. And when we do that, it will go ahead and compile that. And you can see it applies our sand material to our entire landscape material. Then we want to do it for the sand wet. So also click on this and add a weight blended layer normal. Select your materials and save that layer info to that folder. And now we should be able to paint our landscape. So let's select our sand wet and first paint everything sand wet. So let's scroll out here and increase our brush size. And let's paint the entire landscape to this sand wet color. So we can hide our ocean by searching for ocean and hiding it like so. Okay, so we can paint this all sand wet. You could paint it all the way out as well, but that should do for now. But if we zoom up on this texture and show our ocean, you can see that we have sort of this shiny sand, rippled sand, which is sort of like this wet sand for our beach. Then we can select our sand dry, and let's decrease our brush size down like so. And let's select our sand dry and paint it. So if we left click, you can see that it adds our dry sand on top of our wet sand. So we want to add this dry sand basically all the way around like this. And you can decrease or increase your brush size. It really depends on how you want to paint it. There's really no perfect way of doing this. You just sort of eyeball it. But as you can see, this is what it will look like. So if I hit play down here, you can see what the dry sand looks like with our wet sand over here. And you can adjust things like the tiling. If you don't like the tiling of the material, you can increase or decrease the tiling and mess around with that. Now, a couple of other things that I want to fix real quick with our map before we move on is things like the collision on the water body. So if you select the water body ocean, currently if I hit play, we can't run through the water. So our player is sort of running on top of the water. So we can fix that real quick by changing the collision settings. All you have to do is select the water body ocean, and in the details you can scroll down to the collision presets, expand this, and since this is set to custom, we can overlap the pond. So if you set the ocean to overlap the pond, let me take my player start and let me actually move this over here. Let's hit play and let's run over to the ocean. Now you can see I can actually run into the ocean and we're not colliding, and our character mesh is not colliding with the ocean. Also, I think the camera is colliding with the ocean, so we can actually disable that. So if we select that and search for collision, we can also set the camera to overlap. But just note you can fix those collision settings by just simply going to the details and changing that. So once we made those changes to our map, we can also add additional assets in here. So I added these Thai beach rocks. So just go to Quixel Bridge and search for these and download them. and just add them in the level, scale them up, rotate them, and place them pretty much wherever you'd like. So as you can see, I'm just placing them in the level at random different spots, and you can scale and rotate them to your liking. So you can also add things like bushes to your map. So I downloaded this tropical palm from the Quixel Bridge, and all that I did to get this to look nice was I enabled Nanite. So you just shift select all of the assets, right click, and click enable Nanite. Then you can go into the material settings. So just open up the material and search for wind and enable the wind, and basically it will animate the bush so that it will move in the wind. And then you can just add this to your foliage painter and paint this onto the map. But now that we have our map complete, this is basically what it looks like. There's one other thing that we need to fix in terms of bugs. When we hit play, there's a bug with our buy menu with spawning in some of the items. So for example, if I kill all the skeletons in here, if I press B and try and buy, say, a cannon turret, what you're going to notice is it takes all the coins, but it doesn't spawn in the cannon. Now we need to fix the collision when we spawn in those items. So you want to go to your core blueprints, open up your BP third person, and we need to go into where we spawn our build preview. So go to your place buildable spawn build preview, and over here on our spawn actor node, we want to change the collision handling override. We want to change this to try to adjust location but always spawn, because we always want to spawn this actor no matter what. What's happening is it's colliding with our landscape and it's not spawning in our actor. So we want to always spawn. Then the next thing that we want to modify is when we place down the buildable. So over here, over on our shoot weapon, spawn structure function, open up the spawn structure function. And again, over in our spawn actor node, we want to change this to try to adjust location but always spawn. So that will fix that little issue for when we place down structures. It will allow us to actually place down structures into the map. Now another thing that we need to fix is the skeletons are running behind the keep as well. So we want to fix that so that they don't run behind the keep. So one way that we can fix that is by adding some collision boxes to help the navigation. So if you press P, P will show the navigation. And so as you can see, they can clearly navigate behind the keep. And that actually might be an optimal path for them. So to prevent that, we can click on the Q+ icon and add a box, a trigger box, and just scale this up. And then in the box settings, in the details, we can, under the collision preset, set this to block all, and also search for navigation, and click on fill collision underneath for navigation. So basically that will block the navigation, and we can scale this up like so. Maybe move this over and just scale this super big like this. And what that should do is it should block the navigation so that the skeletons will only go this direction. So let's go ahead and hit play, and let's see our logic work. So as you can see, the skeletons will only go for the forward attack. They won't go behind the keep because we blocked the navigation. So that is our very simple map. We created our island map that features a custom landscape, some unique props, and our tower defense game mode setup. So now that we've finished creating the level for our game, we're going to be creating a main menu so that when we play the game, this will be the default main menu, and also a level selection, so we can select which level we want to play. In our case, we only have this one level, but you can add more levels if you want and create different levels, add them to the level selection window. And also our main menu will feature things like a options menu to change things like the graphics. So let's go ahead and get started. So first things first, we need to go to File and New Level to create a new level, and we'll select the basic template and click Create. And we want to do a file, save current level. So save current level as, and let's go to our maps and save this as our main menu. So now that we have that saved, let's go ahead and modify our level. So first, let's delete this floor and add a landscape. So go to the landscape mode, and for our landscape resolution, I set this to 64 by 64. So the absolute smallest landscape that we could create, and go ahead and click on the create. And then for this, we can select our landscape and let's apply our landscape material. So let's go to our materials and drag and drop our MI material instance onto our landscape material. Let's go into the landscape mode and go to the paint mode and select our sand dry and select down here for our none, select our sand dry layer info, and that will apply our sand dry to our landscape. Then we can go out of the selection mode. So for our main menu level, let's take our player start and let's move this up. We're going to create a little main menu background so that when the player hits play, they have the play options on the left, but on the right, they can see basically their character and some props just to have a nice background. So let's go to our meshes. So go to the cargo geometry folder and we're going to look for the dock mesh. So we should have this big dock mesh right over here. So just drag and drop that in the level and rotate this over like so. And let's move this over. But this will be our main dock area. Then we're going to drag in a couple of buildings. So let's drag in this building over here and move this up and over, and let's drag this other building and move this up and over like so. And I'm just going to line these up like that. And then we can get some various different props and drag them on the dock. So we have things like these crates. We can rotate and move that like so. And we can drag in some barrels in here as well. So let's take these barrels and rotate these and move these up. And then we can add in as well some palm trees. So let's take one of the palm trees that we have here and move that over there. Rotate this. And we could just move this down so we could see it better. Okay, so maybe something like that. And you could add more different props that you want. So maybe some of these bags right over here. But just decorate it to your liking. And I'm going to select everything and move everything up so the dock is above the ground like that. And if we wanted to, we could also add in some rocks and other different megascans. So go to our megascans, 3D assets. We have some of these beach rocks in here, so we can scale these up and move these over. And we also have this other beach rock. We could also scale this up and put that over there. Oh yeah, that is our simple main menu background. Now let's add in our characters. So let's get our character mesh. So let's go to our core animations, and in here let's right click and create a new folder for main menu and double click open this up, and in the project files we'll have a custom animation for our main menu. So go ahead and open up the project files, and in the main menu folder we have this emote underscore spit. So drag and drop that, and under the skeleton we want to select our pirate skeleton. So select at the very bottom the UE4 mannequin skeleton and click import. And now we should have that imported. And what you'll want to do is drag in your pirate skeleton, or your pirate character. So go to the pirate folder and go to the mesh UE4 full and drag in the SK pirate full. And let's rotate this. And in the details with this selected, we can use a animation asset and change this to our emote spit. So now if we hit play, you can see that we have this basic little emote or animation for the pirate character. Now we're also going to make a main menu pawn so that we're not playing it as the third person character. But for now, we also want to add a weapon to this player's hand. So to add that weapon, you want to go to your pirate and go to our meshes folder. So mesh weapon and drag in our SM pistol. And then take that SM pistol and we want to drag it and drop it on top of our pirate SK full. So it looks like cannot attach actor with static mobility to actor with movable mobility. So all we have to do is select the pistol, set that to movable, and then we can drag and drop it on the pirate SK full, attach it to the weapon socket, reset the location and rotation. And that should be good. So now if I hit play, you can see that we have our basic animation with our weapon. So let's go ahead and work on our main menu pawn. So let's go to our core blueprints and create a new folder for main menu. So double click, open that up. We'll need to right click and create a new blueprint class of the type pawn and name this to BP underscore main menu pawn and save that. Also, we need to right click and create a new blueprint class for our game mode. So select the game mode base and name this to game mode underscore main menu. So do a file, save all. Let's select our main menu game mode, open that up. And in the classes, we can set the default pawn class to our BP main menu pawn and compile, save. And then we can go ahead and go to your window world settings. And over here, select our game mode override and change it to our game mode main menu. And then it should automatically assign our main menu pawn as the main menu pawn. So if we hit play, this is what our main menu will look like. It will just be a pawn that we cannot move around, and we'll have to work on showing a widget as well as showing our mouse cursor. That way we can click on different main menu buttons. But also let's take the player start and we can move it up forward, right up to the character. But let's work on our main menu pawn. So double click and open up your BP main menu pawn. So in here, we're going to add a simple capsule collision. So search for capsule collision and add that and select it. And we'll scale this up to 2 by 2 by 2. And then onto that capsule collision, we'll add a camera component and move this up. And now let's go ahead and test this out by hitting play. And so this is what our POV will look like. And we can modify that point of view by adding in a cube. So let's go to cube plus icon and add in a cube below our player so that it will rest on top of this cube. And then we can move it back or forward depending on where we want the player to see. So I'm going to go ahead and move this down and move this back. Okay, so something like that. So I think that looks good for now. We can play around with the positioning of our character more later on. But now we need to go and create our main HUD. So let's go to our core widgets and create a new folder in here for our main menu. Double click, open this up, and right click and create a new user interface widget blueprint of the type user widget and name this to W underscore main menu. Do a file, save all, and double click, open up the main menu. Search in our palette for a canvas panel and just drag and drop it onto our main menu like so. Then we want to go to our widgets textures folder and we're going to import some textures. So go to your main menu folder in the project files. And then in the textures, let's right click, create a new folder for level art. Double click, open this up. And we have these level art icons. These are basically just placeholders for the different levels that we'll create for our level selection. So save that. Right click, shift select all those and do a asset actions and do a edit selection and property matrix. Let's select all these and change the texture group from world to user interface and save that. Then the other thing we want to do is import these other icons. So we have the background, main menu banner, and pirate game.png. So shift and select all those and drag and drop those in the textures and do a save all. We can also, in our widgets, add a new folder for font because we're going to import this font, the pirate font. So drag and drop that in the folder. It's going to ask us, would you like to create a new font using that font that you imported? Click yes, and just do a file, save all. So we have some font, we have some main menu icons. Let's shift select these main menu icons and right click asset actions, edit selection, select all that and change the texture group from world to user interface and save that. So now that we have that set, we can go to our main menu, and in our main menu we want to add first a border. So search for border and drag and drop it like so. And I'm going to anchor this to the left. So the left side all the way around. I chose this anchor. For the position, I set this to 0, 0. And for the size X, I set this to 712. And then 0 for the offset bottom. So basically, it should cover this left side of our screen. And then for the content, so for the brush, expand this and search for our background 2. So this background 2. Now I gave this background a tint. So under the brush tint, I set the alpha to 0.9, just so it's a little bit transparent. So that is our background. Let's go ahead and add the rest of our main menu. So search for a vertical box and drag it onto that border. Select that vertical box, and we're going to set this to center align horizontally, center align vertically. Then in that vertical box, we'll add a size box. Into that vertical box, select the size box, and we'll set this to a width and height override of 400 by 300 pixels. Into that size box, we'll add an image and select that image, and under the brush, we can search for our main menu banner. So it just says Pirate Game like so, and compile and save that. And then next up, what we want to add are some buttons. So search for button and drag and drop it into the vertical box. Select this button, and we're going to give this a padding of 10 all the way around, but then we're going to change the padding for the top to be 50 for just this particular button. Then we can add a text onto the button. So search for text and drag and drop it like so. Select that text. We're going to set this to play a game. We'll set the font family to our pirate font, and we'll scale the font size up to 49. Then let's select our button and change the button style. So under the style, let's expand that, and under the normal, let's expand that and change this to a dark gray color, like so. And we can copy this for the normal and paste it for our hovered and pressed. But for our hovered, we can change this to sort of a yellow tint. And then for our pressed, we can change this to maybe a green tint. So just compile and save. And let's copy and paste that button in our vertical box 2 more times. Select this top button and change the padding to 10 on the top. Select the bottom one and change the padding to 10 as well. Then the center one, we can select the text and change this to options. And the bottom one, we can select the text and change this to quit game. And one thing that I need to do is select this vertical box, and I set a padding of 20 on the right, and also select the size box, and I believe I need to set the width override to 480, just so it's a little bit more wide, but that should be good for our main menu. So save that, and then let's go to our BP main menu pawn and head over to the event graph, because this is where we'll initialize the widget and create it. So delete everything other than the event begin play. Off the event begin play, we'll do a sequence. So the first thing that we'll do is we'll create the widget. So we'll do a create widget. And we want to create that W underscore main menu widget. For the owning player, just get player controller at index 0. And then take the return value and promote that to a variable and name this to our main menu reference. Then lastly, off of there, drag and drop and add to viewport to add that widget to our viewport. And then we can right click and get our player controller. And we want to set the input, so set input game and UI. And also off of here, do a set show mouse cursor and set that to true. So let's compile and save that. And now let's hit play. And now we should be able to see our main menu widget. So we have our play game, our options, and our quit game like so. And we have our little pirate character right here in the center. I might actually move this over just a little bit, but other than that, I think that we have everything positioned pretty well for our main menu. So we created our basic main menu level. Now let's go ahead and actually program in the main menu widget. So we'll need to set up the play game to open up a simple widget for our level selection. So in order to do that, we'll need to open up your widget main menu widget. And in here, we're going to hide everything. So unexpand the border, and we're going to add another border into our main menu widget. Just drag it onto the canvas panel and let's size it up and drag it into the center. And for this, we want to anchor this to the center of our screen. Let's reset the position X and Y. And for the size, we'll set this to 1080 by 720. And set the alignment to 0.5 by 0.5. So it should be in the center like so. So just some sort of rectangle in the center. And scroll down till we see the brush appearance. We want to change the tint to a dark black color, and we want to change the alpha to 0.5 so it's transparent, and click OK. So this will be our level selection widget, and onto here we want to add a vertical box onto this border, and select that vertical box, and onto that vertical box we're going to add some text. So drag and drop it onto there. Select that text, and we'll set the text to text align center, and we'll set the font size up to 48, and we'll change the text here to select level, and then we're going to add a size box onto this vertical box, and select that size box and set this to a width and height override of 600 pixels by 500 pixels. So it should fill the space just like that. Onto that size box, add a scroll box. Onto the size box, select that scroll box, and now that it's in the size box, we want to select the scroll box and always show scroll bar, just like that. And under the scroll, we can change the scroll bar thickness, so you can increase it. I set it to 20 by 20. And we can also select this, and we're going to change the orientation to horizontal, so it's here at the bottom. Then into that scroll box, we're going to add a size box. Into the scroll box, select that size box, and we're going to set a width and height override of 200 by 200 pixels. And we'll set this to center align horizontally, center align vertically. And we'll give this a padding of 20 all the way around. So this will be our simple level selection widget. So add a button into that size box, and onto that button we can actually expand the normal and hit the drop down and search for level. So we'll select the level 1 icon and copy and paste that for the hovered and pressed. But for our hovered, we're going to give this a tint of a yellow tint, and for the press we can give this a green tint. So compile and save, and then onto that button we can add a text onto the button, and select that text. We'll set the text to align, bottom align vertically, and we can rename the text to level 1 and compile save, and then we can copy and paste the button or the size box in the scroll box a couple more times. So I pasted this 4 more times, so it should have a total of 5 levels, just like that. And we have the scroll box that will scroll based on whatever level we select. So this first level over here is level 1. The second one, let's select this, and in the normal we can change this image to level 2, and hovered we can change it to level 2, and press we'll change it to level 2. And let's also select the text and change this to level 2. Select the next button. Again, we want to change the normal hovered and press to level 3, level 3, level 3. So we're just changing the icon for each one to match the level. So we have level 4, and level 4. And we can change the text as well. So we have level 3. Change the text over here to level 4. And then the last one will be our last level, level 5, like so. And select our text. This will be level 5. And I believe that is all that we need to do. So that is our simple level selection widget. Let's go ahead and add a couple of more buttons. So select this button over here. We have the button, the play game button. Copy and go back to our border, our vertical box. Right below our vertical box, we can paste onto that button. And actually we want to add a horizontal box, so delete that and first search for a horizontal box and drag and drop it onto the vertical box. So it should be down here at the very bottom. Set that to fill, and then paste that button over there and paste it again. So we should have 2 of those buttons. Select the first button over here, and we'll set this to auto, and for the padding we'll set this to 20. And then select the other button, and for that button we'll set this to align, right align horizontally, set that to fill, and give this a padding of 20. So it should look exactly like that. Select the text over here. This will be our back to menu button. And this right one will be our play level button. So compile and save. So now we just need to go ahead and name our buttons and set up the logic for hiding or showing our level selection or our main menu. So let's go ahead and do that now. So first things first, let's unexpand everything and hide this border. Let's first work on this main menu over here. Let's select the button. So this is our play game button. So in the details, we'll rename this to play game button. And select the options. This will be our options menu button. And the last one will be our quit game button. Then select this border and set that to a variable and rename this to our main menu HUD. Then select this other border down here, and this will be a variable as well, and this will be our level select. Then let's show our level selection, and we're going to select all the buttons and rename those. So we can select this button down here. This will be our back to menu button. Then this other one will be our play level button. Then for our level buttons, we can rename those. So this will be our level 1 button and a level 2 button. So once you have all of those renamed, we can now set up the logic for hiding and showing the widget. And so by default, we want to select our level selection widget. So this widget right here. And in the details, we want to set this to hidden by default so that this level selection will be hidden from our screen by default. Now we're going to select our main HUD, our main menu HUD right over here. So this widget. And we're going to add a little animation for it to fade out when we click the play button so that we can show our level selection and fade this out. So under the animations, we're going to add a new animation to fade out. So with the main menu HUD selected, go to your animations and add a new animation and name this to fade out main menu. Select that and add a new track for our main menu HUD. Because we have it selected, it will allow us to add that. And then with that selected, we can add a new track for render opacity. So render opacity will change basically its transparency. So as you can see, it added a key on this timeline and the value is 1, which means that it's transparent. So move this over to time the seconds to 1 and change the value from 1 down to 0. And now what you should see is it fades out. So just phase out like this, and also drag this over to 2 seconds and add another key. So click on this key and that will just increase our animation to be 2 seconds in length. So now this is what it will look like. It will just fade out. So compile and save. Now let's head over and we can actually select anywhere off of our animation. So just select off of that and it will stop playing the animation. But let's head over to the graph and set up our button logic. So delete all these events. And we need to add a on clicked for our play button. So add it on clicked, actually on pressed for our play game button. And also our options menu button, add it on pressed. And our quit game button, add it on pressed. So these are all the buttons for our main menu HUD, our play game, options, and quit game. So for our play game, what we'll do is we'll play that animation. So over here, we're going to get our fade out animation. So expand your animations and we should see that fade out main menu animation. Drag and drop it on the graph and drag it and do a play animation to play that widget animation. Then we can do a delay. We can wait for about 1 second. And after it's done playing that animation, we can get our level select widget. So we should have the level select border. Drag and drop it, get it on the graph and do a set visibility. We want to set this to visible. So now let's test this out. Let's hit play. Click on our play game. We should see our level select pop open like that. Now we need to set up the back to main menu. So when I click back to main menu, it will hide our level select and show our main menu widget. So let's select our back to main menu button. So we should have our back to main menu button, add a on pressed for that. And I'm going to move this up here. Basically, we want to copy and paste our play animation. And we want to do this in reverse. So that will fade back in. And then also we want to set the visibility of our level selection widget to hidden. So compile and save. And now if I hit play, if I hit the play game button, it will fade in our level select. Click back to menu, it will fade back our main menu HUD. So that is our very simple play a game and level selection widget to transition back and forth. Now let's add in the other different buttons as well. So for our on pressed, for our options menu, we're going to create another widget for that later on. But for now, we'll just leave that as is. For our quit game, we want to do a quit game. So that will just quit the game for the player. But now we want to set up things like our level selection widget. So in the designer, let's show our level selection widget. And over here, we're going to select our button. And we'll give our button a little bit of animation. So when we click it, it will just show that we pressed it. So under the animations, let's select our first level and add an animation. We'll name this to level 1 anim. Select that and add a track for our level 1 button. And add a track for transform. So then for our transform, what we can do is drag this to 0.2 seconds. So 0.2 seconds. And take our transform and scale this up. And expand the scale. And change this to 1.5 and 1.5. So at 0.2 seconds, it should up the scale from 1 to 1.5. Then go over to 30 seconds, 0.3 seconds. And change this to 1 for the X and 1 for the Y for the scale. So basically we should have this very simple press animation. So compile and save, and we can select off of that animation. And head over to the graph, and when we click on the level 1 button, we can add a on pressed for that. So basically when we press that button, we can play our level 1 anim. So get that and do a play animation. And we can play that animation, and whenever we select a button, so when I click on the button, we want to set our selected level. So we want to add a new variable and name this to selected level. And change this to a name. Compile and save. And we want to set this whenever we select one of our levels. So in our case, the levels 1 button, we're going to name this to the map name that's associated with this level. So since we only have one map, we're just going to name this to Shipwreck, because that is the level name of our level that we created in our maps called Shipwreck. So compile and save. And then once we have our level selected, we want to add a on clicked for our play level button. So add a on pressed for our play level button. And all that this play level button will do is we're going to open level by name. And for the level that we're going to open, we're going to plug in our selected level name. So compile and save. Now let's test this out. So if I hit play game, that will show our select level. If I click on level 1, it will play the little animation. And I can click play level. And as you can see, it opens that level that we selected. So that is our very simple level selection widget. You can go in and animate every other different button, but I'm not going to do that just for the sake of time. And also you can create additional levels and assign the names. That way we can have references to opening that level. And so when you select it, you can play the level, or you can hit back to menu to go back to our main menu. Alright, so in our previous lecture, we created our play game and our level selection. What I want to do is, I don't want our level selection to just be shown on the screen. What I want to do is add a very fancy camera transition, so that when I'm hitting play and I click on my level select, our camera will move over here, and it will show our level selection widget. So the way that we'll do that is we're going to add an additional camera into our main menu pawn. That way when I click on level select or play game, it will move and transition to that camera. And if I click back, it will transition back to our main menu. So it'll sort of give us this 3D effect that we're clicking on different menus and it's moving our camera in the game. And it's not just static. We're not just staring at our character the entire game. So the way that we're going to add that is we'll need to go to our blueprints main menu, open up your main menu pawn, and in the viewport, And in here, we're going to add another camera. So add another camera component and drag and drop it on the capsule. So we have camera 1. And basically, we're going to position this based on where we want it in the level. So let's go into our main menu level and add the Q+ icon, search for camera, and drag in a simple camera actor. And this will allow us to preview what the camera will look like in the bottom right. We just want to get the basic positioning. Doesn't have to look super fancy, but this should do for now for our position. So now we can drag in our BP main menu pawn right here. And let's drag this up. So this is what our main menu pawn will look like when it's spawned in. We just need to modify this camera position to line this up with the position that we chose over here. So to get this to be over here, all we have to do is select this main menu pawn. In the details, we can select the camera 1 location. And if I move this over, you can see that I can move this camera 1 over. So because we're selecting it in the details, we can move it over. And now all we have to do is line this up and rotate this like so, and move this to sort of line up with the camera that we have placed in the level, and move this over and up. And then we can just right click and copy the location and head over to our main menu pawn, select the camera and paste that location. And also we need to copy the rotation. So let's copy our rotation over here, go to our main menu pawn and paste that rotation. So now we have the exact positioning set. So compile, save that. And then let's go ahead and delete this pawn. So select the main menu pawn and delete that camera as well. But if we drag and drop this back in the level, you can see that it's saved that camera positioning over here, which is what we want. But now we have 2 camera positions, so we can toggle between the 2 camera positions. So delete that, we don't need that in the level, so save that. But in our main menu pawn, let's head over to the graph, and we can set up the logic for transitioning between those 2 cameras. So the way that we'll do that is, first we're going to get our camera locations and save them. So let's get our first camera, and then get our second camera, camera 1. For the first camera, we're going to get the world location and take that and promote that to a variable and name this to our start cam location. And let's hook this up for our sequence, so our then 1. We also want to get the rotation, so get relative rotation, and we'll save that. But also our camera 1, we want to get the world location of that camera and promote that to a variable. This will be our end cam location. So the end location. Then take the relative rotation and promote that to a variable. This will be our start rotation. And then off of our camera 1, we want to get relative rotation as well, and promote that to a variable. This will be our end rotation. And drag that over there. Now we just want to add an interface to call an event to transition between our start location and end location. So let's go to our blueprints, interfaces, right click, add a new blueprint interface, and name this to our BPI underscore main menu pawn. Double click, open this up, and we'll add a new function in here named set active cam, and then add another function and name this to set main menu cam, and compile and save that. And let's go to our BP main menu pawn class settings. In the implemented interfaces, we can add that BPI underscore main menu pawn, compile, save, and we have those 2 interface events. So double click and add both of those events. And we'll just need to add a timeline. So right click and search for the timeline node, add timeline. And for our set main menu cam, we'll actually move this up. So our set active cam will be our play from start. Set main menu cam will play this from end, reverse from end. So double click, open this timeline up. We'll add a new float track, and this will basically tell us how long should we take to transition from our start camera location to our end camera location. So in here, we're just going to right click on the graph, add a new key, select that key and set the time and value to 0, 0. Then right click anywhere else on the graph, add another key, select that and set the time to 1 and the value to 1. Then we can zoom fit horizontal, zoom fit vertical, and this is what our graph looks like. Lastly, change the length to 1 second, and we should have this straight value. So we have a 0, 0, and then at value 1 is value 1. So we'll take 1 second to transition from our original cam location to our new camera location. So head over to the event graph. Now we're outputting this float value from our timeline. And now what we can do is set the rotation and location of our camera. So we're going to get our camera position over here and do a set world location and hook this up for the update. And for the new location, we want to do a vector interp 2. So what the vector interp 2 node does is it interpolates between two values. So it gives sort of like this smooth transition from one location to another location. So for the first location, that will be our start camera location, our starting point. For the target location, that will be our ending location. So plug that in for the target. Then for the delta time, we just plug this into our timeline. And for the interp speed, that will be 1 second. We want to do the same thing for the rotation. So select our camera and off of here do a set relative rotation. And for the new rotation, we can also do a R interp 2 to interp between two rotator values. So for the current location, that will be our start rotation. For the target rotation, that will be our end rotation. Then for the delta time, just plug in our track from our timeline like so. So now, when this gets called, all that is doing is it's interpolating from our start location, setting the world rotation of our camera. So every frame, it's updating the location and transitioning from our start location to the end location and our start rotation to the end rotation. So now we just need to call these interface events from inside our main menu widget. So you want to go to your core widgets main menu, open up your W main menu widget. And basically when we click on the play game button, so let's go up to where we click on the play game button over here. We can, before we play our animation, move this over. We can right click and get owning player pawn. That will get the player pawn associated with this user interface. So this is the back to main menu. So we want to call our set main menu cam interface message. So that will set it back to the main menu. And then also down here for our play game button, we want to set active cam message. So this will play the timeline from the start. This one will play the timeline in reverse to reset it. So now let's go ahead and test this out. So if I hit play, if I click play game, that will go ahead and rotate and go back like so. And it looks like our rotation is not really transitioning that well. So let me go ahead and head over to our BP player pawn. And that is because we didn't set the interp speed. So you want to make sure that you set the interp speed to 1 for our rotation. And now let's hit play. And if we hit play game, you can see that it rotates like so. So we have our play game and it fades out and shows our level selection and our pirate game like so. So it's just a very simple transition into our select level and our main menu widget. So that is it for this lecture. We just added a nice smooth transition between the two cameras to show our level selection widget and also go back to our main menu to show our main menu options. So we set up our level select widget, which will show our level selection when I hit the play game. Now what we want to set up is our options menu that will show the options and graphic settings for our game. So we're going to create the options menu widget. So we'll need to, in our main menu folder, right click and create a new user interface of the type user widget. and select user widget and name this to W_options menu. Double click, open this up. In here, we're going to add a size box onto our options menu. And for the size, we're not going to add any width or height override, but onto that size box, we'll add a border. And select that border, and we're going to change the brush to our pirate game image. So this image right here, which is what we imported from our project files. Then we're going to add a background blur on top of that image, or on top of that border. Select that background blur and give this a blur value of 10. So it'll just blur the background. Then onto that, we'll add a border onto the background blur. Select that border, and we'll set this to fill or center align horizontally, center align vertically. And we're going to give this a tint of a dark black color and an alpha of 0.69, and click OK. And then onto that border, we'll add a vertical box on top of that, and then select that vertical box, and in there we'll add a text. And then select that text, and we're going to size this up to 128. And rename the text to options. And I'm going to set this to regular for the font type, and we're going to align text center. So compile and save. Then onto that options, we're going to add a size box. So search for size box and drag and drop it on the vertical box. Select that size box. We'll give it a width and height override of 1000 pixels by 500 pixels. There's our options. And then we'll add a scroll box onto the size box. And select that scroll box. We'll set this to always show scroll bar. We can increase the scroll bar thickness. And then we're going to add some buttons. So first add a horizontal box below onto our vertical box. So should it be below our scroll box down here. And then onto that horizontal box, we need to add some buttons. So I'm just going to copy our buttons from our main menu. So open up your W main menu, select our play game button. We can copy that, head back over to the options menu and paste it like so. So select that button, and we can set this or reset our padding and just copy. Let's actually just give this a padding of, say, 10 all the way around, maybe 20. And copy and paste that, and select this other button and set this to right align horizontally and set that to fill. So select this first button. This will be our back button. Select this play game button. This will be our save settings. So compile and save. Those are two buttons right there. And let's go ahead and rename everything thus far. So select this button, and this will be our back button. Select our save button, and this will be our save settings button. So now we need to add the graphic settings that will populate our options menu. And so to do this, we're going to create a separate widget that will be for each individual graphic setting. So we'll need to create that widget, and also we'll need to create an enumeration for each graphical setting. That way it will be a lot easier the way that we create this. So let's go to our blueprints and right click and create a new folder for enums for our enumerations. Double click, open this up, and we'll right click and create a new blueprint enumeration down here. And this will just be called e_graphic setting. And double click, open this up, and add a bunch of new enumerators. And so these are just going to be the different graphic settings that we're going to have. So the first one will be called shadow quality. The second one will be our view distance. The next one will be our anti-aliasing. The next one will be our post-processing. Then we have our textures. Then after that, effects. Then add a couple more. This will be our foliage quality. Then add another one. This will be our shading quality. Then add another one for our global illumination quality. Then add one last one for our reflection. So those are the different settings that we have. You can add some more depending on what you want. Well, those are all the main ones. So we can close out of there, and let's go back to our core widgets main menu. And we'll need to create a new widget for the individual graphic settings. So right click and create a new user interface of the type widget blueprint and of the type user widget, and name this to w_graphics settings. So double click, open this widget up, and in here we're going to add a simple size box, and select that size box, and onto it we're going to add a border and drag and drop it like so. And with that border selected, we're going to set this to top align vertically, and we'll give this some padding. So I changed the padding down here to 10, and for this padding up here, expand this, and we're going to give 10 padding on the top. Also change the fill screen to desired on screen, like so. Compile and save, and then onto that border we want to add a horizontal box onto our border, and select that horizontal box, and onto there we're going to add a text. So drag and drop a text. We're going to change actually the background of our border, so select first our border, and for our border change the tint. We're going to change this to a gray color or gray tint, like so. Click OK. And so we should be able to see the text now. So select that text, and we're going to change the text to shadows. So this will just be a little preview of what our text will look like. And we're going to set this to left align horizontally, like so. And then onto that horizontal box, we'll add some buttons. So let's actually just copy our buttons over from our options menu. So select our back button, copy that, and go back to our graphic settings and paste that. Select the text on that. We're going to reset our text back to our default font, and we'll change this to bold. And we'll change the font size down to 25, and select our button and reset the padding like so. Select this text. We want to center align that. So make sure that's center align. Then select this button, and we'll center align horizontally, center align vertically, and we'll add some very simple padding, not too much, but this will just be 4 padding on the top, on the left, 2 on the top, 4 on the right, and 2 on the bottom. Then select the button, and in the normal we can change the tint to maybe sort of a blue color like that, and that should be good. Compile and save, and let's copy this button and paste it 3 more times. And select the text. This will be our low. Select this next text. This will be our medium. And then select this one. This will be our high. And then lastly, select this last button, and this will be our ultra. So you can change the tints of the buttons. So if you wanted to make this, low, it can be blue, medium can be maybe, a yellow color or something like that, or red color. You can also change that as well. So high could be like a red color, and then ultra could be, purple or pink or something like that. It's totally up to you how you want to set up your graphics. But that should do for now. So those are different buttons there. Now we just need to set up the events. So let's select our button and rename our buttons real quick. So this will be our low button. Then we have our medium button. Then we have our high button. And then our last button, which is our ultra button. And compile, save, and head over to the graph and delete all these nodes. Compile, save, and in here we want to add one variable and name this to our graphic setting. And we want to change this to our e_graphic setting, like so. We want to set that to instance, editable, and expose on spawn so that we can set this graphic setting in our widget. Also, we want to be able to customize things like the text over here. So the way that we'll do that is we'll add another variable in the graph and name this to graphic name, and change this to a text. Also set that to instance editable and expose on spawn, and we'll bind this text to this text value over here. So select that text, and in the details under the text we can bind that to that graphic name variable. So hit compile and save. And now let's head back to our options menu. And in our options menu, we should be able to, in our palette, search for our W_graphics settings widget and drag and drop it onto our options menu. And it looks like we'll need to play around with the settings. So go back to our graphics settings, select this button and set this to right horizontally aligned like so. And we'll set that to fill vertically. And let's see what it looks like. So now you can see that it pushes that to the very right. And also we can add some padding for our text. So let's go back to here, select our text, and on the left maybe we can add like 20 padding. And so that will be what it will look like. So I think that looks good. We can compile and save that. So we added our graphic settings. We can change the graphical setting. So this is shadow quality, and we can set the name to shadow quality. And we can basically just copy and paste this. So copy and paste this again and select that, and this will be our view distance, and rename this to view distance. And then copy and paste this again. And you want to do this for each graphic setting. So we have anti-aliasing, and just copy and paste this again. So all you have to do is select the setting and name this to post processing, and just go down and do this for each setting. So once you have done that, you set every single setting, that should be all good to go. Now let's just focus on actually showing this widget on our screen. So let's go to our main menu widget over here. And we'll first need to add a size box onto our main menu widget. So drag and drop it on like so. So it should be on the canvas panel. Select that size box, set that to a variable, and name this to our graphics widget box. Compile and save, and we want to anchor this all the way around and reset our offset left, top, right, and bottom so that it will stretch the entire screen. We want to set the Z order to 2, that way it will be in front of everything else. And then we can head over to the graph. And so when we click on the options menu button over here, we want to go ahead and create that widget. So first let's right click and search for the create widget node. And we want to create that W_options menu. Off of here we can get owning player to get the owning player. Then off of the return value, promote that to a variable and name this to our options widget. So this is our widget reference. But before we go ahead and create this, we want to get that options widget and just right click and convert this to a validated get and check and see if the widget is already shown on the screen. So if it is valid, we want to go ahead and remove from parent, which will delete it, and then go ahead and recreate it. If it is not valid, we want to go ahead and create the widget then. So that will be our simple setup. Then for actually creating the widget and showing it on the screen, we want to get our widget box, our graphics widget box. So get that box and add a child, and our child will be the options widget. So plug that in for the content. So compile and save. Then go into your options menu and select the back button and head over to the graph. We can delete all these events, but we can add a on pressed for our back button. So select our back button and add a on pressed. So when we press this, all we have to do is call the remove from parent, and then we'll go ahead and delete this options menu from our screen. So let's go ahead and hit play to test this out. If I click options, it will show our options widget, which will show us our shadow quality, view distance, anti-aliasing, post-processing. And I might change the global illumination quality text to just keep it shorter because you can see it's messing with the button. But if I click the back button, it will go back to our main menu widget. So all we have to do is, I'm going to fix real quickly that global illumination button. But as you can see, that is a very simple options widget that will show us all the different options and graphic settings for our game. Now all that is left to do is actually programming in, setting in the various different settings. So in our previous lecture, we set up our simple graphics widget, which will show us all the different graphic settings that we can change for our game. So we need to go ahead and program in the buttons, so that will set each individual graphic setting. And when we click the save settings, it will go ahead and save and apply those settings. So let's go ahead and get started. So we need to go to our options widget. So open up your W options menu and head over to the graph. And over here, we need to right click and search for the event construct. So this event construct. So when we construct this widget, we want to go ahead and load all of our graphic settings. So we want to use and call the node get game user settings. So that will get the game user settings. And then off the return value, you want to load those settings. So use the load settings node. Then we can start getting the settings. So off of the return value, we can get the shadow quality. And for each of these values, we want to promote them to variables. So take this and promote that to a variable and name this to shadow quality. And so we'll need to do this for each setting. So we want to get view distance quality. We want to get our anti-aliasing quality. We want to get the post-processing quality. And you just want to go down the list and get each individual graphic setting that we created. So we have texture quality. Then we have visual effects quality. And then we have our foliage quality. And then our global illumination. And then our very last one, which is our reflection quality. So take each of these and just promote them to variables. So once we have all the qualities saved and set, we're setting all those variables. Then what we can do is for each of the settings, we want to set the quality. So if our player selects on, say, the low setting for, say, our shadows, what that will do is it will go ahead and call an event in here to set the value of this integer, which is the quality, from a scale of 1 to 4. And that will set the quality detail. So we want to right click in here and add a custom event to set our individual quality. So call this set quality. And this will have two inputs. So the first one will be our e_graphics, our graphic setting. So this will be called setting. And the next one will be an integer, and this will be the actual quality. So then for our graphic setting, based on that, we can do a switch on eGraphic setting. And that will be based on the different setting that we select. We can set the quality. So for our shadow quality, all we have to do is set our shadow quality integer to that quality setting. And you want to do this for each quality setting. So set our view distance to our view distance quality. And basically just go down the list and set each quality. And so once you have plugged in each value like so, now we can just call this event whenever we select a particular setting. And the last thing that we want to do is we want to add a save and apply. So basically when we click on the save settings button, we can add a on press for that. And to save and apply the settings, we just want to, off of here, get a game user settings. And off of the value, we can do our set the shadow quality to our new value. So we want to get our shadow quality and plug that in like so. We want to get every single value. So get view distance quality. And we want to do a set view distance quality and set it to each value. So just want to go in and again, get each individual setting, get anti-aliasing, set anti-aliasing, and just set it to the value that we set. So once you have all those values plugged in like so, the last thing, most important thing is off of the game user settings, you want to apply the settings. And then off of there, you also want to do a save settings. So you want to call both of these nodes in order to apply and save. So take both of those nodes and plug this in like so. and that will just apply and save the settings that we created. And then also after that, we're going to do a remove from parent. And maybe we'll add actually just a little delay, do a delay of 1 second, so that we can apply our graphics settings and then remove this widget from our screen. So now all that is left to do is to call this set quality setting from inside of our individual graphic setting widget. So the way that we'll do that is through an interface event. So first let's go to our interfaces, content, core, blueprints, interfaces, and open up our main menu pawn interface. So in our main menu pawn interface, we'll add an interface event to set the quality. So add a new function and name this to set quality setting. And we'll have the two inputs, the same two inputs, which is our e_graphic setting, which will be the setting, and then add another variable, which will be an integer, which will be the quality. So compile and save. And now let's go ahead and go to our widgets, core widgets, main menu, open up our wGraphics settings. So this is the individual setting. Head over to the graph, and we want to add on press for each of the following buttons. So add it on press for high, low, medium, and ultra. And let's rearrange this so we have our low, medium, high, and ultra. So when we press this, what we'll do is we'll call the interface in our pawn. So you want to right click and search for get owning player pawn. So that will get the owning character with this widget. So drag up here and set quality setting, call that interface message that we just created. And for the setting, that will be our graphic setting. So just plug that in like so. And for the quality, we'll just set the quality value. So for low, that will be 0. And for medium, we can copy and paste this over. For our medium value, that will be 1. For our high value, this will be set to 2. Copy and paste this again, and then for our ultra, that will be set to 4. So the graphic setting goes from a value of 1 to 4, or 0 to 4. So 0 for the lowest, 1 for medium, 2 for high, and 4 for ultra. So that will be the quality setting. And now we just need to set up that interface in our pawn. So let's go to our core, blueprints, main menu, open up our BP main menu pawn. And on the event graph, we can add that set quality setting interface. And all we have to do is get our widget and call the event to set the quality setting. So you just want to get your main menu reference widget and drag up here and get the options widget. Get the options widget. And off that options widget, we can call our set quality function. So this is our target is options menu. So plug in the setting and the quality. And it looks like we have a reflection quality there. So I can actually just delete that. That was actually a mistake. But now we should have that plugged in like so. And so that will basically just call the set quality event, which will set the quality in our options menu based on the graphic setting. And then when we click save and apply, that will save and apply that setting that we changed. So let's go ahead and test this out by hitting play. Go to our options menu and we can set low for all of our graphic settings. And click save settings. And now you can see that all of our graphic settings are set to low. And if we hit play game, play level, looks like the default map is our third person map. I believe we didn't select the level, but basically you can change the options, play the game, select our level 1 and click play level, and that will open up our default level. So that is our very simple graphics widget. You can go to the options and increase the graphics to ultra, or tweak them low. You could also add additional graphic settings to tweak things like resolution, full screen, and all that stuff. But for now, I think this is good because this will just give us a simple template and base template to work on, so you guys can add additional graphic settings and other things that you might find useful. Alright, welcome back. So in this lecture, we're going to show you how to add controller input to your pirate game. So basically what you want to use for this lecture is a controller of some sort. So I'll be using the Xbox controller. So I recommend you get an Xbox controller to test this out, because it'll be the easiest method for adding controller support for your game. You can use a PS5 controller, however you will need to download an external program, so I won't be covering that in this course. So again, I just recommend getting a Xbox controller because it is the easiest. It already is integrated into the engine. So all you have to do when you have that controller is get a USB cable or connect it via Bluetooth. So once you connect it or hook it up, what you should see in the bottom right is this input device has been connected. So that means that it detects that we have a controller hooked up to our game. And now we can actually start working on adding controller input to our game. So the first thing that we'll tackle is adding input to our widgets. So to add input to our widgets, we want to open up the main menu level. So open up your core maps main menu. Then we want to add input to our play game options and quick game. So the way that we'll add that is we want to go to the widgets and main menu, open up our W main menu widget. And then also we want to go to our core blueprints and go to our main menu folder and open up the main menu pawn. So in here, off of the event begin play, when we create the widget, we need to set the focus. So in order for our controller to navigate inside of our widgets, we need to set the focus. So off of our main menu reference, we can get play game button and set that for the in widget focus. So compile, save, and then if we hit play, if I have my controller in here, you can see that I can navigate up or down. And what you should notice is whichever button is highlighted, as you can see this is selected in this blue, you'll see that whichever button is highlighted is what my controller can press. So I have play game, options, quit game. You might not really notice it, but it's just right there on the corner. So because that button is focusable, we're setting the focus, and therefore it is what we have selected currently. So we have play game. So if I press the A button, you can see that it will open that up. But you can still see it's selecting those buttons over there. So we'll need to set the focus to our level selection. So go back to your main menu and head over to the graph. And over here, when we click on the play game button, we want to set the focus to our level widget. So our selected level widget. So we want to get our level 1 button and set the focus, set that as the focus when we click on our play game button. Then when we click back, if we click the back, we want to set the focus back to our play game button. So get our play game button and set focus back. So this is a very simple way of implementing controller input for your widgets. So if we go ahead and hit play, you can see that we have play game. If I press A, you can see that now I'm in here, so I can select which level I want. If I select level 1 and go over to our play level, that will go ahead and open up our level. So that is just very simple controller input for our widget. Then what we can also add is for our game, we want to go to File, Recent Levels, open up our Shipwreck level. And if we hit play, currently we should have actually some controller input already set up for movement. So you can see I have movement and input look around already set up for controller, and that's because it's already set up by default. And so to add more inputs for a controller, all you have to do is go to your core input and open up the input mapping context. So if you expand the move and the jump, as well as the look, what you'll notice is they already have defaults because that is what the engine comes with when you create a third-person template. It already adds inputs for jump, movement, and look. So you can see that the gamepad already has those inputs. But we'll just need to add inputs for our shoot, reload, and open up our buy menu. So for these, we can add just some simple inputs. So add a new mapping. So add a new action mapping for shoot. And for this, we can search for the gamepad right trigger. So we have gamepad right trigger, so that will be the right trigger on the gamepad. Then for reload, what we'll add is a new input, and this will be our face button top. So basically, if this is an Xbox controller, this will be the Y button, the top button. Then for our buy menu, we'll add a new input, and this will be our face right. Gamepad face button right, which is the B button on a Xbox controller. So save that. Now we have all of our inputs set up. We have our jump, move, look, shoot, reload, and buy. Now for our buy menu to actually work, what we'll need to implement is the focus. So we need to go to our core blueprints, third person character, event graph, and go to where we have our hide or show buy menu. So in here, when we set the visibility of the buy menu, over here we need to set the focus. So you just want to, off of the buy menu, get the button, get barrel item button, and set that in for the focus. So compile, save. Let's hit play and test this out. So now you can see I can move my camera around. I can shoot by using the trigger. I can reload by pressing the Y button. So let's go ahead and kill these skeletons real quick and reload our gun. And we have one more over here. Let's go ahead and kill this guy. And if I press B, that will open up the buy menu. And what you can see is it allows me to select either item because I set the focus like so. So I press A, that will spawn in the cannon. I press the trigger, that will spawn in and place that item. So we have all of our controller inputs set up. So all you have to do is add inputs in your input mapping context if you want to add controller support. And then of course set up all the widgets so that they have focus, so you'll be able to select them on a controller device. Welcome back. So in this lecture, I'm going to show you guys how to package our game and test this out on any other type of device. So first of all, to get started, we'll need to set the default maps and modes. So you want to go to your edit project settings, and you want to head over to the maps and modes. So basically the maps and modes will specify which map is the default map when you play your game. And since we created a main menu level, we want to specify that our main menu level is the default map. So under the game default map, we want to change this from our third person map to our main menu level. So go ahead and save that. Then what we can do is we can go ahead and actually package the game. So the way that we'll package our game is you want to head over to platforms, and under Windows, we can click package project. And then under the configuration over here, we have different settings. So currently we have development, which will package a development build of our game, which will be fine for the purposes of this video, but just note if you are packaging this game to upload onto Steam or to distribute, you'll want to choose the shipping configuration. But in our case, we'll just use the development for testing purposes. So once you select Windows, package project, it's going to ask you where you want to package your project. Now, if this does not pop up, if you instead get a message that says download the Windows SDK, in that case, you'll need to download the Windows SDK from Microsoft's website. Or another way of doing this is you can download the Visual Studio installer. And so what I downloaded was, I head over to Visual Studio Community. So I'll leave a link to this. You want to go to visualstudio.microsoft.com/community and download this Visual Studio Community installer. So once you have the installer, this is what it will look like. You'll have Visual Studio Community 2022, and it will ask you what components you want to download. So this is what it'll look like. And basically I went and checked the .NET framework over here for desktop development. And in the installation details, I enabled the Windows 10 SDK over here. Then over here in game development with C++, I hit the checkbox for that as well. So those are the two different things that I downloaded, the .NET framework and the game development with C++. And then of course in the .NET framework, we downloaded the Windows SDK. So once you click and install that, you'll click the install button down here, and that will go ahead and download the SDK, and it will download Visual Studio as well. And you'll need to restart your engine in your project after that. Well, once you have the Windows SDK downloaded, you should be able to go ahead and click on Windows Package Project, and you shouldn't get any issue or message saying that you need to download the SDK. So then all you want to do is find a location on your hard drive to package your game to. In my case, I'm packaging mine to my desktop and to a new folder. So just select that folder and I'll go ahead and say packaging for Windows. And you want to click on this show output log and then click this dock in layout. Then I'm going to take this output log and dock it here at the top. So this output log will just show us all the information about packaging our game. It'll give us various warning messages, error messages, if there's anything wrong in the packaging process. It'll tell us those issues and errors that we need to fix. And it'll prevent us from actually packaging the game because we'll need to go in and fix those errors. So anything in yellow like this is a warning. So you don't really have to worry too much about that. But anything in red is an error and it will prevent you from actually packaging the game. So you'll need to go ahead and fix it. Now, if you're doing this for the first time, it'll take quite a while to package. So it might take anywhere from 20 to 30 minutes, depending on your PC rig. And it will use a lot of processing power when you do this. So just note, you might want to take a little break and come back later when it's finished packaging. So it looks like we got an error here. So you can see error cook, unknown cook failure. But if you scroll up, you can see what the error exactly is about. So in our case, collision profile settings do not include an entry for water body collision profile, which is required for water collision to function. So whenever you get an error like this when you're packaging your game, you'll need to go ahead and just copy this error. So just select that and copy this and paste it into Google and basically find out why you're getting this error. So just Google the error message and likely the chances are someone has already searched up this error message. In our case, this has to do with the water body plugin. So we need to add an entry in our default engine.ini file. So to do that, you want to go to your content, right-click your content folder and go show and explore. And that will pull up your project content folder. So you want to go to your pirate game tutorial and to your config, and there we have the default engine.ini. So that's the exact file that it's talking about. You want to add an entry for your water body collision profile. So in your default engine.ini, over here, if you scroll down to the very bottom, we'll need to add an entry for our water body collision. So I'll leave this code in the description. Basically, this will allow us to have a collision setting for our water body. So this is the setting that we need. So just copy this, and down here at the very bottom, we can paste this into our script engine.collision profile and save that. And then we want to go ahead and restart our project. So once you've restarted your project and it looks like we're no longer getting this issue, so let's go ahead and do platforms, Windows, package project, and select folder, and let's show our output log. And it looks like we're not getting any more errors in here. But if you do get any errors, again, you just want to go and copy it and type it into Google and figure out why exactly you're getting this error, because it will tell you exactly what's wrong with your project. And you just have to look it up and figure out what exactly is wrong and fix that issue. And once you do, you'll have your game packaged. You won't get any errors when you package your build. So when you're successful, you'll see that it says packaging complete. We'll get the green check mark. And you can see down here that the build was successful. So you'll know that we were successful in packaging our game. And you'll notice that we'll have the folder wherever you saved it. So in my case, I saved mine on the desktop. So if you double click, open that up, we'll have a new folder for Windows. And then you can see this is our actual package game, or the exe file. So if you double click and run that, it will open up the game. So now you can see we have our pirate game. So we'll click allow access. And you can see we can click our options menu, we can go back, click our play game, select our level, click play level. And now we're actually playing our game here in our level. And you can see that we can run around and move around and everything.